Tēnā koutou, tēnā koutou, tēnā koutou katoa. Nā mai haere mai, ka Kawaiicon. Please join me in a karakia to start the day again. Ki hora te marino, kia whakapapa po namo te moana. Hei huria mā tātou, e te rangi nei, aroha atu, aroha mai. Tātou ie, tātou katoa. Hui e, tai eke e. No reira, tēnā koutou, tēnā tātou katoa.
Great, good morning everybody. Glad to see at least a subset of you managed to make it here this morning. That's good, that's good. So, how many of you have been to a Kawaiicon? Yeah. So I think Sput's asleep because, baby kept her up all night. It's not here, which means I think we can kick it a little bit old school. Yeah. You know what I feel like? I feel like a little heavy metal. And I feel like a little pyrotechnics, and I feel like some flames. Come on, squirrel, give me some flames. Matt, some.
Hey. Metal, we spoke about this.
No, I wasn't doing anything. I was just taking care of the audience. Got to wind them up. Give them a little bit of.
It's Kawaiicon, not KiwiCon. I will get the glitter. Okay, got to keep it on brand. It's cute.
But heavy metal.
Cute space. I will get the glitter out. Just. Yeah.
All right. I'll stay on brand, Spot. I'll stay on brand. I'll activate the brand. Cute. I think cute thoughts. Fluffy bunnies and puppy dogs. We had puppy dogs on stage. That's pretty cute. That's on brand. Anyway, good morning and welcome. We have a wonderful day of entertainment planned for you. There are a few items of administrivia that our fine script tells me that I should say. So, first things first, thank you for continuing to mask. Thank you for monitoring your own symptoms. We've had a few people who felt crummy yesterday, used the rat tests that are available in the venue, discovered that they were COVID positive and spreading it around, and have subsequently left, and are hopefully watching the live stream. So, thank you to those people for being responsible for looking after our hacker family. And if you are watching on the live stream this morning and you haven't picked up your merch, please ask one of your fellow hacker chums to pick it up for you. If you do want to pick up your merch desk is going to be open until afternoon break. If you don't pick up your merch, it's a real pain in Ad's ass because he has to go put it back in the lockup, and then the logistics crew have to deal with it all, and then getting it out to you later is a real pain. So please, help us out. Otherwise, we have to pay for storage for that stuff for the rest of time. And there is KiwiCon 2 merch going back a decade that we keep in a lockup somewhere, along with the sheep and the llama. Well, actually, the llama has a job now. Works a day job at Llama Engineering for all of your Datsun restoration services, courtesy of Mr. Bogan. Anyway, so yes, what else have we got? The videos will be available after the con if you want to relive any of your experiences or share them with your workmates or chums or other people who could not be here. So we will do that. Go participate in the CTF at HAL. Go investigate the lockpicking desk and have yourselves a good time. So our first speaker this morning, when you think about the history of InfoSec, one of the things that strikes me is that we invented computers to hack Nazis, which is pretty cool. And then the Cold War happened, and nuclear Armageddon threatened us. Unfortunately, that's not a thing that happens anymore. And the intersection of nuclear weapons and the Cold War and command and control systems for ICBMs and guidance systems for weapons and eventually the space program contributed to the development of computers and communications and miniaturization and all of the things that led to the crazy cyberpunk dystopia that we live in now. And when you think about the impact, of the Cold War and of nuclear weapons and nuclear energy on the development of InfoSec and development of hacking, there's very few people who are directly at the kind of intersection of both. And of course, it is my great pleasure to introduce to you a man who has spoken, I think, all but one Kiwicons ever. I think maybe you missed one, right? And then every other single one, we have had none other than the maintainer of many, many crypto things himself, Inspector of Nuclear Weapons, Mr. Peter Gutman.
Okay, so about a couple of years ago, I did a talk on the effects of faults on security, and what this talk is going to be is on dealing with those faults. So basically, in terms of faults, you've got random faults, overvoltage, undervoltage, spikes, electrical glitches, clock glitches, noise, thermal issues, and the one I talked about a couple of years ago, which was radiation, which was one of the ways of having faults. But more typically, you'd have electrical faults. And the nasty thing about these things, if you're using them to compromise the security system, is that it's entirely passive. You just sit there and wait. You watch the bits on the wire. If there's some sort of corruption there, then it's probably been caused by a fault, and then you can work backwards and use that as an attack. There's very few studies that have been actually carried out on the effects of these faults. So two of the ones I could find found that about 2% of faults in firewalls and FTP and in SSH had security implications. So there was some random fault. 2% of those caused security vulnerabilities. So those are random faults. But what if you're an attacker and you help that along a bit? All of those faults that I mentioned previously can be induced deliberately. So with hardware, you introduce voltage glitches, clock glitches, electromagnetic fault injection, where you put a huge electromagnetic pulse into the circuitry. And there's also software-based ones. You may have heard of rowhammer, causing bit flips in memory. And you can also do things like undervolt a motherboard. So, for power-saving purposes, they're designed so that they run as low power as possible. You undervolt it into the point where the circuitry is now working unreliably and cause faults in that manner. So you've actually got software support for hardware attacks on standard motherboards. And it's pretty much self-explanatory. So that's an example of an electromagnetic fault injection probe. So it's a software-controlled way of generating a very high voltage, high current pulse, which you then push through a coil and induce that inside the circuitry. So you take the target, you glitch it, you record the results, and you repeat until you get the effect you want. So that's an example. Obviously, it's just a test setup in that case of a Raspberry Pi that's being used for fault injection. So that red bit of the circuitry is the high voltage pulse generation circuitry, which induces those faults inside the Pi. A couple of years ago, it used to be pretty exotic stuff. So that one there is handmade. That's commercial off-the-shelf gear. So you can go out and you can buy one of these things. In that case, it's being used to break a Trezor hardware electronic wallet. So there's a series of devices. There's something called a chip whisperer, which does side channel attacks. And then there's a chip shouter, which does the opposite. It introduces faults into a circuit. And you can glitch data reads, you can glitch reads, you can glitch CPU operations. There's an example there of a chip shouter being used to glitch memory. So depending on the polarity of the pulse, you can either force bits to 1 or bits to 0, or at least more bits to 1 or more bits to 0. And these attacks are incredibly effective. This is a comment from a smart card, from two smart card researchers, one of whom was a white hat, who asked, what happens if you find a smart card, so some security circuitry you can't glitch? And the other one, who was very much a grey hat, said, I've never found anything that I can't glitch. Okay, so the way of dealing with this is you use fault-tolerant systems. And there's a lot of architectures designed for this. Typically, the terminology is X out of Y. So X out of Y units have to fail to get an overall failure. Incidentally, these slides have a lot of information on them, particularly the later ones, so I'll be putting them online later. You don't necessarily need to photograph the slides. They'll be available later. Standard systems are 1 out of 1. So you get a failure anywhere in that chain, and the whole thing fails. Then you've got fail-safe systems, so you don't want to have an accidental activation of something. So in that case, both systems have to fail to get an accidental activation. The opposite is high availability, so either one of those has to be working in order to get the correct activation. In other words, both systems have to fail in order to get an overall failure. And then there's a lot more complicated stuff like 2 out of 3, and you have voting, majority voting, stuff like that. The thing is, all of these require custom hardware. So if you go to someone and you say there's this theoretical probability of some faults that may affect security and we've got to completely redesign the hardware, that's really not going to fly. There was one variant that requires little to no custom hardware, and that's 1 out of 1D. So it's a standard 1 out of 1 system, and it's got a diagnostic channel. And what that diagnostic channel does, it detects a fault, and it resets or restarts. If you remember the talk yesterday about the AGC, where it does checkpointing and restarts from a safe checkpoint, that's an example of a 1 out of 1D system. So basically, you fail fast, detect a fault, restart from a safe point, and keep going. So the goal is to make general-purpose software 1 out of 1D. The way to do this is to use something called the Swiss cheese model of failure. It was designed by a guy called Professor James Reason, who's done a lot of work on the failure of complex systems. And what you do is you turn that on its head and turn it into the Swiss cheese model of failure prevention. So the way this works is defenses are imperfect. It's like Swiss cheese. However, if you've got enough layers of Swiss cheese, a fault has to go through all of those layers to get to actually become a serious noticeable effect. So in the case of the Swiss cheese analogy, all the holes have to line up exactly to get something that goes all the way through them. So you need to constrain the code and data flow in such a way that error propagation through all of those layers of Swiss cheese is highly unlikely. So basically you take the Swiss cheese model and turn it into a safety model instead. And again, the way to do that is something called design by contract. So it was introduced by this guy called Bertrand Meyer in the 1980s. The basic idea behind this is that each block of code has a precondition, so these things have to be met before you go into the code, and a postcondition. These things are satisfied once you exit that code. And in C, it's pretty easy to do that as a macro, just if this is met, fail, or if this is not met, fail. So there's an example. So you've got a function to do some, that's actually taken from some crypto code. And typically when you pass in, let's say, an integer parameter, that can have one of 4 billion values. So that first macro there, it says that instead of any one of these 4 billion values, if there's any corruption, it can have one of these 2 values. If it doesn't meet those conditions of having one of those 2 values out of 4 billion, then it fails, and it goes into a failure recovery. So basically, it guarantees that all the input parameters are expected. I mean, even beyond this, the fault tolerance, it's just good sanitation. And it also catches things like wild jumps into code, and it makes ROP a whole lot harder because you've got to have all the parameters set up correctly. You can't just randomly jump into a block of code, and it'll keep executing. So it's a fundamental building block for all of the later safety measures. So a common problem in C, it doesn't have any range checking. And you get problems with memory overruns from memcopy, memmove, something like that. So if you look at that function, the last parameter is actually an unsigned value, but typically it's passed an integer count value. So when you get any sort of corruption in that and it becomes negative, once you cast that to an unsigned value, it becomes a very large unsigned value, and then you get a memory overrun. And this has led to a lot of security vulnerabilities. You can make everything unsigned, but that doesn't really work because then it comes back and bites you in other places. So you basically create bounds checking functions. And again, you've got that precondition there that requires. So before every memory operation, you do a bounds check. This must be a short non-zero integer within this range, which means it's not going to be cast to a large positive value once it's unsigned and cause a memory overwrite. And you can do the same for enumerator types and bit flags and other stuff with a bit of macro trickery. And you can also use it to deal with compiler brain damage. So this is an example of LLVM. And what the C standard says, if you've got a case statement and there's no default at the end and you fall off the end, that's undefined behavior in C. So what the compiler writers have said, well, okay, it's undefined, we'll just generate a code jump into a random location in memory. So they don't have anything at the end of that function to catch values that aren't specified in that switch statement. So if you jump into that code with a value that's been corrupted or an unexpected value, it just does a wild jump into memory. Compiler doesn't produce any warnings, it generates code that fails when executed. Yep, C has no bounds checking. I've already mentioned that. It's a long-standing complaint. And you can, again, add macros to do bounds checking. So basically, we've got this block of memory. We're doing an operation here. Is that within this larger block of memory? And macros to do this. So there's an example from SSH packet assembly code. And again, packet assembly and disassembly code has led to a lot of problems with memory overruns and memory overwrites because it's really tricky to get right. So before each one of these memory operations, you do a bounds check to make sure that I'm still working within this packet rather than using some corrupted value that an attacker's passed me or a value that's been faulted to point outside that memory block. So you may be wondering, yeah, okay, it's C, why not just ditch C? Well, there's a reason why you need to use that. And to defend against faults, you can't have any hidden surprises. C is a high-level assembly language, so you know pretty much exactly what you're going to be getting from some source code. If you've got anything with complex hidden internals, polymorphism, dynamic dispatch, vtables, garbage collection, anything like that, you've got this massive complexity that can be affected by faults and where you have no idea what the compiler is actually going to be generating in terms of code. Really bad is even worse than that. Virtual machines, interpreters, just-in-time compilers, anything like that. You've got even more complexity that can fault with no control over it. So that's why all this is in C. Okay, safe loops. That's a standard form of a loop, counts to 10, passes the value 0 to 9 to that function. What if there's a fault? So now you're passing random garbage values to that function. So if that function happens to have these preconditions, then it'll catch most problems. But still, the other problem is that loop never terminates, because if you look at that loop, it does a comparison against the value 10. If that faults and becomes 100, it will just keep running until you get integer overflow and do God knows what. So, okay, you make the loop variable unsigned and use the less than rather than equality comparison. So you know that it's going from 0 to 10. Will this loop terminate? Yes, it will for a simple loop, but if it's a more complex loop, I mean, that's an example just for illustrative purposes. If that loop variable is the subject of very complex calculations, you can't really loop at that and say this thing will terminate. And even then, it may not work, which I'll get onto in a minute. What about that one? Will that loop terminate? You're following a series of pointers. I mean, it's supposed to terminate, but if there's corruption anywhere in those pointers, you're going all through random memory, and it will never terminate. So you statically bound every loop. So for most loops, you have a pretty good idea that this thing shouldn't run more than 10 times or 100 times or 1,000 times. For example, for a DNS name lookup, you're not going to get we shouldn't be getting 1,000 results, so you can bound it with a hard upper bound. So now you can guarantee that every loop terminates rather than running through all of memory. And again, some horrible macros to hide all that mess. Problem is, if you do that, the compiler will screw it up because you've got this hard upper bound of, let's say, 1,000 iterations and the loop bound of 10 iterations. So the compiler looks at it and says, well, 10's less than 1,000. I'll just throw away this upper bounds check and reduce it back to the original loop. So the way to deal with this is you have one variable counting up and the other one counting down in opposite directions, so the compiler can't figure out a relationship between those and merge them. And there's some more tricks. If you've got a loop that counts down anyway, then the other one counts up. So then you've got this horrible expanded form, all hidden by macros. So now all the loops are statically bounded, and we can guarantee that they terminate after a fixed number of iterations. Except then the compiler screws it up again. Now you may be wondering what could possibly go wrong with a loop like that. If you look at what GCC does to that, remember that's a less than comparison. It rewrites it as an equals comparison. So it's back to that broken, failure-prone loop that we had originally. It's x86, GCC ARM equals comparison, MIPS equals comparison. PowerPC is a bit of a special case because the architecture actually has a loop register which counts down, so you can see why the compiler would generate that code. RISC-V equals comparison, Spark equals comparison. Okay, you've got a delay slot there, so you've got the store after the branch operation because of the delay slot. But in every case, it's actually rewritten the loop from the safe bounded loop into the unsafe equals comparison, where if you get a fault on the variable, it's just going to keep running forever. So there's no known version of GCC that will actually compile that thing correctly. And there's a bonus feature in GCC. If you make it unsigned, it looks at it and said, well, this comparison is unsigned. It can never be less than 0, so I'll throw away that entire check. So it treats it as a signed variable for the equals comparison, which renders it useless. And then it treats it as an unsigned variable for the actual range comparison, which also renders it useless. Okay, what about the competition? That's Clang, again, equals comparison. Clang on ARM equals comparison. Intel C compiler, that sort of gets it right. It does an unsigned comparison for the signed and unsigned value. Visual C equals comparison. XLC, which is the IBM compiler, again, it's got a count register. That's a special case. Sun CC, the Sun compiler, less than or less than equal unsigned, it actually gets it right. So there exists at least one compiler on at least one machine which gets this correct. So again, you now need to do so. This is why it has to be in C, because you need to know what the compiler's doing. So you add a loop invariant inside the code. So inside the loop itself, there's another check to make sure that it's within range. And if you look at, for example, real-time control, the real-time control world, you've got these safety standards like IEC, electrical substation control standards, and they say you need to compile with optimization disabled for exactly this reason, so you know what the compiler's doing to your code. So in GCC, if you disable optimization, does it fix things? Yes, it does. It actually gets it right, but the resulting code is pretty bad. What if you get a formally verified compiler which is guaranteed to produce code that has the same semantics as the object code, the same semantics as the source code? There's a compiler called CompCert, which if you've used it, it's developed in France, and it's also a very good way of getting people to swear in French if you've ever tried to use it. And And that gets it right. The problem is it has really bad code generation. So it's basically the same as GCC without optimization. Okay, well now we know or hope we've got to the end of the loop okay, but what happens inside the loop body? If the fault happens inside the loop body, you can go through X amount of times, which is not the same as the amount of times you're supposed to go through it. So for example, in that code, it goes to 10. If there's a fault, it bails out at 7. And as far as that code's concerned, all the preconditions and postconditions are met, but it hasn't executed it enough times. And this is great for glitch attacks. So this is a standard glitch going back at least 30 years. You glitch password checking loops. So that's an example of some code to check a password, and it does it correctly. It checks every value in the password rather than bailing out once you get the mismatch, so you can't guess the password a character at a time. And so what you do to glitch that is, once you get to that last instruction, the branch instruction, you send in 2 clock pulses instead of 1. The program counter is a simple bit of circuitry, so it steps twice. The CPU is a complicated bit of circuitry, it steps once. So effectively, it steps past that loop, and you've only got to get 1 character of the password rather than the entire password. There's a long history of this. So this is a 1990s thing called an unlooper. It's based on, it's a DOS-based device, or at least you control it via DOS. Stick a smart card in there, and it does a clock glitch, and it breaks the security of smart cards. Today, it's more likely to be voltage or electromagnetic glitches or other things, not these things anymore. And you address this by using loop invariants. So if you've got one variable that counts down and the other one that, down and the other one that counts up, or the other way around, the ratio between those two is constant. So you make sure that the down counter plus the up counter have a constant value. And at that point, you know that you've executed the loop the correct number of times, and it also defeats the compiler because it has to maintain that constant ratio, so it can't remove variables from the loop. So now you've got this long-suffering loop, which is, there's a lot of mess hidden behind this macro, which is, again, it's good in C because you can just hide it all behind macros. So now you've got a loop that's basically unglitchable or unfaultable. I mean, I'm sure there's someone out there who'll figure some weird trick to do it, but in general, it is very, very hard to fault or glitch that loop. Array bounds, another example. So typically you go through an array and there's some magic value like null or -1 at the end of it. What if that gets corrupted and you'll blow past the end of the array? So you overallocate that by 1 element, and then you have a hard bound, which is the full size of the array, if it's a static sized array. So for example, if the null or -1, if you go past that, which is the soft bound, you then hit the hard bound and you restart the system. Pointers, again, that pointer example I gave earlier. So you can make the loop safe, you can bound the loop, but you still don't know where those pointers are going. If one of those pointers is corrupted, it could end up going anywhere. So the problem is pointers are too valued. Null is a not a valid pointer. Anything that isn't null is an apparently valid pointer. They should really be tri-state. Null, a valid pointer to something, or not a valid pointer to something. So you make them scalar variables. And then there's special tricks with function pointers and other stuff, which is architecture specific. So basically you store a pointer and its bitwise inverse, or you can exclusive OR it with some random mask, which effectively encrypts the pointer if you're worried about someone deliberately manipulating pointer values. And that has to have a fixed value, all ones or whatever, and that will detect corruption in the pointers. And you've got this basic building block, is this pointer valid or not? So now you can say about every pointer, it's null, it's valid, or it's not valid. And again, you hide it all with macros. And so the loop becomes that. So basically, instead of just grabbing the pointer directly out of memory, you use this macro to hide the mess. And if that guarantees that you've always got a valid pointer as you go through this loop, you're not going to get a wild pointer pointing to some random location in memory. Booleans, the same problem. That's a standard defined for a Boolean. False is 0, true is 1, defined. But the compiler treats anything that isn't 0 as true. So it's basically a yes-biased Boolean. You've got 1 false value and you've got 4 billion true values. And you know, if you've got your Boolean doing something like eject reactor core, you don't really want a yes-biased Boolean for that. In fact, pretty much any fault or malicious overwrite of a Boolean value will make it be treated as true. And here's some examples of this. This is from actual hardware faults. So NXP devices, they have those 4 32-bit values, meaning high security, and anything other than those values, meaning no security. So all you've got to do is glitch 1 single bit through an electromagnetic fault injection, and it disables the security on the system. STM's STM32 has the same thing. It's got a 16-bit value, 1 single magic value that says high security, RDP, readout protection level 2. You glitch that to anything other than that 1 value, and you've dropped the security. There's a great video by a hardware hacker called Joe Grand where he's attacking a Trezor 1 hardware wallet and breaks the security of that based on this glitch attack. And other CPUs do similar things. There's one called an EFM32, which is another ARM-based system, which mostly gets it right, but then you glitch it a slightly different way. So basically for a Boolean, the same with a pointer, there should be one false value, one true value, and 4 billion invalid Boolean values. And again, there's a quote from a safety standard there saying, basically it should be stored in such a way that any single or double bit fault cannot flip one value into another valid value. So the way you do this, and this is from the previous talk on radiation-induced faults, that's a particular bit pattern which is particularly vulnerable to bit flips in memory. So chances are if you get a bit flip anywhere, it's going to affect that particular pattern. So you make that be true. And again, the compiler strikes again, so you can't store these values in such a way that the compiler can just turn it into a meaningless comparison. The compiler will take that long, complicated magic value and say, it's not 0, therefore it must be true. And in that case, you've got the design by contract again. So at the entry to that function, it says this Boolean has the one value that's valid as true, or the one value that's valid as false. Nothing else is valid. Safe integers, this is kind of a mess and it's compiler specific. So at the moment, it's still a bit of a problem. This is integers where you can detect overflows. The compiler support's pretty hit and miss and it's a pain to deal with, so it's better to just explicitly use a macro to check for it in advance. Another C problem is buffer overruns. This is pretty straightforward stuff. You basically, again, instead of using allocated memory directly, you put a cookie at the start and a cookie at the end, and it detects off by one errors and overruns and so on. It's not going to detect everything, but it will detect the most common errors of writing past the end of a buffer or being off by 1 and accessing element -1 or something like that. Control flow integrity. So I mentioned earlier with these preconditions, you can sort of guarantee that if you get a wild jump into code or you get used as ROP, then it's not going to work, assuming they hit that check. But what if they jump into the middle of a function? Or what if control goes into the middle of a function? Or there's just some fault and suddenly the code jumps to somewhere where it shouldn't be going. So what you want to do is make sure that if you're calling a particular function, you did actually intend to call that function. And there's a thing called Bernstein hashing, which is just a way of turning a standard ASCII string into a 32-bit or 64-bit integer value with a very low probability of collision. So if you've got a standard C identifier or even programming in general identifier, you can turn that into a unique integer value. And this really beats up the preprocessor. But again, this is why it's good in C, because you just get the preprocessor to do all the hard work for you. So here's an example of this. You've got a function shutdown reactor or eject reactor core, and you really don't want to call into this by mistake. So when you call it, you use this hidden behind a macro, this Bernstein hashing. So it takes that value, shutdown reactor, and turns it into a unique 32-bit key. The called function then does the same thing. It checks that key. So it makes, effectively, it's like a password that's been called, that you pass to this function to make sure that, yes, I really did want to shut down this reactor, and this isn't just a wild jump into code or a wild branch through code. You can also use it to enforce control flow integrity within a function. So basically, you're creating two expressions of the control flow in the code. The first one is the code you've actually written, and the second one is an explicit statement saying, I intended to execute these statements. Right at the end of it, you check the two values and make sure they match up. So this is a notorious example. This is Apple's go-to fail. And as you can see there towards the bottom, they doubled up the go-to fail. So instead of stepping through all of these functions, once it got to that doubled go-to fail, the control flow branched away from what the programmer intended into something else. So the way they use this is you encode sequence points in the code as part of this. And at the end of it, you check that all those sequence points were passed. And again, lots of preprocessor trickery. I'll put the macros in the slides later. So in the Apple case, and this is a bit of a, it's an extreme case to illustrate the point. So basically, after every line of code there, you've got SSL free buffer, and then you've got this control flow integrity check saying, I've passed SSL free buffer. And once you get to that point, the go-to fail, it's going to miss the remaining checks. And so when you get to the end of that, that's saying, I expect to have passed all of these control points, and you've skipped SHA-1 update 2 and 3. So basically, that will detect that the code you've written hasn't actually been executed in the way you intended it to be executed. You then reset the system and restart from a safe point. Again, that's a bit of an extreme case. Typically, you have significant code blocks, particularly in critical functions that you need to be executed, that you want to be executed safely, annotated in that way. You've also got to rethink your coding. How far do we need to go here? We need to limit exposure in time. You've got these safe Booleans and things in memory, but at some point you've got to take your nice safe pointer that's protected against faults and turn it back into a standard pointer so you can actually use it. So if you've got something that's in memory for, say, 10 microseconds, it's reasonably safe against random faults, at least. If it's sitting there for 10 minutes, you probably want to store it in a safe manner because you've got much larger exposure there. So you need to think about data lifetimes. And again, there's an example. You're sitting there with a pointer in memory or a safe pointer in memory waiting for data. You turn that into a standard pointer that you can use. You use it for a couple of microseconds, and then you store it back into a safe pointer where it's protected against faults and corruption. You also need to rethink standard coding styles, where you can have errors at any point. So that's, again, a bit of a contrived example. But you're reading a bunch of variable length data, so you drop a marker at the start of the data, you read these variable length records, you drop another marker at the end, the difference is how much data you've read, and then you copy it into a buffer somewhere, using standard ftal, if reads, and so on. And it's a pretty standard pattern. As I said, this is a simplified one just to illustrate this. And yet that last f read, you know that succeeded because you've just checked the return value, so you know that the ftal will also succeed, unless there's a fault, at which point the ftal will return either a garbage value or -1 to indicate an error. So even if that previous call succeeded and all you're doing is pulling a value out of memory, the call can not necessarily succeed. And you've got that problem I mentioned earlier where that offset goes from being a simple positive value to a very large negative value, which the memcopy or memmove or whatever then turns into an overwrite. And this can never occur error. You can run this 1,000,000 times in a debugger and it won't occur because it was either a random fault or an attacker-introduced fault. So it's very difficult to reproduce yourself. So you've got to actually change the way you code and change a lot of these coding patterns that you may be used to. So basically, real-world systems can experience faults, and the nasty thing is attackers can, and certainly hardware hackers have been very busy helping these things along, and it's been going on for quite some time. And it's not just availability, but also security, because if you've got one single bit separating you from safe to unsafe, that's a huge tempting target for an attacker. And you can mitigate those effects via this 1 out of 1D design, but then you need to fight the compiler to get it working as intended. And just a side note to that, if anyone's got access to any compiler that isn't GCC or Clang, and unfortunately a lot of the embedded systems compilers have also been turned into GCC or Clang, I'd love to get some of this code run on really obscure embedded systems compilers to see if they will actually generate correct code. Okay, that's it. Thanks. Blank looks? None? Okay, crickets, thanks. No problem, sorry. I've never...
There's these really good donuts out the back in the green room. Stuck in my face. Crickets.wav, please, while I chew. Consummate professional. All right, anyway. We thought you would enjoy like a little light talk just to start the day, something gentle, easygoing, not 17 platforms worth of assembly language dumps and compiler optimization minutiae. We'd never do that to you at 9 o'clock in the morning where you've got a hangover, sorry. Anyway, from things that catch fire on purpose to things that catch fire by accident. It's my very great pleasure to welcome to the stage. You may remember him from previous fires on stage, Mr. Jeremy Stark.
Hello, everyone. I'm Jeremy. I'm a software engineer, dad joke enthusiast, security professional. You see the order is important here. I help some companies with their security operations, compliance things, some cloud things, blow things up as well. I love to build security tools, and I work on my talk until I have to walk out on stage. Someone called me out on instant physics like the other day. That's true, except not this time because I had to leave my laptop here. So I was very nervous backstage because I couldn't work on my talk. Well, SAS, Security is a Second Thought. I love this title because it's so broad. It could mean anything. So I hope you're strapped in for, well, just about anything, really. A couple of months ago, I read the PCI 4.0 spec. I didn't even have a client to read it to. It was very sad. What's worse is I got excited about it. Yeah. And it's not because I wanted to win an argument. No, not at all. And that argument is now with myself because the other person doesn't care. Well, anyway, PCI is one of those second thoughts. It's definitely not the first thought when you're like, oh, let's add credit cards to our app. It's not the first thought in the developers and the marketing people, the product people. No. It's more of a second thought thing. Risk and governance and compliance. Those are really great security second thought words. And I thought so too as a developer. I wanted to build the cool stuff. I didn't want to do this, boring, what I thought was boring stuff. Yeah, basically, this is the talk about how I had to do something boring and I completely over-engineered it and did something unnecessary. But anyway, if there's one thought I want you to remember from this talk, it is to remember to build a secure company, not just a secure product. Otherwise, security leaks. Yeah, thank you. As you can see, I spent my time wisely. I got way too carried away with DALL-E Mini. I don't know if you've seen this. Like, you give it a prompt and it generates pictures. It takes like 90 seconds to generate, so it's perfect for just like doing something and just waiting and doing nothing else. Yeah, and so I'm not talking about startups. They've got enough problems. It's hard enough to build the product. I'm not saying like, hey, where you should spend your time. I'm not talking about really large organizations. They really have to do this stuff out of necessity. They're already doing this stuff or should be doing this stuff. If not just for logistics. But there's a big gray area where you were small, you had this cool idea, your product started getting big, hopefully really successful, and then at some point, bam, you're all grown up, you've got to pay the bills, go to work, and you're thinking how great it was back then when you didn't have all these problems, and why didn't I invest in Bitcoin at $20, So I'm just going to give you some things to think about that if you're in that place of growing really quickly, here's some things you can do before you'll need to do them later, and it'll make your life so much easier later. And maybe if you're already in that late stage, I'm not sure how this is going to apply and how you can, maybe there's some cool ideas here that if you can make that work in a big org, let me know. So, here's, these first boring thoughts that I had, and you can see I got really carried away in Grafana and GraphQL and a graph database. I really just wanted to play with graphs. I didn't want to do any of that boring stuff, so, well, that's what we're going to find out. First things first, are you sitting on a pile of SaaS services? They really heap them on there, your startup. They're just like this big pile of laundry of big SaaS products. It wouldn't be unusual to have hundreds in your organization. We'll just write them down. Go and find out what they are. The best time to do this is during security awareness training. So I've gone up there, and I've told people, just yell out all the services we use. And I'm there on the whiteboard, and they're thinking, oh, this is just part of the training. I'm like, oh, what did you say? We've got another Dropbox thing. Okay, you're running that. Oh, yeah. It's a gold mine. You've got to talk to everyone in the organization because they're going to have those services that they think everyone else knows about, but it's really just the 3 people in the back of the corner that use that service. And which ones are critical? How do you define critical for your company? If Amazon stopped existing, would your company be able to continue? We all know if there's like a whiff of a Slack outage, that's it, no more work, got to go get a coffee. My message is taking more than 5 seconds to load. That's it, can't work. I wasn't even using Slack, but, And so for those critical services, how would you even contact them? Particularly those in a hurry. As a pro tip, you can figure out how to contact them before there's an incident. You don't want to be finding this out on a Friday night that your domain registrar doesn't have a phone number and you can't contact them until Monday. And even then, there's no person you can talk to. Does your CEO need to tweet their CEO? That's your method of communication? Are you just like a $10 a year customer to them? And this is this domain name is your entire business? What would your domain registrar do if they got a bunch of automated spam complaints against your domain? Are they going to really? Do they know how to contact you? And And who looks after each one, otherwise known as, who can give me access. And this is usually how these lists start. Someone's like gone through onboarding, they got really fed up, and they're like, oh, I'm going to make this big list. But then they onboarded to everything, they didn't need to update it anymore. So it's usually 3 years out of date and in Confluence somewhere in the depths of your wikis. How many of you come across a list of service only to find out, these people, why they're still on this? There's a contractor from years ago, he's still got access to this thing. Or have you got any MDM software where the account, sales rep has an admin account because they gave you a demo that one time? Yeah, business requirements, also very important to remember, why are we even using this service? Like, if you don't need it, then just get rid of it. But also, don't discount things that you think people shouldn't be using. Find out what the actual business benefit is. There could be a really good reason why you're using it. You could consolidate some things. But yeah, this is a really big one that people don't think about until way too late. So, I have a bunch of demos. Let's see if they're going to work. So, pretty graph things. Yes. So here I've just put a whole bunch of services. We've got these ones here, these services, and it looks cool. There's lots of nodes. This is the fun bit that I was doing, right? But then as you're doing this fun thing, you discover things. You're thinking, hang on, I've got this service here, GitHub, and I've got these 2 people, but 2 people own this service, and that's very unusual. And in fact, this person, they don't even belong to a team anymore, so maybe that's something I should look into. And you can find some really cool stuff. You can look at it from a really big distance, and you find some really, what are these ones over here? They look unusual here. And then you can go and have a look and say, oh yes, there's some services with no owners. Okay, so yeah, we better go and check those out. These kind of things are really hard to spot in a big list of stuff on the wiki. Here's another one. We've got Okta here as a service, and it's owned by someone from security, but also owned by someone from engineering. So maybe that's how it was introduced and then never really, tidied up properly. So yeah, there's some really cool stuff you can do with some graphs. What are your assets? Next, in this database, go through, now that you've got all these services you're going to start thinking, what am I putting there? You've got databases, you've got employee data, personal information, customer data. Go and tag them, they can go and annotate these things. This is another good thing to do during this security awareness thing. This is the logical next thing. People are like, oh yeah, this is great. And you're like, again. Make a note of which third-party service then supports those assets. So this is the graph database, this is the real power, I think, is the query language. It's called Cypher, and it's a bit of a weird learning curve, and you create these relationships. But it's as easy as just this text file that's like, okay, I'm going to create this relationship between Amazon and it's storing this customer data, or Bamboo HR is storing my employee data. Of course, naturally, then you're going to start having to classify your data, and you're going to go through this list, and you're going to find common pieces. And this is just one of the ways, one of the 4 different ways. You go public, internal, confidential, restricted. But you can start thinking about, how do we use this data that's stored in these services in our company? Some things do have to be public, otherwise no one will know about your company and you can't send those cool tweets. But then some things do need to be internal. Maybe that's your business processes, maybe that's, some issues in an issue tracker or something. Confidential, your employee records, only the people who need to know them to do their job should have access to them. And then maybe there's some restricted stuff that you don't want anyone to have access to. Maybe that's your customer data in a database or something like that. So now you've thought about all that data, how important it is to you, and which ones you really like, and now imagine that they're gone. How sad would you actually be if you lost this data? And this can be a really fun exercise, but I'd say pace yourself. Don't get too carried away, because it can be a bit heavy in one of these exercises. Someone's going, yeah, and we're going to lose our jobs, and then we're going to possibly go to jail, and then our customers are going to suffer, and everyone walks out of this meeting going, oh, geez, Whew. So don't get too carried away. But do think about this stuff before it happens to you, because maybe just thinking about it's going to spark the discussion. You're going to talk about it amongst yourselves, and you're going to say, hey, there's actually something we could do to reduce these impacts. So we've got some more cool graph stuff. So you can see, I don't know how well you can see this, but you got that query, right? That you're asking. This is the bit I really love about the graph database, that you're asking a quite generic question, but you get a very specific answer back. So I'm saying, hey, show me all of the ways I can go from a service to an impact, and that impact is going to be lose company. So now we can start having a look at that, and that's going to be like one that we might want to have a little zoom into and see. So here's our impact, lose company, in the middle, and what have we got? Okay, well, Slack. Why is Slack could potentially cause lose company? And that's maybe because it's storing database credentials, right? So just little facts over time. You can add these little relationships in just as you discover them. Oh, we're storing some database credentials in Slack, but I know that database credentials, a loss of confidentiality could lead to lose company. So that can help you prioritize some things. There's some other ones in here you might not have expected, and it could be something you want to run all the time and just keep an idea of this picture. And you can take this picture to somebody and say, hey, what's the problem? It's like, there's the picture of the problem, and it's much, much easier to talk about. So let's go to the next one. So look, I didn't want to say it, but once you've got this likelihood and you've got these threads and you've almost got this basic risk register. Now I'm not one of these. I don't think I'm a professional in this area. I don't know if there's I'm not a lawyer, but for GRC. But I would say if you do hire your CISO and you get your security team and you've done all this stuff and that's what you give them, it's going to be a very different story. They're going to have a much better time. You're going to have a better time. They're going to have a better time. It could be way of a better start. Usually, the first security people into the organization are coming in at a time where it's a little bit too late. So have a think about this stuff and do it beforehand. I learned from a CISO once that a risk register is really just a communications tool, not just to accept and sign off risks and things, but also to show how the risk is changing over time with the investment of money into security from people who have the money. So if you can communicate back up to people and say, oh, you spent that $1 million, and here's how it's changed over time in a picture. I mean, it is a really visual thing to show people. And I think that communication part is really key, not just up to the execs and the people who've got the money, but actually everyone needs this information, and it's just maybe in a different context of their work. You can imagine a developer adding a new microservice. What kind of impact do similar services have? What do I need to consider for the service? Imagine they start classifying the data before they've even worked on the project, because the data is available to them, and they can query it and search it, and even put a cool picture in their GitHub, README. Says, hey, yeah, here's my service. If you make these tools available and they're good tools and they're up to date and it's the source of truth of data, then people will have no problem doing good work. Someone brings in another SaaS product. That's okay. All the information's there. Someone's going to want to add it to this graph because maybe then it appears in some, report or something, and they can say, oh, yes, I added this in. And initially, maybe they just add the service that they own it, and that's fine. And over time, you can add more information like, does that service have a risk assessment? And have we looked at this other thing, and what's the impact of these things? But you can just add little pieces at a time and not have to worry too much about, before I add this new service to my, I've got to get security sign-off of this new service because no one's ever going to look at it ever again. But if you're constantly looking at this stuff, then it doesn't matter. You can do things piecewise, a little bit at a time. it really allows the business to assess the risk constantly so that you can take on more risk, right? So these opportunities out there, these really big opportunities, going to come with some risk. If someone can quickly say, oh, actually, we do have a lot of this high-risk data that we're storing in all these places already, maybe adding another one's not such a good idea. Or maybe we don't, and maybe we can take on this really risky service, but it's only because they have the data that they can have a look at and make the decisions from. You can also use this graph tool as a way to communicate and help you actually get some controls in place. It's much, much easier to explain why you need MFA when you've connected it to an impact and then like the set of assets. And you can say, oh, well, all this data that's going to lead to loss of company, loss of sales, loss of data, that's the one that we're protecting. And so we can actually show you which ones need the extra controls in place. And then you can even alert when you have a new service that is impacted that doesn't have MFA, and you can alert with a picture. So this real next part that really brings people in is the automation side. And I've realized you can't just give everyone access to write these Cypher queries. I think it's similar to putting an SQL database just on the internet and relying on like the table access controls. I don't think it's a good idea at all. You can have similar access controls in the Cypher database, but that's not a good idea. So that's where I've started adding in GraphQL. Even though the graph is in the name, it actually doesn't mean it needs to have a graph database behind it at all. It's really just an interface description of your API, and you create a schema. So you say, here's the type of data I'm storing in my API, and here's how I can query it. And then it does a whole lot of the input validation, output validation, the type checking. You can have required fields, and you can do all this neat stuff with it. So it's really just a way to say, here's the way I'm expecting people to use my API, and then they can query it themselves. You also get quite a nice little UI that you can query from. So you get like this graph playground. You may have seen something like this before. This is what the query looks like, and you actually you query, and you tell it the format and structure of the information you want, and then all that the input validation happens, and then it goes off and gets the data from your data source and then returns it. So you can see here I'm running my person query, and I'm getting back all of the people from my graph. So you might also wonder how that actually connects to the back end. There's a really cute library that makes this kind of nice. There's that Cypher query again, but now it's in this resolver for the GraphQL bit. So this is really all that was required. Now, I haven't actually pen tested this or anything, so there's probably more lines that need to go in there. But this is the start, right? This is you're saying, okay, I want to actually control who can query this data and what the type of query you can run is, and where the parameters are going to go. And then I can have my access control. But it's just really to enable everyone in the company to access this data as much as possible. And when you're connecting it to GraphQL, then it actually enables you to use other tools as well. Because GraphQL is it's kind of a standard tool that other things have a lot of plugins for. For example, Grafana also has graph in the name. This is part of that's kind of why I chose it, really. But it also is a nice dashboarding tool. So this is an open source tool that you can use to graph metrics and things. But with a plugin, it can query data from a GraphQL database. So you might have, and it even had this cool, graph view. So you might imagine that your specific query where it's saying, hey, show me all of the services that have no owners, or show me the impacts that could lead to this certain kind of financial loss or reputational loss. I want to make that as a dashboard so that I can just have it and have a look every now and then and see what the what my environment looks like. I think I have some more bits as well. So if you wanted to add some data into this, you'd use one of these mutations, and here's I'm just running this query where I'm saying, oh, okay, we're going to create this person, add them in, and then I'm going to get this person back as a result. And so you run that, and here's the result from the graph database. Now that should be in there. I think if it all went well, I might see myself appear here. Oh yeah, there we go. There's the second one that I just added in. So that's a really nice part of it if you're adding like, oh, how do people actually consume this without having to, Docker, outdated Docker and compose up. I was very suspicious. My Docker needs updating, and I haven't done it before the talk yet, and I'm a bit scared actually. So the other thing I've got is, how many of you have seen environments where the endpoints are completely unmanaged, right? Like you go into an org and they say, well, what we did is we told people here's $5,000, go out and buy a laptop as long as you do the work. We want you to be happy. People come back with like RGB laptops that can hover and all that, and then you've got, but you just got no idea what everyone's using, and half the people are using Windows, half the people are using Mac OS, and the other half you didn't know about are using Linux. So, and I've been in an organization where you're like, okay, they had a antivirus software, but they just couldn't report basic things like what's the patch level of Windows, what major version am I on? So things like that, if you don't have that visibility to start with, how can you even begin doing other things? There's some new, you can follow the news. It's like, oh, new Windows 0 day, great. Ooh, are we affected by that? Don't know. But then you can also go too far too quickly and go, well, we need MDM. We need to manage these endpoints with some automated stuff, and yeah, we're going to pay $60,000 a year and it's going to be great. Poor IT team, already under-resourced, now have to automate everyone's stuff for them, and you don't even know why you're automating it. You're not really sure what problem you're solving. You could do this much more efficiently if you just said, well, actually, all I really wanted to know was what version of Windows you had and what version of Firefox or Chrome you're using. So maybe that's just what you do. Install a little tool, and Ryan's helped me write a Rust tool to do this, where it go and collect, okay, all it collects is what version of Windows, what version of browser you got, and then it could post this back into the graph database. So I don't have the Rust demo going, and I was considering doing it last night, but that was a bad idea. But I do have a curl command that is just about as good. So you can see, and in fact, it could actually be curl on like curl with a cron job. Like, why does it have to be anything too fancy? All you want to do is record, which user has what operating system and what version, and then you can decide later on what you want to do about that. Because when you're small, you could just go and ask them. You say, hey, you need to update your machine, and that's much easier than relinquish control of your laptops to someone who's now got admin privileges, and it's like, why are we doing this again? So you could just do a GraphQL request, and then so here I've registered this endpoint, with this graph database. And then you might want to say, okay, so one of the queries I might want to add it to GraphQL, to my Grafana dashboard is, well, what operating systems are being used by different people? And so now we're actually traveling away from this. There's no graph component of this. This is just, but behind it there's a graph database. If I showed you what that endpoint looks like, I don't think we had. I know what we're going to do. We'll add Bonnie in. Bonnie could register. Coming up with test data is really difficult, especially coming up with a whole bunch of names. So I went and just grabbed like the friends list of names, their character names, to do all this. And then it's not so I have a bunch of friends in my fake company, but. So now we should have operating system used by Bonnie and And then if I went to query that with my GraphQL, so here's Bonnie. And you might say, okay, Bonnie is a member of engineering, or they actually registered an endpoint, and that endpoint has a version of Windows on it that you can go and inspect the version of. What's really strange here is actually Kiki also registered that endpoint. So that would be a really good query to add. I'd only changed the name, so they've somehow got the same endpoint. But that's a real situation that can happen, where maybe someone takes over a new laptop, but you might want to go and make sure that was this endpoint not wiped? Why has it got the same ID as the last one? Yeah. And why is that interesting to know what version of Windows Bonnie's running? Well, maybe Bonnie's actually trying to access Amazon, and I already know the ways in which Amazon can lead to lose company. But through this query to say, okay, well, if Bonnie is accessing a service that has a really important impact like this, I actually want to make sure that their version of Windows is up to date. And now that can be my query to run when I'm giving them access to this. And it's a generic query. It doesn't really matter what the impact was, or what the service was. Just because you gave it these little pieces of data over time, now you suddenly have this really powerful query to say, oh, they're actually out of date. And maybe you would give them 7 days to update their machine, otherwise they're going to lose access to the service that they want to use. But now they're going to understand that. They're going to understand why they need to update their machine, so they can keep logging into the thing. They're going to... You can imagine the alternative when 7 days passes and they go to the security team and say, I've been locked out. And the security team goes, was the notification not working? Oh, no, it was working. Okay, so did the update not work? Well, I just didn't do it. That's so much harder to do now, because in advance, you know why, and you know the impact, and it's been explained to you. This is why, because you're accessing an important service that stores this data that has this impact, that's why we're requiring you to have an up-to-date machine. And you can go even further, and what I want to throw into this is like the OSV.dev I saw earlier, which was like the current vulnerability information. You can imagine if maybe there's a 0 day for Windows currently in the wild, so that likelihood of that impact goes to certain, or maybe very likely, and then you don't even give them 7 days. Right? It's like, hang on, you're trying to access the service, you've got an out-of-date machine, and there's a 0 day in the wild that we've added to the graph. So actually, you're going to not have access at all. We need to fix this first. We need to make sure that we're not affected before you can keep accessing the services that lead to the sad times. So really coming back to, remember to build the secure company, not just a secure product. Then we're going to end up with security cabbage patches. Yeah. Yeah. They look cool. I like the pictures after I did this. There was I also tried an eye patch, and it came out a bit weird. You got to get very specific with these prompts if you go and play with this stuff. If you want to try it out, there's the repo, and you can see it's not a fully fledged SaaS application, but it's more just a collection of ideas. Maybe you can use those to build this yourself in your own organization. So you can have a play with the graph stuff, and you can use Docker if you're still brave enough to do that. Why is it called Leeks? Well, I just name all my projects after vegetables to avoid the problem of not starting anything because I can't think of a good name. And then Leeks kind of just really fit, I suppose. So yeah, thank you to a couple of people who helped me with my slides and my presentation. This was one of my favorite outputs of the DALL-E. There's the playground that I used. I had to give Google extra money to to warm up some GPUs somewhere. So yeah, but this the P's and the C's with eyes. Oh yeah, thank you.
Look, I hit my cue this time. Not out the back eating donuts. Thanks very much, Jeremy. Now, I grew up in the 80s virus scene. That was my kind of introduction to what ended up being hacking, what ended up being my career. I infected my mother's computer with a virus, Dark Avenger from Sofia, Bulgaria, and that caused me some grief, as you can imagine. Anyway, so I became quite interested in viruses. I used to collect them. Like I have at home, I have a box of 5 1/4-inch discs, with Caught in the Wild, Pakistani Brain, and Dark Avenger, and Cascade, and all of it's stoned, written several hundred meters from this very place. And so that was, my gateway into this sort of thing. And then I guess I never really thought about the other sort of virus, the pandemic sort, because that's a thing that happened in the old days. So we were in a strange time, and the analogy between computer viruses and biologic viruses, does have a bunch of interesting points. Now, our next speaker has been involved in incident response in both capacities, and perhaps there really are some things to learn. So it's my great pleasure to introduce to you Izzy.
Kia ora koutou, and as you can probably guess, and from that introduction, this talk will extensively cover the COVID-19 pandemic. Now, I get that this is the first time we've ever kind of attended an in-person conference during this pandemic environment, and if it's all feeling a bit much for you, I totally get it. Go grab a coffee, we can chat in the break, and I promise I'll sanitize it for you. But hello, I'm Izzy, comms lady about town, and I specialize in helping people and companies talk about their cybers, rogue or otherwise. I honed my trade with several years building a national cert, and now I'm out helping other people talking about computers. And since I'm a free agent, I can say swears on stage. This presentation brings together the two great career loves of my life, health communications and cybersecurity communications. And these things have so much in common. So today I want to share with you the why and the how, and give you some things that you can take away to maybe learn something that you can use from the COVID-19 hellscape. So cast your mind back to the before times, long before COVID, before we wore masks and bumped elbows, before the nation had a cert, in fact. I was a health communicator. I talked about how to keep people safe from flu and what hospital capacity was like, and I gave out patient status updates like she's in a serious but stable condition in the intensive care unit with complete earnest. And I learned to be an incident responder, and I worked on the health response to the Christchurch earthquakes. And I once got to watch a helicopter full of PPE-clad people land on a disused helipad during an Ebola outbreak. And then life moved on, and I discovered cybersecurity and you fine folk, but I never forgot my roots in health, which is where I honed my trade. In fact, one of my most used resources even now when teaching people how to respond to cybersecurity incidents is a battered old copy of a World Health Organization handbook on effective media communications in a public health crisis. And then, like an analogy that would make sense at this point in the talk, we had COVID. And everyone suddenly knew about things like viral load and genome sequencing. And the experts that it was my job to fight on the internet about password entropy were suddenly epidemiologists. So how do these things even relate, Izzy? Well, I think there's 4 really key components of both a true virus and a computer virus responding to those types of incidents that we can really take away. So the first one is we're operating in this constantly evolving situation. New information is coming to hand all the time. Secondly, there's lots of people in the general public or potentially in our user base who just think that they're immune to it in one way or another. It simply won't happen to me. And so there's a real barrier to overcome with everyday folks. Thirdly, there is so much information around. The information overload is truly real, and discerning what's real and what's dodgy is much more challenging. And of course, the fourth thing, the thing that I care most about, is people. People are at the center of what we do. They're at the center of a health crisis. If we didn't have people, we wouldn't have anything to do. And of course, comms. Why I'm here, right? So we've got to understand people and issues, because without knowing our audience and knowing our subject matter, we can't overcome them. Now, when I was planning this talk, I looked through lots of media interviews, lots of press conferences. We're all very familiar with the press conference machine now, of course. And I found this fantastic clinician, Dr. Michael J. Ryan. He works for the World Health Organization. He's Irish, so he has an amazing accent. And he is the most quotable person I found throughout. And he said some really poignant things that I think really relate to the work that we do. And the first one that I'd like to share is this one. Be fast, have no regrets. You must be the first mover. The virus will always get you if you don't move quickly, and you need to be prepared. Now, this is all a bit doom and gloom, right? So, what can we do? Well, fortunately, heaps. Put simply, everything can be a learning experience. The more we can open our eyes to finding out what we can take from other, maybe even vaguely related disciplines, the better prepared we'll be for the time when it's something in our wheelhouse going pear-shaped. Now, of course, there is the oft-used quote from Winston Churchill, never waste a good crisis, or unfortunately for everyone I've ever worked with, me just constantly all the time during an incident response. But from this crisis, I've got 4 key things that I think we can learn. So the first one, nothing's set in stone. So you can always change direction during your response if something isn't working. Here's my old mate again. If you need to be right before you move, you will never win. Perfection is the enemy of the good when it comes to emergency management. Speed trumps perfection. So really, this boils down to do the thing. When we're in the midst of an incident, it can be really easy to get stuck in the detail, to start analysing the true technical nature of an incident, and that's awesome and interesting for us, but less awesome and interesting for other everyday folk who might be impacted. So if you're that kind of person, that's cool, but find someone in your team who's ready to act and ready to move so that they can take the helm. An incident controller, if you will. So when we think about this in terms of the New Zealand response, in terms of changing direction, you'll all remember the early days, 2020, what a banger, where masks, were a thing constantly asked about, and in fact the New Zealand response to masks, kind of hilariously looking out into this crowd, was, yeah, nah. And scanning, keeping track of your movements through an app, of which we acquired many, was kind of possibly, maybe, but maybe, I don't know. I'm sure you remember. It'll be fine. But MIQ was sorry everyone, yeah, no, we've got to stick with MIQ. MIQ is the long-term solution to this problem. Let's click forward to Delta. Suddenly masks, yes, all the time. What does your one look like? N95, KN94, fabric, we're sewing them, it's amazing, everyone's got a new hobby. The direction changed, but the way that direction changed was using evidence, using insight, using the experience of our overseas partners. Scanning became the center of our universes. We all installed that little iOS trick where you could tap the back of your phone. It was a core part of our response because we had so few cases in the community. We learned that tracking and tracing was the way to get that moving forward to keep our community safe. And then MIQ. Well, MIQ, not everyone's darling, was suddenly gone burgers. It was out of here because the environment that we were operating in had changed. So when we think about changing direction in cyber incidents, I'm sure you'll all remember this old fella. So WannaCry was the first cyber incident I ever worked on, which, holy mama, that was a baptism by fire. And when we were responding to this incident, a couple of my former colleagues in this room, a couple of scared little monkeys, as we have been described, we had a bunch of evidence, right? WannaCry for New Zealanders happened overnight. So we had this evidence from our international partners saying, hey, look, it could be this Windows vulnerability, but we also have some evidence that there is propagation through phishing. And so we shared this information, and then as the time evolved, as things moved on, we discovered that actually the phishing thing was not a thing. So we owned our decision, we changed our advice, we had to field a few OIAs, but in the end, changing the direction was the right thing to do because it gave New Zealanders the right information to stay safe from the virus. Because the right pivot is worth the pushback. That doesn't mean it's going to be easy, but it is worth doing. Because when you're the person, when you're the man in the arena, so to speak, it can feel pretty overwhelming, being the one giving the advice, the one changing the direction. But that direction change, it can show humility, it shows vulnerability, and it can be the right thing to do. The second thing is getting back to basics, right? And when I think about basics, I think about simple, easy to understand, and easy to action advice, because no one ever complained that something was too easy to understand. So while we may want all the detail, every last piece of information, in fact, for some people that is just not going to work. For people who don't operate in our environment, it's much more challenging, in fact. And so making sure that the things we need people to do are clear, simple, and actionable are critical. So a great example of this is the wonderful national game of Go Home, Stay Home. March 2020 saw us all go into lockdown, but we saw compliance from pretty much 5 million New Zealanders with the Stay Home, Save Lives message. It was clear, it was simple, and it was actionable. Similarly, look, a quote from someone else, was hand washing. Hand washing is both an amazing mitigation to the virus, but also a simple thing that people can do. So you're giving people a simple, understandable action that they can undertake that's actually going to make a difference for them. So when we're taking security information, taking it back to basics, there are 4 key things to remember. The first thing is use familiar language to make it real. So think about how you can boil down your advice into simple, clear, familiar language. Now, once upon a time when I ran the Search Twitter account, I used to get a bit of grief because I would always say this information is easy enough for your mum to do it. Now, some people took that as an insult, that mothers were not intelligent. But I'm thinking about my mum. My mum is a senior leader. She's highly educated. She's a chief executive. I'm not thinking about dumbing it down. I'm thinking about bringing someone new into our universe. The second thing is make it actionable. Give people something they can do, or, in the case of the Air New Zealand example that Nadia gave yesterday, give them a clear nothing to do. Number 3, if in doubt, tell a story. Storytelling is part of what makes us human. By telling people a story that they're familiar with, we can make it easier for them to understand what we're trying to get across to them. And number 4, know well actually. This is not a time for perfect information. This is not a time to debate the ins and outs of password entropy. This is a time to help people do the thing that they need to do to help them be safer. Now, sometimes basics aren't going to work, but technical information can be for everyone. So there will be instances where you simply need to wade into technical language and technical concepts, but doing so in a way that is empathetic, that is caring to the people we're communicating with, will give you a much better outcome for the actions that you want them to take. So a great example of this during the COVID-19 pandemic was, of course, everyone's favorite 5-star rated show, the 1 p.m. update. Keeping people up to date daily, giving them a mechanism to understand technical concepts, gave them an opportunity to build their knowledge gradually over time. Because what we were entering was unprecedented times. And so being able to present experts and very senior people telling a cohesive, easy to understand story while explaining technical detail brought New Zealanders on a journey to be more safe from the virus. And the New Zealand response to both locking down and responding to COVID has been internationally lauded for the way that we were communicated with. I think many of us in this room are incredibly fortunate to have lived through the pandemic lockdown here in New Zealand because we didn't know what everyone else was experiencing. We only got to experience this really world-leading communications response. So the way, for instance, that the Prime Minister talked to us about how we were going to enter lockdown was very clear, concise, and decisive. But sometimes you need to think about maybe an alternative method for communicating this information to people. Sometimes people need more information, sometimes they prefer to read information as opposed to it being spoken to them. And so the other great example of this is the COVID-19 alert level summary. We all got one in our post box, we saw them everywhere. They were up in the office if you had the fortune/misfortune of going in there during lockdown. But whenever you needed to know what information was required, what steps were required for you to take during the different levels of lockdown, the alert level framework and the information provided by the COVID-19 group was incredibly useful to help people know the detail if they wanted to get into it. And of course, I couldn't talk about making technical information clear without mentioning the amazing work from Toby Morris and Susie Wiles. The media work that they undertook with these cartoons, this is an example of how an mRNA vaccine works, was amazing. It has been replicated around the world. The WHO are using these, but we had the opportunity to have these very complex subjects. You know, I don't think that 5 years ago many people in this room would have been able to understand the inner workings of an mRNA vaccine and its various benefits over any other type of vaccine. Suddenly, though, we've had these very compassionate people speak to us about how these complicated things work. So then how do we apply this to our world? Well, when simplifying isn't going to cut it, I can't tell you which bits to include or not include. Every situation will be different. But what I can advise is when we're in this situation, bring these three things. So bring empathy for your audience. I know we've all experienced things where we're not the expert in the thing that's being explained to us, right? And so having someone explain something complicated to you with empathy and with kindness is always going to give you, as the audience, a better outcome. Number 2, transparency. This is something that Nadia spoke about yesterday. It's something I will always endorse. Tell as much as you can, because the more information we're sharing, the more likely we will be a collective to respond to an incident. Bring people on the journey with you and do it by telling them the truth. And 3rd, expertise. Make sure that your information is right. Now, this sounds a bit obvious, but unfortunately, it's actually very challenging to do. Particularly when we think about security, there are so many opinions, and so finding a way to cut through the noise and make sure that we're giving the right information for this situation to make sure that people can recover effectively is really critical. The last thing that I want to cover is we're not always going to get it right? Not everyone got everything right in the COVID-19 response. Not everyone will get everything right when responding to a security incident. And when my old mate, Dr. Ryan, was asked about which country is doing worst at responding to COVID-19, this is what he said. We're trying to identify the best lessons we can all use, the best way to move forward together. No one has done perfectly, and no one has made all the mistakes. We share all of the errors together. And I think that as a community, this is a really critical point, right? You don't want to be the one responding to an incident and having your peers critique you online, internally, wherever it may be, what we need to do is band together, support each other, make sure that when someone is having a tough time responding to an incident, that we're helping them, that we are giving them our expertise to help them recover more effectively. So then, in light of this, I've got 4 key things that are maybe things we could learn from as we go through this. The first one is eat your own dog food. So if you are talking the talk, if you are saying, hey, the thing that you need to do is have 20 character passwords while you've got middens 1, 2, 3 sitting on your machine, it's probably not the way to go. Or if, just hypothetically, you're the Minister of Health and you go to the beach during a level 4 lockdown, that's probably not a great look. But, just hypothetically, of course. Number 2, you're better than click carefully. Don't give people shit advice. Click. What does click carefully even mean? So give people something that they can do something with. If you can't, tell them you'll come back to them. Don't give them something to do like in the early days of the pandemic when we were told not to touch our faces. Have you ever tried to not touch your face? It's almost impossible. Instead, give them something meaningful and actionable that they can do, or leave them alone. Number 3, the industry will consume itself. And I alluded to this earlier, but now is a time to love each other. This is not a time to criticize the response publicly through public channels, on Twitter, have a big fight, get yourself a hashtag, maybe make a logo. This is a time to come together and share that advice, to commiserate, to send a coffee run to your friends who you know are having a terrible day, because otherwise we will never get through this. We must come together. And 4th, haters gonna hate. Sometimes people are just gonna hate your response. That's okay, because I'm sure all of us could name a pseudo-expert who's probably got views on the response that you've undertaken, but that at the end of the day, if we're supporting each other as much as we can, that is the best thing we can do. And also, maybe do what you can to take those people off Twitter, because they're a nightmare. So then, that was a lot of information, right? This is a lot to take home. So then, to finish up, I just wanted to give you 3 points. If you remember nothing else, this is the one to take a picture of. What do we do about it? So the first thing to remember when responding to an incident, particularly when speaking to others, is to be humble. Remember how it feels to not be an expert in something, and give people the advice that you would want in that situation. That kindness, that humbleness, that empathy, that's what's going to give you the best outcome. It's what's going to give you buy-in from the people that you're speaking to. Number 2, use analogies. Analogies will be the thing that saves us when talking to everyday folk about security. The thing we talk about is incredibly complex for everyday folk. So liken it to something that people are familiar with. Something maybe like a pandemic. We've all lived through this. So think about how we can take the lessons we've learned from something like COVID to tell a story about security incident response. And lastly, know your audience. Think about who you're talking to. Really consider who they are as people, the other demands that they have on them, and what they need. This isn't about dumbing it down. If you're dumbing it down, you're doing it wrong. Instead, we're making meaning for people who don't understand quite what we're talking about. And so, that's it. Thank you. And let's chat.
Thanks very much, Izzy. I think nearly all of us, in this room who work in security, who aspire to work in security, understand that our role really is explaining and communicating our expertise to everybody else in this world who is forced to live in this technological nightmare that we've built for them. So having content like that, having something that really, that we have seen what incident response looks like on a global scale and on a national scale, and getting that kind of expertise and understanding what that means for how we practice our craft. I mean, if you want to be a pen tester, 50% of your job is looking at terrible SSL certificates and alert ones, and the other 50% is explaining all the things that actually do matter to the business and to the customers. So it's really great to have, such a level of experience in explaining very, very complicated issues to a very, very wide range of people. So I hope you found that useful. So we are going to go out to morning break and come back at 11:15. The merch desk is open if you want to pick up your merch. We have cookbooks for sale. If you did not order one and you'd like to buy one for cash, that is a thing that you can do. I have been instructed by Spart, against my will, to say that I will sign your cookbooks. So that's service that apparently I provide. I don't know what my life is anymore. But anyway, thank you very much, and we'll see you back. Get a cup of coffee. Remember to wear your mask around the venue, and we'll see you soon. Welcome back. Now, when we first started Kiwicon, we all thought that we were like super underground badass hackers, when in fact we all had jobs, and some of us mortgages and children. We have a lot more children than we did in Kiwicon 1. There's been quite a lot of procreation since then. But anyway, we thought we were badass. We thought that we were underground, hacking the man, and yeah, we're all like sold out shills. But anyway, we had plenty of talks about attacking and very few about defending back then, because we thought, that's not what, we're badasses. We want to attack stuff. And it turns out that, all of the defense that we did 10 years ago, 15 years ago, didn't matter anyway, because it didn't work. And B, we didn't want to think about that, because we were just busy having fun, right? The computers didn't matter, security didn't matter, firewalls didn't really work, VPNs totally get you owned these days, and we spent all those years telling you had to use your nasty Palo Alto that drops Java 1.6 on you so that you can VPN in for security. But now the world's different, right? Now the world has, computers matter and security matters, and our hospitals stop working because of stupid VPN tech or whatever else we sold them, in the mid-2000s, because security didn't have to work then. There was no pressure that security had to work then. We could just do what we liked. Turned out it was a terrible idea. Anyway, where I'm going with this is that we now attempt to have some at least slightly defensive talks on the schedule. And so on that subject, it is my pleasure to welcome to the stage Asjad.
Kia ora and good morning. Thanks, Adam. Thank you for joining me today to talk about security operations and why I think it should be a lot simpler than some of us make it out to be. So to Adam's point, we've spent a fair chunk of this conference talking about breaking into networks and hacking things. But then there is kind of this other side to our industry and we focus on defending our networks, right? Like, how do we make sure the bad folks don't break in and steal the data and do the damages and things like that. So the goal today is to spend a bit of time thinking about that. So if you're kind of looking at all the talks and going, there's no hope, everything's broken, I'm just going to quit my job and take up farming or something like that. I'm here to give you some hope today. So my name is Asjad Atik. I live in Melbourne, Australia, and it's great to be back in Kiwi land after the lockdowns and whatnot. I'm a principal security specialist at Elastic. Some of you may have heard us from projects like Elasticsearch and Kibana. Full disclosure, my employer does build and sell a security solution, but rest assured, this talk is going to be completely vendor agnostic. My job is to work with customers across Australia, New Zealand, primarily kind of helping them observe and understand their IT environments. And from that observability, what I can generally then do is help them build threat detection, prevention, response type capabilities. And the whole goal is to defend themselves from cyber attack. I also recently published a book. It's called Getting Started with Elastic Stack 8. It focuses on making it as easy as possible for folks to learn and use Elasticsearch, Kibana, and all the technology around it for things like search and observability and security and so forth. Started off life as a software engineer and then turned into a guy that does the cyber things. My first job in security was really working with a group of analysts to help them do their job a lot more effectively, right? Like, give them the tools, technologies to help them be successful. So it's kind of like a long time spent in building security capability for defense. Before we get started, though, I just want to quickly gauge the audience here. Who here works on defending their environments, if I can get a show of hands? So about 30-ish% of the audience. Do we have any security analysts in the room, like folks who work in a SOC, use tools like SIM, endpoint detection software, things along those lines? Okay, so about 20-ish%, maybe. That's really good. So good audience. There's no kind of like in-depth terminology or anything like that. The goal here is to keep things as simple as possible and give you folks a bit of food for thought as you go away from this. So I think it's good to kind of start this talk by framing the conversation with a few trends and stats. The first trend is that our environments are more complicated than ever before today. There's just way more data than most security teams can collect. So I've put on the references here, by the way, so you can go and have a look at the stories behind some of these stats. But 2025, predicted worldwide data growth is 175 zettabytes. Like, that's just, mind-boggling volumes of data. I think I read somewhere that in the next 3 to 4 years, the world is going to generate as much data as all the data we had 5 years ago. That's how much volumes in data are growing. Now, I want you to think about when you're building your defensive capabilities, how much of the data that you generate as an organization do you actually end up using for your use cases? So just keep that in mind. The other trend is, a few of the stats, on average, we use about 288 applications to do our jobs. Think about when you log into your single sign-on portal or Okta or what have you, just think about how many applications, like how many new applications you see pop up there on a daily basis. Those applications are not only increasing the attack surface in size, but it's also the depth of the attack surface. So once someone gets in through one of those applications, they have more space to hide once they get in, which is, pretty scary to think about, especially if you think about the number of these applications. 64% of the organizations that were part of this survey are also looking at multi-cloud adoption. So as if a single cloud digital transformation wasn't complicated enough, we're looking at now doing that across multiple cloud providers. And 95% of our peers that were interviewed expressed some sort of concern around cloud security at their organization, which is not a great place to be, right, if you think about it. The second trend that I wanted to highlight is while we have that complexity around data and transformation and all that, adversaries are extremely motivated to accomplish their missions. So expected global cost of cybercrime by 2025, $10.5 trillion US. Like, that's just crazy. 70% of attacks using malware that leverage 0 days. 0 days are attacks that are vulnerabilities, attacks that use vulnerabilities that are unknown to the vendor or to the community. The average cost of cyber incident in Australia, $6.8 million. I'm sure New Zealand is somewhere around the same ballpark figure. And there's a 26% increase in the cost of a cyber incident since 2016. So what I'm trying to get at here is, on the one hand, you've got the complexities of defending your organization. On the other hand, there's this motivation and there's this whole industry that's built around taking advantage of that complexity and, of all the issues that we have as defenders. It's also worth understanding what the state of Secops is today. So what are the problems, right? It's easy to talk about the challenges, but how much of a problem do we have in being able to do our jobs? 80% of companies that had a cloud breach in the last 18 months reported that the breach was due to poor cloud visibility, especially across hybrid cloud. So, that transformation thing I talked about and how people are going on all these different cloud providers based on what those providers are good at, it's starting to give us a lot of grief. 90% of IT leaders also said that having silos of data, right? So having your IT ops data sitting separate to your security audit trails, which is then sitting separately to your endpoint telemetry, it's hindering security efforts and also innovation across the company. On average, we use 49 security tools to do our job. And alert fatigue is still not improving, right? Because all these tools say things that are not working and we just don't have enough people to go and look at them. And there's 93% of the alerts that are being generated that are not being dealt with on the same day. If you work in a SOC, you can probably relate to this, right? Like you're probably looking at all your alerts going, yeah, I don't trust the tool, that's broken, that's a false positive, I'm just not gonna deal with it. And also you've got other priorities. So, there's no humanly possible way of going and dealing with them all. So what do we do? Look, the solution here is not to buy more tools. I know it's very easy, I know it's very tempting. Our security folks love working with shiny tools. Thank you. But the solution is to not go and buy just another tool, another point solution to go and fix your problem, right? You kind of need to take a bit of a step back and start thinking about what you actually want. What do you actually want to achieve when you're looking at all this complexity, all this this problem space in your organization? So what do we actually want? I think this is the wrong slide. We definitely don't want to be binging our favorite TV show instead of working. What we actually want, and this, by the way, I don't think has changed for a very long time. But what we actually want is we want to reduce the dwell time that attackers have in our organization and the associated damage that comes with it. I think that's a fair statement. That's pretty obvious, right? Like the last thing, like if someone managed to break into your network, the most important thing that you want to do is kick them out as soon as you possibly can. The second thing we want is we want to improve our ability to respond and remediate, right? When we find out that something bad has happened, we actually want to take some effective response actions. The last thing we want to do is apply a blunt instrument across the environment. We want to do something targeted, we want to do something effective, and we want to do it in a way that we're not hindering the business and we're not pissing off the stakeholders that give us money to buy shiny toys when we do buy shiny toys. And the third thing is we want to have more smart and informed investigations, right? A lot of people in security talk about the needle in the haystack and so forth, but the last thing anyone wants to do is just dive into a haystack not knowing what the hell they're doing or what they're looking for and what the needle looks like, right? What you actually want to do is you want the tool to you want to use technology, and you want to use everything that you have at your disposal, tools and data and so forth, to tell you what you should be looking for and to guide you through that investigation. Because as a human, you want to apply your intelligence, understanding and contextualizing a threat, not necessarily just looking for things aimlessly, going down rabbit holes. So what does that mean for your SOC? So this list that I've got here is kind of I don't want to say a laundry list, but it's kind of like the high level of what I see across all of my different customers at Elastic. When people think about Secops, this, in a nutshell, is what they're trying to do, right? Not all of them do everything, and the important thing to note here is there's no one-size-fits-all, right? Depending on the size of your organization, the types of attacks that you are concerned about, and the type of adversaries that you're going to attract, the priorities and importance of these things will vary. But at a broad scale, these are things that you should consider. The first thing that you need to think about is plugging visibility gaps and collecting all the data that you actually need to build your defensive security capability. And you need to be able to do this at scale, right? If you set up your data collection processes or workflows, you want it to work when your environment is 100 people large or 100 endpoints large, but you also want it to continue to work when you then grow to 500, 1,000, 10,000, or when you go to a cloud provider and you have that exponential growth that most people often do. So you want to think about that, right? Like, where are your gaps in visibility and how are you going to go and plug it? The second thing you want to do is you want to bring together the different silos of data that you've got lying around your environment. A few people kind of talked about this throughout the conference, right? Like there's a lot of value in being able to collaborate and use different insights that are being generated across different parts of your company, right? A good example here is your SRE team or your IT team is going to collect a whole bunch of information around the performance, uptime, reliability, stability of your business critical applications. From a security perspective, isn't that just a goldmine of understanding how actions from a security perspective impact business critical capabilities? but not a lot of us end up using that information to actually come to the right conclusions. So it makes a lot of sense to think about how you bring those silos together. You also want to reduce the number of false positives, right? This is obvious, right? When a security tool tells you something's gone wrong, you want to have a high degree of confidence that this alert is legit, so that you can justify spending time and effort understanding, contextualizing, and responding to that thing. So you want high fidelity detections. Touched upon this before, you want your tools and your technology to inform and guide your investigations. And you actually also want to close the loop between your detections and your remediations, right? Remediations are always going to be like a maturity thing, right? Like you're not going to have all your remediations be at the best point that they're going to be on day one. But if you're able to then take the learnings from that, if you're able to tie that back in and close the loop between remediation and detections, and namely this means things like tuning and so forth, you can start getting a lot of value for your SOC. So let's elaborate and let's go into each of these and understand what I mean here. So, and like I said, we'll kind of stick to simple terms here, right? Because we're talking about these concepts, and I want you to go home and think about what this actually means for your company. So first problem is you've got a bunch of computers. The first thing you want to do is protect them, right? Because that's where your attackers will start. That's generally, when you do your attack modeling, that's generally where the entry point is. So if you can protect them as much as possible, apply preventative capability, do that. Some of these sit on a cloud somewhere. The rest sit under someone's desk, right, or a closet or something along those lines. You need to collect a bunch of data off these, namely things like logs, metrics, audit trail, endpoint telemetry. You want to understand what's happening on these things. So that's where you start. Now, part of plugging visibility gaps is you also should think about how you can do this continuously, right? This is not a static thing where you've got a few endpoints and you've understood what the workloads are and you've gone and set up some log collection. You actually need to be able to continuously collect and onboard this data as you go along, because you're not going to get everything on day one. So think about things like how you collect from every corner of your environment. Think about how you evolve alongside that data source, right? So as you're updating applications, as technologies evolve, the actual logging is going to evolve. The telemetry that it gives you is going to evolve. So think about how you can actually be on top of that. Process and understand and contextualize this data before storing it. Don't just blindly collect all your logs and metrics and dump them somewhere that no one's going to go and use. Actually think about how this is going to be useful for you. Now, granted, like you can't boil the ocean, up front and do all of this work at once, but make a bit of an effort just thinking about the value in some of these data sets. And as part of that, also think about how you can enrich this data to increase the value in downstream use cases. A good example is, if you've got a bunch of events with an associated user, think about what other context you've got in your environment that can paint a picture around what the user is, right? So if you've got, say for example, AD or some sort of HR data, enrich the information with the user's title, enrich the information with are they on leave or not, enrich with what the risk for that user is, what their job title is, things along those lines. Because when you then do your detections, that's context for you. And then don't be afraid of the data volumes. A lot of SOCs out there will kind of make very conscious decisions around, hey, like I'm going to drop this data source, so I'm going to heavily aggregate and summarize this data source because it's just too much volume. I just don't want to deal with it. But when you actually think about building hi-fi detections, you need a lot more than just error or audit logs, right? Like that telemetry, the information actually gives you a lot of insight in being able to build those detections. So use technology effectively. There's lots of very scalable, cheap solutions out there, cheap technologies in the open source ecosystem as well, that'll actually help you deal with this. Don't be afraid of the volume. Think about SLAs on timely ingestion and your SOC, right? Like when you have an event that happens in a corner of your organization, it's not good enough to get that event 48 hours later, right? When the attacker's gone in and wreaked havoc and already left the environment. you actually need to start thinking about how reliably and quickly am I getting this stuff into my SOC so I can deal with it and process it. And you also need to be resilient in being able to handle peaks and troughs in your volumes. So classic example here is, holiday season or Black Friday sales type things, right? Like when your business is actually, going through its seasonal peaks, you don't want your security to start lagging behind. And then also think about the layers in your technology and operational stacks. So think about the physical world, think about the platform, cloud, or provider that you're using. Think about the hypervisor or the bare metal that stuff ends up running on. Then think about the host OS and the appliances and all the ancillary stuff around that. Think about the software, think about the containers. You get the idea, right? So start from one end of the spectrum, go to the other end, think about all the different layers, and think about what visibility is important for you. And then lastly, think about, is the visibility that you're getting good enough when you're actually having a bad day? Because that's when this stuff matters the most, right? And the last thing you want to do is when you're having a bad day, you start thinking about what you then need to have visibility on and then go and introduce like really bad point solutions to deal with that, which you're then going to be stuck with forever. The next thing you do is you take all that data that we talked about and you store that on a bunch of these 3D printed save icons. This will prove to be a very smart thing that you do in the future when you actually need that data. So this is, I'm talking about making your data sets usable and interoperable here. So think about, what's meaningful data retention for you, right? Like, are your archives actually usable on a Friday afternoon? We talked about this before. How long can you look back for indicators of compromise or indicators of attack? Patterns that you're interested in, right? Like sequences of events. Think about, how far stealthy adversaries will go back. I think someone was talking about the SolarWinds stuff, and there was basically, there were a couple of months in between, initial access and then when they actually ended up, compromising or moving laterally within the environment. So is that retention that you have meaningful enough for you? And how quickly can you access and manipulate this data? Right? When your stuff is on fire and you run a query and your platform says, okay, cool, come back 6 coffees later, not really good enough. Like, you need to be able to at least get some insight relatively quickly so you can act on it. And then think about the data platforms or lakes or repositories or whatever your favorite word there is. But think about how they need to talk to each other. We touched on this before as well. IT ops, Secops, business data, right? How can you bring that all together? This also applies across different technologies like AWS, GCP, on-prem, so on. Also applies to geographies. If you work at a large, multinational org, they're going to have data that is generated across multiple regions. And generally, because of cost and things like that, people will keep that data isolated. And I mean, there's other good reasons why, things like, role-based access control. So obviously, think about what those requirements are. But having some sort of ability to bring those data sets together, to be able to do trend analysis and apply these patterns, is very meaningful. Your investigations will generally need to span across these data silos because your threats will obviously do that, right? If you've got a business-critical system and you don't have any visibility over that, kind of defeats the purpose of what you're trying to do. And things like DevSecOps type mindsets here, are very relevant to think about, right? Like, if your org, works that way, and the line between these different disciplines are a little bit blurred, think about how that applies to your security. And then, the benefit of doing all of this is if you do it well, you can have better collaboration and shared accountability. And in the process of doing that, you can drive down your costs and you can drive down the strain on your resources, which is good because while we all have a lot of job security, we're all very stressed in our roles, right? Because we have way too much to do. So it's a net positive there. So once you do all that, run your data through your security detections, which are these very cute German shepherds here. And the goal here is to look for known bad. There's a lot of research out there. There's a lot of intelligence that tells you, like, hey, what's known bad? And it makes a lot of sense to run all this data through that. So with detections, the goal, the kind of key thing that I see is the need to be able to pivot to an engineering mindset to actually build your detections. So things like using detections as code, peer reviewing detection logic, right? Testing it before you actually deploy in production. Ability to roll back detection logic, and having that audit trail of changes that apply to your detections. Measuring detection performance in terms of effectiveness to actually look for bad stuff, but also reducing the false positives associated with your bad stuff. It's all really, very sensible stuff. And this comes with maturity, right? This is not a day one thing that you're going to have to do. But think about how using these sort of techniques, you can improve the fidelity of those detections. The other thing that makes a lot of sense is, continuously mapping detection coverage to your attack model. And the visibility that you have. So, a lot of folks prefer using things like MITRE ATT&CK, but really it doesn't matter. Like, whatever framework you use to understand, the tactics and techniques that are, relevant to you and your environment, actually map your detections on top of that, because then you understand how much coverage you've got. It also makes sense to combine multiple detections or signals to create more higher fidelity overarching detections. A good example here is, you might have an alert from your endpoint software that says, hey, saw some run-of-the-mill malware. Cool, right? That's a good alert. I'm not saying granular alerting is a bad thing. But, so what? Like, it happens all the time. If you're able to combine that with another alert that says, hey, this user account sent in an anomalous amount of data to this weird destination that they've never interacted with before. And then you see, hey, this person's deleting a whole bunch of files on this machine. If you combine those three things together, it's a lot more meaningful and it's a lot more severe, right, as an activity happening on that endpoint. So think about how you can bring multiple little detections together, not necessarily acting on those little detections, but putting them together to look for more important, highly severe activities. Techniques like anomaly detection, right? Like, machine learning is actually your friend here. For a long time, the defensive security industry, looked at ML as a bit of a black box type technology, and not a lot of people trust it very much. But the technology's evolved since then. There's a lot of really good open source tools out there that can apply some statistical analysis to the data you're collecting to give you some context, right? That anomalous amount of data being sent out of your environment is a good example of that. You're not necessarily going to write a rule for that, right? Like, every person's got a different usage profile. You're not going to say, hey, this person's got 5 megabytes as their limit and the other person's got 10. But using some sort of statistical analysis to see how far this person's deviating from the norm is really, really useful. And then, as a follow-on to that one, you can also start using things like risk profiles on entities in your environment, right? Users, hosts, to start quantifying threats. Like, if they're doing a lot of weird stuff, if they're associated with a lot of alerts, start raising the risk around that user and you can take more, decisive action around them. Then, once you've done the detections, you can also investigate and hunt through this data based on findings, based on threat intelligence or hypothesis that your team has. And this is just as important as looking for the known bad, right? So you need to make sure the investigations that you're doing are actually meaningful. And what I mean here is doing things like contextual detection alerts, right? Like applying the timely intelligence and context around these. You can also do things like automating repetitive context gathering tasks. Generally, like, you see an alert, right? The analyst is going to have 10 different things that they're going to have to do that never changes. It's very run-of-the-mill. Automate that stuff, right? And that's a way for you to actually scale your bandwidth, scale your capacity. Look at effective ways of actually triaging. So I spoke about risk, but you can also think about occurrence. You can look at the sensitivity of that particular alert. You can look at the exposure. If it's tied to a critical asset or critical infrastructure in your organization, you're going to treat that a lot more with a lot more caution compared to someone's workstation. You can also use ML to identify some of the noise around your detections. So remember, like, alerts are also data sets, right? There's no reason why you can't use the same techniques that you do on your raw data sets on your alerting. And then graph and maintain entity relationships in your environment. Again, this is the maturity thing someone was showing you folks just before around the powers of using graph databases. Think about how you can apply that here. Think about how you can understand relationships between different entities, actions, and so forth. And then the last thing you want to do is you want to take the right response depending on what you find in your investigation or through your detection. So close the loop, right? Tie alerts to automated response workflows that are actually meaningful to your environment. There's no silver bullet here. Like, no one's going to be able to give you like a whole list of playbooks that you can apply to all the alerts that you find. These are going to be very specific. So someone getting malware on their workstation means that you're generally going to have to re-image their workstation. But someone, triggering an insider threat detection, right? Someone exfiltrating data out of your environment, you're going to have to do a very different response action there, right? Like, you're going to have to lock down their account, you're going to have to get in touch with your colleagues in HR and legal and so forth. So, think about what that means and automate as much as possible. You also want the ability to kind of reach into your endpoints and key bits of infrastructure to very quickly go in and act and block and remediate appropriately. The last thing you want to do is, once you actually find out what's going on, going and talking to this completely different team that's not part of your SOC to go and do things on your endpoints. You actually want that ability tied in very closely with your core tools and capabilities. And while you're closing the loop, you also want to bring back some feedback into use case development, right? So based on the things that you're finding, based on things that are triggering in your environment, you want to inform the engineering process. Ideally, that's done as part of the same team, right? Like with people specializing in different roles. But you want to bring that feedback into that process. So what do we end up with? You've reduced your gaps in visibility. You're keeping more of what your environment generates, and that's useful for your downstream use cases. You've got higher confidence in detections, and you've got the operational maturity in detection engineering if you've kind of gone through that process. You're now using your tech to guide your analysis, right? And your investigations, and the whole point here is take off some load from the analysts and actually get them to do useful things. And then lastly, you're now going end to end. You're closing the loop between detections and response actions, and that will hopefully help drive operational maturity even further. And the other useful thing, and a really good benefit, is your analysts are actually going to be far happier doing the role that they do, right? They don't have an easy job. Like these folks literally live in this loop of look at an alert, understand what it means, either qualify it out or act on it, right? And it's like a very, very tedious, hard job to do, and that's why there's so much burnout. So actually help them have a better quality of life and make them happier in their role. And that's it. So Secops doesn't have to be as hard as some of us make it out to be. Take a step back, think about what your team needs to be successful, and just work your way backwards from there, right? Take a holistic approach. So thanks very much. Send me your questions and your feedback if you have any. This is the first time I'm doing this talk in front of such a large audience, so I'd really appreciate what you think. And if you're interested in the Elastic Stack, check out my book. Thank you very much to the crew here for putting up this amazing event. It's been great to be here.
Thanks very much, Sid. So, I want you to imagine that you work at a government agency. That's step one. Step two, someone walks into your office and says, and you probably have an office because the building is really old, so they actually still have offices, and someone says to you, okay, a really, really bad thing's happened. We're going to have to do everything completely differently, and we need to do it by next week, and we need to not get wrecked. Now, I want you to imagine what noise you would make if you were, I don't know, an architect responsible for all of this happening very, very quickly and not going horribly wrong in the middle of a pandemic. So would you like to make the noise that you would make when someone walks in and says that to you? Yeah, that's about what I imagined, and that is the noise that I would make also. So, in order to share this catharsis, I'm going to invite to the stage Mr. Patrick Hindmarsh, who is the person who made that noise on your behalf. So, big round of applause, Mr. Patrick Hindmarsh.
Cool, yeah, I can confirm I definitely made that noise several times in the last couple of years. So yeah, it's been a trip, that's for sure. So yeah, thank you all for having me today. As introduced, I'm Patrick. I was an architect at the ministry for about 2 years. Finished up just yesterday, actually. So I first joined the ministry on a Friday afternoon and then spent the weekend writing the first requirements for what would turn out to be the COVID Tracer app. And in the last 2 years, I've also had the privilege of working on pretty much every digital service that we've built as part of the pandemic response, including Book My Vaccine, My COVID Record, and the My Health Account service. And more recently was the technology lead for the vaccine passes and vaccination certificates for international travel. So if you used a QR code as part of the pandemic response, I'm terribly sorry, it's probably my fault. Obviously, views expressed in this talk are mine. I don't represent the New Zealand Government or the Ministry of Health, particularly not anymore. So if you take umbrage to what's been said here, come and talk to me, and we can see what we make of that. So today we're here to talk about the COVID Tracer app. It's one of the first of the digital products that the ministry shipped directly to consumers. There was actually another app that beat us out by a week or two that was for health workers, but this is the one that we're focusing on today. So I originally submitted this talk about a year ago. I was checking in my emails the other day, and it's about a year. And so things were quite different then. For those of you who are in New Zealand, you'll remember we were still in the middle of all of these public health measures, scanning quite actively, lots of things like that. So I'm going to take a bit of a trip down memory lane today just to remind ourselves about what that was like, because today it's quite different. Even though we're all here with masks and passes to get into the building, it was a bit of a different time back then. And then talk about what we did to secure COVID Tracer and the method that we took around doing that. So as mentioned at the beginning, we were having to learn about a whole lot of new stuff really, really quickly and change our ways of doing stuff really rapidly, and make sure that we did that without breaking anything or getting popped. So to take us back a little bit, at the start of the pandemic response, and for the first 18 months or so, we operated this elimination strategy. For those of you in New Zealand, you'll remember that pretty well, I would hope. The idea was, if we found COVID in the community, we would work really hard to stamp it out, get rid of it. We had no tolerance for it circulating, right? If a person tested positive to COVID in the community, they'd get a phone call from a contact tracer. Typically, that person would be, from their public health unit, local to their region, and there'd be a bunch of case interviews that would happen to understand where that person had been, who they'd been in contact with, and assessing the likely risk of transmission for that person having passed the virus on to other people. That involves canvassing possible locations of interest, so places that you've been where transmission might have occurred. Could be places like home or work. Could also be places in the public, like on a bus. And then linking those locations of interest to close and casual contacts that you might have exposed the virus to. And then finding out whether those people need to be traced and isolating as well. Typically, this would happen over the phone. A couple of case interviews might happen. It would take usually about an hour or two to do the case interview, sometimes longer, sometimes less. The main challenges that were related to that was actually just getting in touch with people, getting phone numbers and contact details and finding people the first time was one of the more challenging things to do. Helping people remember who they'd been in touch with. So there's two aspects to that. The first is people that you don't remember being with, and the other one is people who you don't know. You know you were with, but you don't know who they are. And then the last thing was consistently identifying those locations of interest. So if you talk to one person on the phone, they say, I was at this place. When you talk to another person on the phone and they say they're at the same place, they need to use the same kind of language to describe that place. You might have someone who refers to a cafe by one name or a different name. And it's really important that we link those things together to make sure that we're tracing people the right way. So the main problems that the app sent out to solve in the beginning there was two really in the first requirements document that we wrote. The first one was getting up-to-date contact details from people. It sounds like a really dumb problem, surprisingly. I remember this is the first thing that I got tasked with when I joined, and it's really down to the fact that New Zealand doesn't have a national register or a centralised register for contact details of people. We've got something kind of like that within the health system called the National Health Index, but it's based on data that you give to your general practice typically. So for the most part, the data that's in that set is up to date the last time you went to your general practice. Now, I don't know about many of you, I certainly know when I've moved cities, it took me about 5 years to go to my GP again. And so the details that they had for me were my parents' home phone number and my mum and dad's old address. So we knew at the time, we figured at about the time about 70% of the details in the NHI were up to date, but we didn't know which 70% was up to date. And so that was one of the big challenges we had to start with. This also doesn't account for people who are visitors to New Zealand, tourists and what have you, because if they don't interact with the health system when they come to the country, they have no opportunity to load their data into that register. The second problem we set out to solve was help people remember where they've been and who they've seen. So this is actually where most of the work went, primarily because it's actually quite a hard sell to say to people, give us your contact details without actually any other benefit or help to them to get them to download and use an app like this. So human memory is pretty bad at this kind of recall, particularly when you're in a stressful situation where you've just been told that you might have COVID. So knowing the places that you've been to and who you've been with and having a record of that you can refer to is really helpful for speeding up the investigation process. So lots of the time, the people that you've been with, the people in your household, you'll probably remember them, but quite often it's also just random people you don't know. And part of the contact tracing process is designed to try and find those people as quickly as possible. And so we were doing this within a pretty risky kind of environment, so there's a lot of complex intersections of requirements and politics and changing knowledge about the way the pandemic was working. And so a core part of contact tracing is creating links between people, building a social graph, and mapping out that social graph to manage risk and transmission. And at the time, there was plenty of concern about the privacy of doing that. It's by design quite a privacy-invasive process. You might remember there was a flood of check-in solutions that came out. There was lots of QR codes all over the place with solutions collecting data, mostly centrally. So the idea was they'd digitize that paper-based form that you'd find at the front of places that you'd go to and store it in a central database. We had reports in the media about data from that being misused. You might remember there was a guy who worked at Subway who used the data or used the record off a paper-based register and used it to harass a customer, which is pretty not good. And those are the kind of things that were really visceral for us at the time when we were trying to build this, was how do we make sure that we build something that people are going to trust, that they're going to understand, and it's going to give them control over what they do. There's a general trust and skepticism of government motives and ability as well. You know, we don't have a great reputation of building good technology in this space. And that's for good reason too, you know, and part of my thing was, you know, I can get up on the stage and tell everybody, hey look, you know, trust me, I'm doing the right thing. But I don't have, not everyone's going to do that. And so our solutions had to take into account that distrust and that fear about surveillance and overreach. And whatever we built needed, so that means whatever we built needed to be technically privacy preserving. We had to make sure the technology and the security and all that stuff worked, but we also had to be visibly seen to be doing that as well, because it's no good to build great tech if people don't see that you're doing the things that they expect you to do, which is where social license and expectations around technology come into it. So social license is a very, it's a nebulous idea in some senses, but it's the concept that the public gives a service like this a license to operate based on the comfort that the public has that we're doing the right things in line with their expectations. And it's not something we have to earn social license. It's not a thing that we can buy. And so we had to do that by demonstrating the work that we're doing. And if we didn't do that, it didn't matter how good the tech was, people just simply wouldn't use it. From a technology perspective as well, there's also plenty of complexity. We're working in an environment that was unfamiliar to the ministry at the time. The first consumer-facing application on using cloud-based tech. Most of the technology there, and this is a little bit uncharitable, but you know, the typical approach was chuck everything behind the F5 and we'll be fine. Can't do that with this kind of application. It's not really the kind of thing that works that way. So we had to do this really quickly as well. As Metal said, you know, it wasn't that far from the truth. I joined the ministry and they said, right, we've got a week, we've got to ship the first version. The Prime Minister expects it in 2. And we were like, well, okay, you can't really go and tell your stakeholder to go out to go jump in the lake at that level. So we started, built something quickly, iterate to make it better, but we couldn't skimp on the privacy and the security aspect of the solution to start with. It just wasn't an option. And so those two factors combined meant that there was a really seriously high risk that we were going to make a mistake or do something wrong, and finding out the hard way at one of those 1 p.m. press briefings that we'd done something stupid. So that was one of the things that drove us quite a lot in the design of the solution and how we did it. There also really wasn't a whole lot of existing, this is what good looks like. We didn't have a whole lot of existing international examples of this. The Bluetooth-based proximity tracing and things that we're all used to now Apple and Google hadn't even announced it at that point. Singapore had done some interesting stuff, but it was still very, very nascent. And with something this high profile, and for as I mentioned, the lots of parts of the population found it quite controversial, there's always a risk of the bad people doing bad things for their own gain, and so we had to make sure that we were ready for that too. Underneath all of this too was just this general uncertainty about what the future held. We didn't know what was coming. It's quaint to look back in hindsight and see where we are now, but at the time we had no idea. We were getting new and changing requirements almost daily. We were having to be really reactive and to changes and pivot to understand what was coming and how we needed to build technology to better serve the contact tracers. We also had a contact tracing business that was actually really just focused on contact tracing, trying to sit down and say, hey, we'd love to talk to you about an app that can make things better. They're just like, cool, I don't care, I'm really busy. So we had to really make the most of the time we had and make some really smart decisions and then get on with it. And doing all of that in a really unusual working environment, I spent, everyone was remote, obviously. I never went into the office for the first couple of months, and I've never spent so many contiguous hours on Zoom meetings. I'm pretty sure all of you would be the same, but yeah, I think, starting the days at 7 o'clock in the morning and finishing at 9:30 at night and spending the whole day sitting in a chair on Zoom was not something that I'm keen to go back to. And on top of all of this, the daily media briefings and public scrutiny we had meant that any mistake that we made would be amplified ridiculous amounts, and so we just had to be really, really conscious about that. So what did we do? Well, we built this app. All of you, I'm sure, were just absolutely thrilled to download it on the first time it came out. It has, so the first thing we did was actually build a website that you could give us your name and phone number with, and demographic information like address and gender and things that help you remember, help us find you if we need to find you amongst the population of people. We saved that in a database next to the contact tracing system so that they could search for it while also not mixing it up with all of the other contact tracing data that we were keeping. And a digital diary that kept a record of where you'd been and the places that you'd been with in a database locally on your phone. You could create those entries by scanning a QR code like the one on the screen. If you've got the app on your phone, you want to scan that, you might get some little things. And then that QR code had a unique number in it. The idea was that you could we'd use that number to be able to link the same places together, and later on we made it so that you could manually record entries as well. Putting the diary on the phone was one of the more significant decisions we made quite early on, and it was a deliberate trade-off that we made with respect to the privacy versus usefulness of the app. So having this kind of data in the cloud, the idea of this massive database full of people, places where people had been in any form, even if it was anonymized, was something that we didn't really like the idea of, and we tried really hard to avoid a situation where we would do that. The main drawback with that approach was that it didn't give contact tracers any visibility about the potential exposure of places unless someone contacted us. So there's no way for us to know that, which was a real challenge. But one of the things, like I said, that was one of the trade-offs that we made between privacy and utility for the contact tracing team. We did consider this kind of middle ground where we'd upload this anonymous identifier and then try and map it back and do all this other crazy stuff, but in the end we figured it just muddied the message. And so the message that we got to was really simple. The data that you collect via the app sits on your phone, it stays on your phone, and it only leaves your phone if you choose to share it with us. And that gave people a lot of agency about controlling the participation that they had with technology, because ultimately for us, the use of the technology and having the record, even if you never shared it with us electronically, was still better than not having it, because when you're on the phone, you can read it yourself. And that turned out to be a really good call, because when Bluetooth tracing specs came out a couple of months later, they followed a similar approach with the data being on the phone, the user initiates the sharing, and the detection of the possible exposures happens on the device as well. And even more reinforcing later on was Apple released some requirements around location-based data collection, so basically what we built, and the requirements were exactly the same. So we didn't have to change anything, which was really good. For the QR code posters, we experimented a little bit. I remember trying to come up with a spec for this, and it was very rapid. But my main, so we looked at the things like data matrices and Aztec codes, we looked at other ways of encoding it, and in the end we settled on a QR code with a base64 encoded JSON blob. And we all know the trade-off of that was just these really dense QR codes, and it's one of the most common pieces of feedback I get from people was, why is the QR code so dense? But I chose this primarily because the QR codes and JSON decoding are really well-established technical patterns on mobile. So there was good battle-tested libraries that we could use to generate and parse them. And the major concern was, at the time, what happens if we have a bug in the posters that when someone scans it, it causes some weird thing, and we have to get everyone to reprint the posters again, because that would be a disaster. So the front-end apps were initially built using Swift and Kotlin, using native tech, and then later migrated to React Native when Bluetooth tracing came along. In the design, we treated the apps like they were untrusted. We said our security boundary was our cloud services, and the app, we just assumed that someone had done dumb stuff with it or were doing naughty things with it, and we let that kind of run on its own. We obviously had security controls on the phone, but our main security perimeter was in the cloud, which was really important to how we structured our security approach. So all of the back-end stuff was on AWS, using serverless and API-driven architectures, and it was following all of the AWS well-architected best practices, which made it really easy for us to get going and get things done quickly. So by the numbers, there's a whole lot of really big numbers with lots of commas in them. The ones that I'm most interested in here or the ones that I think are the most exciting, and this is really down to the team that was running this in the last little while, was the Bluetooth tracing numbers there. So you can see we've got 81,000 at the time, 81,000 devices that have shared Bluetooth tracing keys, 300 and something thousand alerts that have been sent to people that might have been exposed via Bluetooth tracing. 804 million scans of QR codes. I mean, that's a bit of a vanity number, but it's still very big, which is nice. One of the things that I thought was quite cool was if you're a person who used the app and during a case investigation, it reduced the time. There was one instance that I was talking to our contact tracing team. They said it reduced the time from 8 hours to 1 hour to send out all of the location alerts to that person's potential contacts. And if you think about that in the context of a massive outbreak like we're having in Delta, that's huge. That's a massive time saving for something that seems quite trivial. And so that was something that I really enjoyed, different to these numbers, which are just the sort of the vanity metrics, I guess. One of the other things that's interesting, 3.6 million people registered their contact details with us, which was really cool. But we're also just going through the process, in fact, just did it last week, where we're deleting that data now because we don't need it. So we've decommissioned the ability for you to register in the app, and we've deleted all that contact information because we've got better sources for it now, and that was in line with some of the privacy commitments we made in the app early on. So to talk a little bit about the security assurance process, I'm not in the security team. My security friends are all sitting in the audience somewhere today, so hopefully I say things that they agree with. But the COVID Trace, like I said, was the first digital product we shipped, and it was the largest direct-to-production app that we'd ever done before. So when we first started, the security process was very much the sort of standard CNA, security and accreditation process, designed for enterprise and sector-facing IT delivery. It was pretty reactive. It tended to be the gate you got through at the end, so you'd go and do all your work and you'd get to the end and they'd do the assessments and tell you all of the things you'd done wrong, and then you go back and fix them, which was a line in the sand approach that was intended to be done every couple of years, but it was really inhibited. It didn't really work for rapid iterative development processes. Some of those early releases had some really ridiculous deadlines. I'm not sure if any of the pen testers that pen tested the app in the early days are in the room. If you are, I'm very sorry. We gave you like a weekend to test the first version. It was insane. And they did some really crazy hours and went above and beyond to make the app, to make sure the app was built right, and I'm really grateful for the work that they did. But it wasn't something that was going to scale. We were going to burn people out like crazy if we did that for too long. We also took a policy-based approach to setting controls. For those of you that remember, the first version of the app required you to have a username and password. You'll also remember it required you to have an NZISM-compliant password. I don't know how many, all of you, I'm sure, have NZISM-compliant passwords because you're all up to speed with that, but most of the public don't. So most people, when they registered for the app, they had to make up a new password they'd never used before. And then when they got logged out after 30 days because of a different bug we found, or a different design decision we found in the Amazon's Cognito service, everyone had to reset their passwords again. So the most common flow was people would log out, they'd try and log in, they'd forget their password, they'd reset it, then they'd come back in and they'd reset, and that would happen every 30 days. It was just a massive complexity that didn't really add any value. But because the only thing that we had in the toolkit was NZISM, that was what we used. And so we didn't have any pragmatic ways of thinking about policies that could be applicable in a consumer scenario. So as we started building more things to support the pandemic response, the COVID Trace App being the start of that, the pace of building things didn't slow down. We realized we had to adapt. So the security team introduced this concept of shifting security to the left, which means our security team gets more involved in the design and the delivery of the apps as we're building them, as opposed to being something that they assess at the end. That ended up being something I was incredibly grateful for. So by the time we'd get to the building and the release of the app, a whole bunch of collaborative work had already been done with the security team to effectively set controls and make pragmatic decisions about what we could and couldn't do, and that was baked into the designer's solution. And it means that the results of the independent penetration test and the assessments that we did at the end were way more predictable and less likely to derail the go-live dates, which was really important for us at the time. That also changed the perception of the security team to be from people who are quite, I'm sure some of you would like to not have this, but there's often a reputation of security people saying no. They're the people you go to if you want to have no told to you. And they always mess up your best laid plans. We had a go live date and the security team said, nah, it's insecure, and now we have to go and deal with that, and it's the security team's fault. And that's not what the reality is, right? But what happened was that the security team that we work with, shifted to be a team that's there to help us safely and proactively work together to get things done with confidence. And that shift happened, where they started becoming more proactive, more involved in the design stages, and bringing in great tooling and processes that helped us do things with more confidence. And that didn't happen overnight, and there's a bunch of really smart people, and we got really good backing from our exec and our leadership as well to focus the role that security played to get it as early in the process as possible. So they set out that strategy to change. It was fueled by an organization that had some crushing deadlines and some crazy demands, and we changed the security culture of the business in a couple of months. And I think that's no small thing, and I think the outcome of that now is that health has a much, much, much better and richer way of managing security events and managing security delivery that's just come naturally to the way that the product teams work. So, yeah, like I said, now we've got this dedicated security staff working alongside our dev teams. They participate in regular activities like sprint planning and stand-ups. They coordinate the assurance activities, manage comms with senior stakeholders, all of that stuff, right? There's documented best practices about how to do security architectures and things in cloud environments that baselined against the NZISM and the Health Information Security Framework. We've got tools integrated into SIEMs, and we've got SOCs that look after keep an eye on things. We've got automated CI/CD pipelines with static and secret dependency and dynamic security testing using GitLab and Tenable and stuff like that. We've got automation that looks for stuff on top of those regular assessments that we do, so our team can focus, and the security assessments can focus on doing more high-value manual testing, which I think is really, really powerful and really valuable. And these tools are really, and these processes actually really now just give the business leaders the confidence that we've got security and privacy under control. And it gives us more freedom to actually go and build the interesting stuff without having to spend a whole lot of time justifying why we're doing it. And so the attitude for security is much more now about how do we make this happen as opposed to how do we work out why it's bad. So how do we make it happen becomes the thing that means that we're way more collaborative and we work together way better. One of the other things we did was open source the app. So on GitHub, you'll find repositories that have the source code for the front end of the application as well as a documentation repo. We weren't really mature enough to work in the open as much as I'd like to have. A lot of countries did, but we didn't have any practices and processes for how you would manage code in a public space like that. We're also pretty concerned about the idea that those repos would get brigaded by people who disagreed with the way that the government was responding to the pandemic in general. And it took longer to open source it than we wanted to, but we got it done by the end of 2021. End of 2020. So the great thing about the open sourcing was that it increased the transparency around how the app works. So it was one thing for us to tell you that it looked after data and it kept it on your phone and didn't share it, but it's another thing for having people with expertise to go in and actually assess that for themselves. And I think one of the other things that I was really, really, really keen to see was that by us doing it, hopefully it gave other particular government departments an opportunity to say, well, if they've did it, we could probably do it too. The idea that software that's built with public money should be made publicly available is something I'm really passionate about, so I hope that that's something that really sticks as an enduring effect for the work that we've done. I did want to give a shout out to the folks that did the NZ Goal, so the New Zealand Government Open Access licenses software extensions, which is published by Stats NZ. So that's a really great framework for if you're working in government or you're working in a sector that you're trying to decide how do we open source, what licenses do we use, how do we make sure we've got commercials with our vendors sorted out. That framework's really good, and they've done a lot of really awesome groundwork, which was helpful for us. So it helped our legal team choose what licenses we would work with, and all sorts of stuff like that, which was great. The open sourcing was actually helpful because it made me have to document the things that we'd made in a more technically focused audience. So it meant that a bunch of the questions that I'd get about how things worked or why they worked that way, we could just publish them on GitHub and it was already there. And that was also a really helpful thing for us to do too. The other thing that we did, which I think was really pivotal to the success of the program as well, was to create a vulnerability disclosure policy. So we didn't have to start from scratch with this. We've got to say a big thank you to the security team at MSD for helping us get a good starting point. But this was another one of those really helpful tools that, like automation, was one of the things that set expectations around and another layer of confidence around how we were managing the security of the services we were building for COVID. It's important to have a clear scope for those, though. We had a lot of potential scope across the health system. The Ministry of Health at the time had a very policy sort of focused thing, and all of the execution of health is managed by, at the time, DHBs. So there's a lot of things that we're not actually directly involved in, either through delivery or actually even just from an accountability perspective. But we did get plenty of low-value reports about, like DMARC not being configured on domain names we don't even own. But we did get a handful of useful reports, and it was really good for us to be able to have that there. And for something that's this visible, for something where we're publishing it, and as soon as we publish anything, it goes straight onto the front page of the news. An absence of reports through that framework or that policy was actually really indicative for us that we're on the right track as well, which I think was really good. And I also think that the VDP was actually one of the more valuable things when you ended up with inquiry or concerns well-founded or otherwise, from the public about whether the apps are built the right way. You know, you get someone who goes and just points an online tool to check your configuration of your SSL certificates and then writes an article about how it's really bad. It's really helpful for us to be able to point at things like the VDP and say, if you found vulnerabilities that you think are exploitable, they're actually impactful, come and talk to us. We're going to work with you to sort through that. Our focus is on getting security done right, not just telling you that it's secure and not asking for your help. So that was a really useful public policy position to have, so that we could point people to that and say, if you've got a problem and you think it's going to be bad, or even if you don't think it's going to be bad and you're not sure, come talk to us. And so it's clear that we valued people's we value their expertise, we support them to safely report it, and we'll be confident and provide confidence that we'll respect them in the research that they do, which I thought was really, really important. And so, takeaways from this, COVID Tracer was used by a lot of people every day to track where they've been and who they've been in contact with. It's a lot different now. I don't know how many of you opening it and scanning that QR code is probably the first time you've done it in months. But for me, being part of this, especially in the early days, was a really amazing opportunity. It was a privilege to be part of the team that put this together. There was a lot of people who worked some really hard hours to get the tech done. And I think, I'm confident that we made a difference in the response that the government put together. And it's not every day you get a chance to design technology that's used by pretty much everyone in the country. You get to walk around and see the posters that were designed and have it be so visible as it was. So I think one of the key things for me was focusing on the privacy-focused design of the solution, and giving people control over their data and how it's used resulted in a much more secure by default design overall. And it meant that we were by not aggregating data in the cloud, for example, meant that we don't have that huge target on our backs. We're not having to worry too much about how we do that. It might have been easier for us to put data in the cloud, and actually there's plenty of arguments I had with people about how that's what we were doing, even though, I could quite confidently say that's not what was happening. But we reduced the risk position of the service both from an accidental disclosure, us making a mistake, as well as someone doing some deliberate malicious activity. Even though we were working in some unusual environments under some ridiculous time pressure, we still managed to ship and continue to ship things that balance the security and privacy and usefulness of the service that they provide, and make sure that we were actually delivering things that provided value. From my perspective, our security team did a really great job to evolve to meet business need. There's no way we could have shipped the things we shipped with the confidence we shipped them with without having the security team evolve to do that. Not just for this project, but across the board, right? And as a result, we've got this more responsive, more integrated, and more involved security practice and process across Health New Zealand now, which I think sets us up for a great success in the future, which is awesome. Security is seen as an enabler rather than a blocker, and for me, as someone designing new things, I'm not afraid about engaging the security team in case they say no. I'm actually more interested to see what tools they can give me to make things better. And the things like automation and open source, the vulnerability disclosure processes are really great for shaping expectations and experience, both internally and externally. So internal culture is a really important thing for us to do around how we do security and how we manage it. So positioning these things as net benefits to the security posture of the organization rather than things that we do as a cost are really important to change attitudes around the way that security works and in the role that it plays in the trust of product development and the trust of the products that we build. So by doing these things, we built technology platforms that withstood the public pressure and the public scrutiny that was well-deserved. They deserve to be scrutinized, but we managed to stand up against that scrutiny across the whole COVID portfolio, which I'm really proud of. And the iterative process that we followed in getting that foundation right was really important, but so was adapting and learning to the new things as we got new requirements and built new things and received feedback. So that's the end of what I've got to talk about today. As I mentioned, there's a lot of change going on in the health system at the moment. Just yesterday we had the new Health New Zealand organisation get formally ratified, and there's a lot of really interesting work that we're taking from COVID to start applying across the health system. So if you've got an interest in that, keep an eye out, reach out to some of my colleagues in the health team. I'm sure they'd love to hear from you. Otherwise, thanks very much for having me, and have a good rest of the con.
I think for a lot of people in the world, New Zealand's response to the pandemic is a thing that they see as having been done, very, very well. And we are in many respects, the envy of the world. And it's through the hard work of people like that. I mean, you can imagine how much work, what it was like in that environment. And I think, we're all very, very glad for the sacrifices that all of the people, working in the health sector have made for us all during the pandemic. So if you want to give us a... And it's also one of the things I really love about this community. As I said, once upon a time, Kawaiicon, we thought we were underground badass hackers, but actually the reality is, this community is who is at the forefront of all sorts of things that are just really important and really matter in ways that they never did. And I'm really proud that we can come together, and learn from that, that we can come together and find employment, find ways to help, and really contribute to the safety and security of our society and our friends and our family and our whānau. So yeah, having talks like that on the stage makes me really happy and really proud. Now, one of the things I'm less proud about is that as attackers, we kind of just show up and bust stuff, and TBH, it's pretty easy. Because it turns out that actually building secure things, especially at scale, is legit hard. And showing up and just sticking a couple of backticks or whatever in the search box and whoop-de-doo, it's a Perl script and we've got command injection, it's not that difficult. So I'm always in awe of people who do manage to build very big, sometimes very fast scaling projects and do so without things going horribly wrong. And so, on that note, it's my pleasure to introduce to the stage Candace, with a K, like Kubernetes. But not evil.
Hello. I was so worried I was going to trip over on the way here. I was making jokes backstage. I should have just dropped to the floor. Get it out of the way early. It was freaking me out. So I'm Candace. I'm talking today about treating security as a product. I have 2 really cute cats and a really cute dog, so I just wanted to share them with you. I'm currently a security product manager, so I have a team of product owners. We don't actually work for a company that makes a security product. We don't do firewalls or anything like that. We're a security team within a bigger organization that serves the rest of the organization to make them secure. But I haven't always been in product. I haven't even always been in security. I'm actually relatively new to the tech industry. The majority of my career, right from when I was 14 and worked in a cafe up to when I was 24 and I was working in call centers, I was in customer service. And that is a great job, let me tell you. I really just so enjoyed all of the interactions I had every day where I tried my absolute best and nothing was ever good enough. And I loved it so much that I decided that I needed to go reskill in something where I would get the most minimal human interaction possible. So I chose engineering, computer engineering, because engineers don't have to talk to people, right? We never, ever have to talk to each other or the people that use our products. So I went and reskilled. I got a network engineering degree, and then I got my first role out in the tech world as a systems engineer. And the first thing that I built was this private cloud. And I was quite proud of it. I automated a whole lot of stuff, it seemed to run pretty well. I thought it was quite good. My team seemed pretty okay with it. The people that weren't okay with it were the people that actually had to use the thing. After being a systems engineer and doing kind of platform stuff, I moved over to being a security engineer, and I kind of found the same sort of problems happening again. I was working on these really great tools. Our purpose was amazing. We're there to build the stuff that keeps our customers' data safe. Our organization's data, that goldmine. We're keeping people safe. We're being superheroes, and we're using this really amazing tech. And I'm working with these really great people, and we really care. But it was just more of the same stuff. We all thought it was doing really good, but no one that had to interact with the tools liked it. And it kind of felt like security was sort of public enemy number one. When I told people I was in security, it wasn't a smile that they gave me. It was more like a... After being a security engineer for a while, I got the opportunity to be a team lead for a security team. They weren't the team that I'd started in, but they were a team that I knew of, and they were pretty great. So I got put in charge of them for 6 months. And I was young, I was full of enthusiasm and energy, and I just wanted to make the world a better place. So I started out by going and talking to all these leaders that I knew of that seemed really, really good, and without fail, they all gave me the same advice. Don't change anything. But I have a bit of a selective hearing problem, so what I really heard was this. That poor team. I mean, I did listen for like 2 weeks. I did spend about 2 weeks trying to get a handle on things, see where the team are. What I found was that I was working with a team that were incredibly skilled, incredibly high-performing, that really, really cared about the work that they were doing, and they were really, really good at it. But there were some problems. It seemed like they weren't actually producing anything. They had a lot of things going on at the same time, but nothing ever got finished. So I found that when you're not producing something, if people can't see that you're finishing work, they always think that you're not doing anything. So we kind of set out to try and change that. This was the first thing that we needed to tackle. We had this Trello board, and it looked like the digital version of this. There were so many cards. The team had tried to wrangle them into kind of columns, but there was just so much there. It was really hard to kind of conceptualize what was going on. And out of 300 cards or so, there were 297 top priorities. So 297 were the high priority, and then the other 3, I guess, they didn't matter too much. So I kind of looked around the business to see what everyone else is doing, and everyone was using Jira. For some reason, everyone was using Jira except the security team, so I was like, okay, maybe we should align with literally everyone else in the organization. So we created a Jira board. We kind of did a loose Kanban sort of style, and we ported all of these cards over. And actually, while we were porting them over, we found some cards were no longer relevant. We found duplicates. We found stuff that had actually already been completed. They just got so lost in this massive board of nothing. So it was really good. It meant we cleaned it up a little bit. And I say a little bit because even once we moved to Jira, it might not look like this, but it still wasn't pretty. There was still a lot going on, but the good thing here was that we can actually kind of see what's happening. Now that we actually had a good idea of what was happening, it was time to kind of look at why nothing was getting finished. And the reason why was because of this. So this is Little's law. It's a mathematical theorem. It's from queuing theory, but it's used a lot when you're talking about workflow optimization. Basically, the concept is that all 3 of these things, they all relate to each other, and if you change one of them, the others will change. So how many things are currently in progress, how fast the things are getting done, and how long it is going to take to get the things done. So obviously this was our big problem. It was taking a really long time to get things done. This was not our problem because the engineers were all really good, all really high performing, all knew their stuff really well, they all really cared, and they were doing heaps. So this was our problem, how many things were in progress. So 5 engineers, 20 things at the same time, that's doable, right? No, it is not. So I managed to convince them after promising and cajoling and being like, come on, please, just try it. I promise if anyone blames everyone, it's going to be me. I managed to convince them to shut all of the projects down. We spent 2 weeks either closing them off or finishing them up if we could, or just deleting them if they really weren't very relevant. And it meant that we could just all focus on one thing. We could fix that problem that we had here. But the next problem was, if we're only choosing one thing of the 20 stuff that was in progress to keep working on, how do you prioritize that? So for that first project that we did, we thought about what makes something valuable to us. and we chose the thing that was valuable to us. So I like to think of that as kind of technical values. That's the things that make our team happy. That's the stuff that's going to optimize your process. That's the innovative tech that you want to try. Those are the things that are really going to benefit your team, but maybe it's not going to benefit the rest of the organization. And that's kind of an issue because we don't get hired as security teams just to make our own lives better. We get hired for a bigger purpose, right? So another way of determining value is the organizational or business value, whatever you want to call it. So this is kind of how to make your leaders happy, right? You're creating projects that your leaders like, yes, see, we're helping to their leaders. Sometimes, though, it's really hard to figure out where the organizational value of a security product or a tool or a service or a project is because, we don't really make any money, right? We're there to make sure that we don't lose money, and if we're doing our job right, no one thinks we are going to lose money due to security. But it's really hard to translate that into a cost that we're giving. So you can look at things like values, you can look at things like strategy, you can look at the vision, but even then, it's very rare to see a company say, security is our strategy. We want everyone to adopt vulnerability management within their product teams, for example. That's pretty rare within organizations to focus on that. Instead, they usually focus on something like this. Ship features faster. It's so hard to see where you fit as a security team in that strategy, right? It doesn't feel like a secure priority either. Like shipping features faster means that they're probably going to be less secure because no one's going to take the time to check that they are secure. But actually we do help. So what we can do is we can make sure that we're enabling these features to be developed quickly and securely. One of the problems that we always hear from people that are working with us is that we're blockers, that we always get in people's way. So when you see a priority like this or similar, your job is to make sure that the security that you need them to put in is not going to make them take ages. The other one, and this is my bread and butter nowadays because I'm a product manager, is the customer value, aka how to make your users happy. I just want to clarify here, I'm going to talk about customers quite a few times in the next few slides. So for me, in a security team, we're kind of like a platform team. We serve the greater organization. We don't interact directly with our organization's customers, which is probably a good thing. This is someone who directly interacts with our tools and services. So these are the product teams that put an endpoint behind a WAF, for example. Or if you're in GRC, probably the team that has to go through your risk treatment plan. So if I'm talking about a customer, it will be someone within the organization that we are working with to help uplift security. It was around here when I started looking for customer value that I realized that I never had and I never will escape from customer service. Everything that was happening was very familiar, right? Like all of the problems that I'd had with projects not being appreciated and my team not being appreciated and being underappreciated by the people that use the stuff that we deliver, it's all customer service related. But because I have a decade of experience in customer service, at least I knew how to talk to customers. So I have put together a How to Talk to Customers 101 slide for you all. Turns out you don't even have to talk with them a lot of the time. There is a whole lot of techniques you can use to listen to them without actually having to talk to them one-on-one or at all. So if you start looking into product principles, a lot of the time what you will hear and see is send out surveys. And what you're going to remember in regards to sending out surveys is that these kind of blogs or journal entries or whatever that people put up about product, they're really targeted towards people that have organizational customers, right? Customers that are using the organization's product. They might have 30, 40,000, a million customers, so they can send out a survey to 5% of the customer base and only 5% actually respond, and they've still got like a good 600 or 700 people's feedback. When you're in an internal team, sometimes, you'll only have 15 people using the tool that you've built. So if you send out a survey to 10% of those people, that's 1.5 people. And then if only 5% of those people actually reply, well, that's no one. So just be careful with surveys, not only just because sometimes you won't get enough you won't get enough people responding to get actually any value out of it, but also, engineers go to work to do engineering. They don't go to work just to answer surveys. So you just got to be really careful with that. I would really just limit them to when you have like a really big cross organization project going on, so something like a vulnerability management program or DevSecops, or like those really big meaty things. That would be a good time to use surveys. The other thing you can do is you can look through your support tickets. So I'm sure we're not the only security team in the world that had a whole lot of support tickets coming in all the time. And something my amazing team had already been doing well before I came along was labeling the tickets so that we knew which product the question was about. And what that meant was that we could actually do sort of an inventory, how many times people asked about each product. And we could find outliers and have a look deeper into them. So we've got, a much higher amount of queries for AWS IAM than anything else. So most likely there is something broken there that we can probably remediate. And a lot of the time it will be around documentation. So you can look for key sentences like, tried to follow the documentation, but, which will most likely mean that your documentation needs to be updated. Could also see, I couldn't find any guides. Maybe you need to add some guides, or if you already have them, are they tagged correctly if you're in Confluence? Or is it just that the people that are using that tool don't have access to Confluence, you need to put it somewhere else? And the other one is help channels. So if you've got Slack help channels or whatever you do for people to be able to contact you directly, you can scroll through them and just see what are people asking about, what are people complaining about, what do people like? Because sometimes people actually do put shout outs in help channels. It's not an urban myth, it does happen, I promise. Unfortunately, at some point you probably do need to go talk to them. So there's a couple of ways you could do this. I don't know if this one's really relevant as much as it used to be, but informal chats. So when I became a team lead and started going off on this journey with my team, I tried to go out and find as many people as I can that were product owners or engineers and kind of like try to build some sort of relationship so I could at least say hi and how are you, and then maybe just get them to just, if there's some big security thing going on, then they know I'm in security, so they're most likely going to bring it up with me. So I could get information that way. The other one is customer interviews. So customer interview is when you book out some of their time and you go through a specific series of questions. So this is really good for gathering feedback from a range of different people. Things to note, make sure you come prepared, have a set list of questions. Also make sure it's only like 25 minutes long, you don't want to waste anyone's time. And also just try and make sure that you're talking to a range of different people. It doesn't help if you're building a tool that you're only going to go talk to product owners when they're not the ones that are actually going to use the tool all the time. Maybe they're only using a dashboard. So go talk to a PO, go talk to engineers, go talk to the principal engineers, maybe even talk to like team leads. Talk to as many different people as you can so you can get a range of feedback. So once you've got all this, you know what your customers want, you know what the business wants, you've kind of like started prioritizing. The next thing you need to do is you have to go start looking at the bigger picture. So something that happens in a lot of security teams, even lots of platform teams, as far as I've seen and everyone I've talked to has told me this, that there's so much reactive work, so many things happen that prevent you from doing other things. You know, people are falling off cliffs all the time. We've got to get our ambulance out and we've got to go save them. But obviously, we don't want to be ambulances all the time. We really need to build a fence. The fence is the most logical thing to do. We need to go build a fence so we don't have to pull out our ambulance all the time. there'll be some kind of timeline that goes like this. We all make the assessment that the ambulance is very inefficient. So we're like, yes, let's build a fence. But then, we get started building this fence, and all of a sudden Log4j happens, and we need the ambulance, so we have to get that back out again. And then there's a risk above tolerance, so now we have to get the ambulance out again. And then we get a little bit of breather, and we're like, oh my goodness, this ambulance is so inefficient, we should really build a fence. And we're like, okay, let's build a fence. And we start building that fence, and then all of a sudden something else happens, and the ambulance comes back. The other thing is, a fence isn't built in a day. You can't just build a fence. You have to do a number of smaller steps towards building a fence. You have to chop down trees, you have to make fence posts, and you buy some tools, you need to dig some holes. And, when we say build a fence, even if we get a little bit of the way through that, probably after we've bought some tools, a whole lot of stuff is going to happen. We need to bring that ambulance back out and start using it again and again. And then 12 months later, we'll come across these tools that we bought, and we're like, oh yeah, that's right, we're building a fence. And these are some types of security fences, right? We all know what these are, most of us. Zero trust, we've heard that word a lot the last couple of days. Uber is another one that I hear a lot. And of course, DevSecops. These are all good initiatives, but you can't get them done in 3 months. They're not just one part of something. You actually have to look to the future and plan your way along. And you have to account for the fact that sometimes you're going to have to bring the ambulance out. So anyway, make a roadmap. It's the most simple thing you can do. And a roadmap is not a document that you just write things down, set and forget. That is not going to help you or help anyone, and you might as well just not do it. A roadmap is a living document. What that means is that you can have these steps out, but then if after you make the fence posts, you have something happen that you have to bring the ambulance back in, or another priority happens, something other than building a fence for a second, you can add that in and squish everything down and make sure that once you're finished with that ambulance or finished with that other priority, you go back heading towards that vision that you have of DevSecops or Zero Trust. So we did all that. We had a roadmap, and we talked to our customers, and we made sure that everything we did aligned with the business value, and we were making sure that we were, doing things that we consider valuable and minimizing toil and using cool stuff. So, we didn't really know it at the time, but we were kind of becoming a product team. So what happened next? What did they actually do? What did we actually see? Wow. We started getting stuff done. We didn't just say, we're going to get this done in 3 months, but then it didn't get done for a year and a half because we're working on 20 other things at the same time. We actually started regularly finishing work and showing value, and people noticed that. We even have got to the point where users willingly adopt our tools. Even very recently, we released an alternative way to access the platform. It's a way that's more secure and works more with our long-term vision. In the past, it would have had everyone complaining, oh my God, why do we have to do this? Security always makes things so difficult. But with this tool, we had been talking to our customers and adapting and making sure that it's doing the things that they want, and we're making it as easy as possible for them to adopt it. And all we had to do was tell them that it exists. They go in and try it, and they have such a good experience that they just keep using it. There'll be the outliers, the people that don't like change. That's fine. We can mandate them. But the majority of the company will be, they just did it themselves, and it was nice. It's a nice experience. And obviously, when people willingly use your tools and actually actively use them every day, you get a better security posture, right? Because otherwise, why are we building these things? Why are we writing risk reports? Why are we building automation for access? Why are we doing any of it? And so that people start using it and we become more secure as an organization. But the biggest benefit to me, probably because of all my decade of customer service, was that we don't feel like the enemy anymore. Obviously, we still do things that they don't like. Every now and again, a decision will come along that, they're not quite on board with, but they'll still work with us. and they'll still like kind of get it done while they grumble. It doesn't feel like we're public enemy number one. It feels like we're part of a greater team. So you might be thinking, Candace, this is kind of wasting my time. This is all really obvious stuff. I'm pretty sure we already do all of that. Well, I don't think you do. So I've got a scenario for you, and just have a think and see if this applies to your team and your organization. So let's say there's a UX governance group, and they do audits. And at some point, the UX team has come around and told everyone that they need to install this agent or run the script on any sort of online reports, and it's going to spit out a list of flaws, and you need to remediate them. It spits out something like this. Like, I don't know about all you, but I don't know anything. I know sweet FA about UX. Like, I can pick out words here that I recognize, but I would have absolutely no clue how to go about fixing any of these things. I'm like, what is this? Why do I need to have a nice UX? Like, and then how do I do it? And where am I supposed to start? There's little things on here. The most likely scenario that's going to happen right now is I'm going to try to remediate, and I won't be able to figure it out because this is just way outside where I am as a security person. Another priority comes in, an actual security priority, the reason that I'm here to keep people secure, not make pretty things. And I'm going to ignore this. But it's our UX governance group. They have authority, and our leaders are being measured on their team's compliance to these UX remediation reports. So my manager comes in, they're like, you need to get this done. I'm getting measured by this. So I do my best, and I go back, and I try to remediate something, and maybe I remediate one thing, but in general, I don't really know what I'm doing. And then another priority comes in, like an actual security priority that I actually care about, and so I ignore this. And then it goes back to my manager, and then my manager is coming back to me in this endless circle until it goes on, and at some point it just becomes white noise, and like just a ritual you do with your manager. Go remediate these things. Okay. No. So I really hope that this is familiar to all of you, because this is vulnerability management. We literally do this to product teams all the time. We give them this massive list of things that they have to remediate, and they're a product team, right? They just want to make their cool features. Like, they want to go make the company money. That is their priority. That's what they care about. And we give this big, big list of things that they have to fix. Why should they do it? We've never had a security breach. So this should be very familiar. And this is what we should be doing. So the UX team, when they see that I haven't remediated all of these things, they should not be going to my manager and telling my manager to tell me to be compliant, so it's clearly not working. Let's say they come talk to me, and I'm like, I don't know what this is. So at minimum, they add a title at the top of the report. Like, they should have done that in the first place. So at least now I know what it is. It's a user experience audit report, and it's for security tool 4. And I'm like, okay, that's cool. Why do I need to do it? I don't care about UX. So, add another line in there. It's to make sure that we're compliant with these audits and also the UX policy that everyone at your organization has to comply with. I would really hope that they'd also back this up by going to like global all-hand meetings or whatever you have, and educating people on the fact that there is this UX governance group, and we do UX audits, and if we aren't complying with it, then we lose hundreds and hundreds of customers and millions of dollars, or whatever the reasons are. And then I'm going to be like, I actually have no idea what most of these words are, so I'm not going to be able to fix this. How do I do it? Well, at least this helps, right? It's kind of more clear directions on what I can do to remediate these problems. I mean, there's still a lot of them, and I still don't quite know what I'm doing, but at least I'm getting somewhere. But then the last one is, there's so much work here, and there's only so much time that I can devote to not doing security things. So where do I start? Like, it's literally as simple as adding a priority list. Start at number 10. Even better, maybe the UX team realizes that most of the people in the company just don't have the time to be fixing these things all the time, and they just automate the whole thing away. So you don't even have to think about it. So I've said a lot of words in the last half an hour about a lot of random things. But if there's nothing else that you remember from this talk today, the one thing that I want you to take away from this is that you as a security person, whether you're an engineering team or you're a consultant or you're in a GRC team, go talk to your customers and find out what they need. Whether it's about a tool or a report or some sort of dashboard, you need to go talk to them and make sure that they understand it, that they know what is required of them. Don't make assumptions that they understand what's on there. Just go talk to them. We really just, as an engineering function or whatever we are, security just needs to stop telling people to build secure products. Telling does not help anyone. If you want to be scalable, if you want to be effective, you need to start enabling people to build secure products. And that's the end.
Thank you very much, Candice. Right, lunchtime. We're running about 10:15 behind schedule, so we'll push the lunch break out to make it an hour long. So we'll be coming back at, what does it say, what did we say on the schedule? 50 minutes behind that. We said 1:45, so probably 2 at this point. But anyway, go forth, get some fresh air, go outside, see your friends, eat a snack, and we'll see you back soon.
Hello. Hi. Hello. Hopefully everyone had a pretty good lunch. The next round of talks that we're going to be getting into are what we call our lightning talks. So it's going to go really, really fast, 15 minutes back to back. Some sparkly warnings will come up when people are going over time or too close to time. And the thing I really like about these next 7 talks is that we'll see a few familiar faces from previous KiwiCon fame, but we'll also see some new faces, some faces that we might, definitely have not seen in previous Kawaicons or KiwiCons, but some new speakers to speaking in general, which includes our first speaker, who I think has a little, what I called a fan club, but maybe is more of a heckling squad somewhere down here, and perhaps also on the live stream. But introducing our first lightning round speaker, Kento.
Okay, kia ora everyone. Hope you had a good lunch, managed to get a good feed in. I'm stoked to be starting this round of lightning talks actually. I do have a bit to cover though, so I'll get straight into it with a quick intro. So hey, I'm Kento, bit of a cybersecurity generalist at this point. Currently I work for Westpac Bank up in Auckland. So here is a photo from Auckland a couple of weeks ago on a good day. And hey, to my absolute amazement, we've had a couple of good days in Wellington as well, so bit of a bonus there. Now, thank you for that one. Now, like pretty much everyone can relate to at this point, I also spent a lot of last year in lockdowns, right? And for me personally, I didn't have too much going on. I got pretty bored, and I ended up spending way more time than I really should have on Twitter. Now, on most occasions, I didn't find too much interesting on there. But on this one particular day, August of last year, I came across this tweet by a user named JohnHat. So you may have seen this one actually, it kind of went semi-viral, but it basically talks about a local privilege escalation you could get by having access to a Razer device. Now, for those who don't know, Razer is a company that make PC peripherals for video gamers. So these are things like gaming mice, keyboards, and headsets. And what was happening here is you would plug in a Razer device to your PC. That would automatically start to install this Razer gaming software. And that was actually installing with system. So from there, you could change the install location of the software, get a file explorer session, and then you go shift right-click, open PowerShell window here, and you get a system shell. This is kind of what that looks like just from a very basic sort of diagram view. You've got me, like low-level Kento user, pretty sad, can't do too much, plugs in a Razer mouse to Windows. Windows then automatically loads this Razer gaming software with system privileges, and then you just convert that pretty easily into a system shell. Once you have that, you're pretty much free to do whatever you want, right? Now I had a Razer mouse lying around at home, and I thought this is pretty interesting. So I recreated it, plugged it in, it worked totally well, like super easily. And if anything, that actually made me more interested. Like I wanted to really understand what was going on here. So there are these 2 areas that kind of like really piqued my interest. The first is this section in the red. This is the how aspect to all of this. Like how does Windows actually identify what USB device was plugged in, and how does it then know what drivers or applications need to be installed? And the second section is the section in blue. This is the kind of why aspect, just by saying, well, why does all of this get to run with system privileges, with such a high level of privilege on the local machine? So wanting to understand this how and the why is what really kicked off my journey down this rabbit hole, where I came to realize just how much of a mess this entire ecosystem of USB devices in Windows really is, and how easily you can actually exploit that with just an Android phone. Okay, so let's talk USB devices. Now, I don't have enough time to get into the full details of this one, but the most important thing to understand is this concept of vendor IDs and product IDs. Now, these are just 2 values that are embedded onto the USB device during creation that are used to identify that device to Windows. So when a device gets plugged in, a service called Windows Plug and Play actually reads those 2 values off and then fetches the relevant setup information file, and that setup information file is what specifies the drivers or the applications that need to be installed in order for that device to work. So the vendor ID, this is actually static and specific to a vendor that creates USB devices. Now you can actually get one of these for yourself. It costs about $6,000 US. You make an application to the USB implementers forum, and then they will assign you a vendor ID. Once you have that vendor ID, the product ID, you just set that to be whatever you want. Maybe increment that up by 1 for each new device that you make, because it's the combination of these 2 that will be used to identify your unique devices. So just to really further illustrate that, here is the Razer mouse that I had lying around. This is a Razer Naga Hex version 2. I had this one when I thought I was going to make it as a pro gamer, but it still worked. And this has a combination of 1532 for the vendor ID. So that is that vendor ID for all Razer products. And then the product ID for this one specifically is 0084. And the combination of these two values then identifies this mouse specifically. Okay, so once I kind of understood that, I just started thinking, well, is there some way that I can control these two values for myself to then maybe control the behavior or the actions that Windows takes as a result of that? And the answer to that is yeah, this is actually pretty easy to do. All you really need is an Android phone. Specifically though, you do need root access to your Android phone. Android phones are essentially just Linux machines, so once you have root access to that, you're free to make whatever changes to the settings that you'd like, right? So I had an Android phone obviously, and I got root access on that. And I went into a thing called the config.fs, and there were two properties that kind of caught my eye. These are the ID product and ID vendor properties. Now, as you might expect, these properties just hold the two values that are the VID and the PID, which get reflected back to Windows. So I've got these very, very basic echo commands. You might be able to see these on the screen. They're essentially just overriding whatever value was already there for the ID vendor and ID product with the values 1532 and 0084, which you might recall is the combination for my Razer mouse. Once I'd done that, I could plug my Android phone into my PC, and that would automatically start to install this Razer gaming software, and I could recreate that privilege escalation without actually using a physical Razer mouse, right? Just by using this Android phone. So that was pretty nifty. Like, I had a way that I could get my Android phone to act as a Razer mouse in the eyes of Windows and get this priv-esc. And then I started thinking, okay, well, now that I do have control over these values, what other combinations are out there that might do, similar sort of things, or maybe just other stuff entirely? So I've got a few examples for you here. SteelSeries. Now, SteelSeries is a competitor to Razer. They also make PC peripherals, and they had a similar sort of thing going on. You could plug in a SteelSeries mouse, or in my case, an Android phone, and that would load the SteelSeries gaming software. From there was a link to view their privacy policy, and that would actually load a web browser. And because that web browser has system privileges now, you can save that web page, get the file explorer session, and convert that into a system shell. Here's a slightly more obscure example. This is like a third-party external graphics driver that loaded with that install shield GUI. If you get to the terms and licenses section, there's an option to print the terms and licenses. You click on that, that gets you the word processor. Because the word processor is running a system now, you save the Word document, get your file explorer session, and you can have a system shell that way too. Now, of course, this also is not going to be just limited to privilege escalations, although they are pretty cool, to be fair. There's all sorts of weird and wacky stuff going on in this area. Here's an example of that. This is like a strange on-screen keyboard application that was installed on my PC. It was really buggy, would crash out all the time. Windows didn't seem to know what was going on with it. And neither did I, to be fair, so uninstalled this one pretty quickly. And then this is pretty obvious in hindsight, but do this enough times, install enough weird drivers, weird applications, and you just give yourself the blue screen of death. So again, there's no real practical application to this one. Maybe you can prank your mates or something like that. But it was a bit of a lesson learned for me and a bit of a headache. Okay, so that kind of covers this section in the red, this sort of how aspect. I want to talk a little bit more about this section in the blue, to sort of answer this question of, well, why does all of this get to run with system privileges? And the answer to that is actually pretty straightforward. It's just because Microsoft wants them to. I talked previously about this thing called Windows Plug and Play very briefly. You may have heard of this already. If not, it's a very, very rare occasion of Microsoft getting the naming convention 100% spot on. Because this is what allows users to purchase a USB device off the shelf, plug that into their machine, and just start playing around with it, right? And that makes perfect sense, because the vast, vast majority of users don't want to have to be manually installing their own drivers or applications in order to get their device to work. They just want to be able to buy a keyboard, a mouse, or a headset, plug that in, and start using it the way they expect it to work. So in order for this seamless user experience, this integration to happen, Microsoft has a program called the Windows Hardware Compatibility Program. Now, this is where vendors who make these devices essentially present them to Microsoft and say, hey, I've got this really awesome product. Customers are going to love it. We want this to work with Windows. In order for it to work, though, it needs these drivers and these applications to be installed. And then Microsoft has a look at that, and they go, yeah, this seems pretty legit. We want this to work with Windows as well. Passes the vibe check. So here is a signed Microsoft certificate for your drivers and your applications. These can then go ahead and install a system, of course. They don't run into any permissions issues. You're good to go. So it's really Microsoft's way of trusting these drivers and these applications to install and perform whatever setup actions are required on behalf of the user. Now, if that sounds like a bit of a recipe for disaster, or at the very least, there's room for things to go a little bit wrong here, you'd be totally correct, right? Here are 2 news articles from last year, one in June and one in October, where these drivers that had gone through the hardware compatibility program, had signed Microsoft certificates, were actually just malicious rootkits. And because they had gone through this and they'd been integrated so nicely with Windows, they could install themselves pretty easily on Windows machines, bypass most defenses, and then just start performing all sorts of malicious actions from there. Now, as a result of this, Microsoft gave a pretty sort of generic statement, oh, hey, we're going to review our process on this one, make sure it doesn't happen again. I have no real insight into what those changes might have looked like, so I can't really confirm. But there were a few other things that came out of this as a result. In December of last year, Microsoft actually opened up a specific driver reporting center. This is a place where researchers who find these sort of drivers can actually submit them directly to Microsoft, and a dedicated team that's been spun up there will take those down, analyze them, and then make whatever changes need to be made after that. Now, I can confirm this one does work because I've been in contact with the team at Microsoft through this and submitted some of the stuff we looked at previously. The only thing I would say, though, is it's taken a really long turnaround time on this stuff, but hey, the team's there, and we're back and forth, and they're doing their best, so that's pretty cool. And then finally, a little bit more recently, in sort of March of this year, Microsoft actually released a specific function within Windows 10 and Windows 11 where you can actually go ahead and block drivers from being installed. So this might be in response to some threat intelligence or, like some of the news articles like we looked at previously. You could actually say, oh yeah, these drivers actually, yeah, nah, not all good. They can't be installed under any circumstance. I'm not really sure how practical this would be in an enterprise setting, but the feature's there and it does actually work really, really well, so that's cool. Okay, I just wanted to sort of summarize what I've been talking about here by reiterating a few key points. By allowing users to plug in USB devices to their Windows systems, that is allowing every single USB device to be plugged in. Now, in terms of vendor IDs alone, there's currently over 12,000 different unique vendor IDs that are valid. That means there's 12,000 different vendors that could be making a huge, huge range of their own unique USB devices. So really, there's tens of thousands of different devices out there, but that means there's potentially tens of thousands of different drivers and applications that could be installed on machines as a result of a device being plugged in. So when you take a step back and think about the scope and the scale of this problem, it really starts to become quite massive. And Microsoft trusts all of these through their compatibility program, but that doesn't necessarily mean we should be trusting them, right? Because in a sense, I think this entire ecosystem of USB devices in Windows is actually a huge contradiction. Because on the one hand, there are what should be considered untrusted, external, third-party USB devices that are simultaneously being trusted by Microsoft and the internal Windows operating system. So that's a bit of a disconnect. And I think it's important to be sort of aware of this reality and just to be aware of how much room there really is for things to go quite badly wrong here. And Android phones in particular, well, hey, these don't necessarily have to just be an Android phone plugged in for some extra battery charge. They themselves could be masquerading as a huge range of devices themselves. So, all I can say on this one is, well, depending on your role, approach with caution or use to your own advantage, I guess. Cool, that's everything I had to talk about today. Here's my contact details. Please get in touch. Thanks.
Thanks very much. I think we can all agree that USB was a mistake and we should have stuck with Apple Desktop Bus. That would have been a far superior choice. All right, we're going to keep it on moving. It's my great pleasure to introduce our next lightning speaker, Denise.
Hopefully that doesn't spill on Kento's computer. I'm not a cat. I swear, I'm not a cat. So, as the title of my talk is, it's about lockdowns, writing, and kid wrangling how I got into security. Now, if any of you guys remember the first lockdown, there was that recording, it was a court session over Zoom, and the lawyer couldn't take the cat filter off, and he kept on saying, I'm not a cat, I'm not a cat. So I'm going to talk about how I got into security, because mine is a little bit of a unique story. I was going to do a heap of memes, and I tried practicing, but it just didn't flow very naturally. I think the sort of story that I have, it's not something that you can really rehearse. I kind of have to speak from the heart, because I've been through a lot. So kia ora everyone, I'm Denise. I work as a cybersecurity analyst for Datacom. I'm a mum to a human child and a fur child. I'm a proud Jaffa. I'm also very open about my neurodivergence as well. I'm both autistic and ADHD, and I do a lot of advocacy work around that. So some of you may know me on Facebook as Neurodiverse AF, because every now and then I might post something about it, but I'm too busy with work. And I'm also a massive nerd as well. Like, if you know me personally, if you know me really well, you know that I can talk for hours about anything to do with science. You know, that sort of stuff excites me. But overall, my journey into security has been, I think it actually started when I was a child. I taught myself a couple of programming languages. Actually started off because the teacher could see in class that I was really bored. And at the age of 9, he challenged me to learn BASIC, and he gave me a book, and I took it away. That was to be my term project, and I taught myself BASIC and wrote my first programming language at the age of 9. From that point onwards, I kind of taught myself other things. This is like the very early 90s, so we didn't have the internet back then. All we really had were books in the library, and I read a lot, and that's how I learnt. Obviously, growing up during the 90s is that, I saw how much technology changed over the years. I didn't really know security was a thing back then, but the sort of person I am, I have a very, very curious mind. I, decided to look into things a bit more. The internet was booming, more and more people were having internet connections, and it was like a good way of trying to meet other people who were like myself as well. But also at the same time, because of who I am as a person and being autistic, society at that time made me feel like that I had to try and act as normal as possible, and I did. I masked extremely well. Most people didn't really pick up that, I am autistic. They thought maybe, I'm a little bit weird, maybe a little bit quirky, but I tried really, really hard to present myself as like a normal person. Going through that, I went to university. At the time, I didn't know I had ADHD, but that really intense need to kind of hyper-focus on things. If anyone in here is ADHD, you'll know what I'm talking about. I tend to get quite obsessive over things that really pique my interest, and I need to know everything right there and then at once about that particular topic. And so because of that, I learnt more and more about how to do certain things, but it was kind of, I think of the age of LAN parties. If anybody remembers during the early 2000s at universities, it was quite a big thing that, lots of people would go to LAN parties. We would all take along our laptops. Some people would take, the big, huge desktop towers, and we would share files between us and kind of learn things as well. And I really liked being in that space because I could just be me. I didn't have to put on a mask. I didn't have to act what society deemed to be normal. And I had a lot of fun as well. Along the way, in my second year, at the end of my second year of university, I got my first full-time job working as a public servant, and I got seconded into an investigations role. Now, the things that I learned in that role, I now realise is what we call OSINT, and I learned a lot. I learned how people try to hide themselves. I know every single trick in the book. But my job was to try and find people that were trying to run away from their legal responsibilities. From there, I got married, had a kid, kind of didn't really do much more in that sort of space. And, things happened in my life, got divorced, went through a lot of my life, and during the time when I was a stay-at-home mum, society tries to make you feel like you're a failure as a stay-at-home mum. They don't really see the value that you provide to society by trying to raise your child. I was going through I've been through a lot of traumatic experiences. Going through a divorce was quite taxing on me. And I had to quit the job that I had been working at that time. At the time, I went from working from one government organisation to another, worked as a research librarian for a number of years, so I was able to use a lot of those OSINT skills that I picked up earlier in that role as well, and even learned even more on how to find the most obscure bits of information on the internet I can find it. But there was a period of time, especially during my son's formative years, where I just felt like a complete and utter failure, and I didn't know what I was going to do career-wise. And I went through a lot. I went through a really bad bout of depression. I went through 2 mental breakdowns. Again, I'm very open about mental health. I think it's really important that we are open about it because it forms part of my story and part of my journey into security. During that lowest point of my life, I actually met someone who's probably, the bestest friend that I have, the person I probably trust the most. And that person, works in security. And just hearing them talk about what they were doing, I was like, oh, you can actually get a job doing this professionally? I didn't know that. And I was thinking about all of the things that I've learnt over the years, but I never felt good enough because I don't have a formal qualification in IT. Well, I do now, but back then I didn't. Had a university degree in science, but it was nothing to do with IT, unless you count like the 2 Java papers that I did many, many years ago. But I just never felt like I was good enough because I looked at all of these people in the space and I looked at what they were doing and I looked at myself and I'm like, I'm not good enough to do this. I'm not smart enough. During that time though, I'm also a very resilient person and I had to learn to pick myself up. I tried so many different things and I failed so many times. And every time I failed, I would even feel worse about myself. Like, I'm an absolute failure. What am I doing? I'm never going to succeed in life. Because again, people at the time and even now still don't really value your role as a mother and kind of all the hard work that goes into being a parent, especially as a single parent as well. But I pushed harder and harder and harder. During the first lockdown in March 2020, obviously the whole world came to a standstill. Now, up until that point, I had been doing bits of work as a writer and as an editor. So again, if you Google my name, you'll see some of the articles that I've written. But did a lot of editing work, did a lot of social media consulting work as well. When that first lockdown happened, that pretty much cut off that work because a lot of businesses were cutting back on their budgets. I probably felt even worse. Felt even more as a failure. I was spending a lockdown trying to decide what to do. And I was thinking about it a bit more. And I was like, but I'm the sort of person, my friends, they come to me. If I've got any issues with their computer, they bring it to me, I'll fix it for them. I know how to do it. I love tinkering around with things. I like to know how things work. After that first lockdown, again, my best friend, they sent me a link to the Women in Tech talk in 2020 and said, oh, you should submit a talk. I didn't think I was going to get anywhere with it. I thought, okay, I want to talk about something that I know a lot about and I do a lot of work around, and that's around neurodivergent people. I wanted to talk about neurodiversity in the tech industry and the appalling statistics when it comes to neurodivergent people in tech. And I think it's safe to say that a majority of us who work in security are neurodivergent. You may not realise it yourself, but honestly, if I talk to you, I can probably tell within 10 seconds if you're like me or part of the neurodivergent community. So I submitted my talk. I didn't think anything of it. I didn't even think they were going to get back to me. But, there's no harm in trying. And then I got an email back. And look, and it's like, oh, congratulations, we want to offer you a space to talk. And I was like, oh, great. And then I read further down, oh, you're going to be our keynote speaker. And holy crap, I was like, oh dear, I was like, oh no, this is bad. Like, do people actually really want to hear me talk for about, 45 minutes to an hour about neurodiversity within the tech industry? But I thought to myself, this is going to be an opportunity to try and meet other women who work within the tech industry, but in particular people who work in security, because I knew at the time ZX were sponsoring the event. And I presented at Women in Tech, and during that conference, I got the amazing opportunity to meet a wide variety of women who work in security. And they may not realise it, but Erica and Kate, they came and spoke to me quite a bit after I went up to talk, and I got to connect with them. That was really cool, and believe it or not, you two really helped to push me into security and to actually think of it as a serious career choice. But again, I didn't think I was good enough, and I needed a way of getting into the industry and try and show people the technical skills that I do have, skills that I've learnt over the years. Towards the end of the year, someone told me about a funding scheme where the government were going to fully fund a whole range of diplomas and certificates as part of COVID, recovery, trying to improve a lot of industries where there is a serious lack of skills. I had looked at doing this particular diploma in cybersecurity, but I was like, I'd have to get a student loan. Study Link aren't going to give me any more money, and I saw this as an opportunity to get into the industry, to try and get my foot into the door. I sent off my application, and I really have to thank Deela for taking a chance on me. She was such a lovely person, and she could see my potential. As part of the diploma, I had to do an internship as part of it, and I think I was one of the first people that they interviewed that year, and I was offered an internship pretty much the same day after my interview. But Tim, who interviewed me, who was managing the SOC team at Datacom at the time, he saw my potential. I was really nervous. I thought he was going to look at me and think I wasn't good enough, but he saw my potential and he gave me that opportunity. From that internship, I worked so incredibly hard. People who are close to me know how hard I worked. I'm a very resilient person. I'm quite stubborn as well, and when I put my mind to something, I will do everything in my power to be able to meet that particular goal, and that's what I did last year. I took the opportunity to apply for a full-time position within the SOC team at Datacom. Again, thinking, I'm not good enough, they're not going to offer me a job. I was interviewed, and I was really, I don't know if my managers realised, but I was actually really, really nervous during that interview. I thought I was going to stuff up. I thought I didn't know anything, but I can confidently say I did really, really well in that interview. I was able to demonstrate my technical skills. One of the managers wanted to know, okay, well, how would you hack into Datacom? I'm like, do you really want to know how I would do it? And I started talking about it, and he had to stop me halfway through because he could tell I knew what I was talking about. But because people were willing to give me a chance, and I worked so incredibly hard, I've networked so incredibly hard as well. This is the reason why I managed to get into the industry. I got my first professional job in security without a formal IT qualification and without any professional certifications as well. Because there's this big, huge emphasis that people think you need all of the degrees and all of the certifications to be able to get a job, but what you need is you need one or two people to actually believe in you enough to help and support you and to give you the opportunities that you need. But all of this is that I want to use my experience to inspire other women in colour. With me being an Indigenous person, I am Māori. I am extremely passionate about trying to get more women of colour into this industry because we have a serious issue of a lack of diversity. It is improving, but there is still this image out there that it's a bro culture, and that really needs to change. And I'm willing to put in that hard work to try and get more people into this industry, people who've got the skills that we need. It's not all about just computers, people who've got fantastic communication skills. It all helps within this industry in all the different areas. People just don't come in and be an analyst like me. You could go off and be a red teamer, you could do GRC stuff, you could do DevOps. But I want my story to inspire others. That yes, I have put in a lot of hard work, but I also need to acknowledge the help of others and the fact that I feel like I'm finally at home. I'm surrounded by people that understand who I am as a person. Thank you.
Awesome. Thank you so much, Denise. Our next speaker, we've had a few talks recently around disclosing vulnerabilities more from the researcher side. So our next speaker is going to be sharing points of view from the person who actually looks after and manages an open source project. So introducing our next speaker, Christina.
Oh, since I can't. Thanks. Tēnā koutou. Ko tēnei takumihi ki ngā tangata whenua o te rohe nei. E mahi ana o I te hapori mahara mō te kau mā toru tau. Ko au te kaiho tū kopapa mō mahara, te punaha, kopaki, pumanawa hea rekore. E mahi ana o I Catalyst IT, ko Christina Höppner aho. Nō reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. Over the years of KiwiCon and Kawaiicon, we've heard lots of stories where organizations did not respect independent security researchers who privately disclose vulnerabilities. That often meant organizations didn't respond, were dismissive when they did reply, or didn't fix serious issues, which then resulted in the dreaded 0 day, of which one almost was dropped yesterday by my colleague Andrew. On the flip side, there are many organizations that are grateful to information security researchers like you, who share their findings and contribute to a more secure experience using software applications. These organizations often follow good practice. For example, they engage with the researchers, give them public credit, create CVE numbers, and also communicate about resolution timeframes. Sometimes, rookie mistakes are made, though, that can lead to frustrations on both sides when expectations aren't met. The scenarios that you will see here today are all that I've experienced over the last 12 years. To preserve anonymity, all identifiable personal and also organizational information has been removed. And they may also have been shortened slightly for brevity. So I recruited a good friend of all of us here to help me out today. Hey, Faily Monster, where are you? Oh.
Do I hear my name? Hello.
Hi, Faily. How are you doing?
Very well, thank you. Hello, hackers.
It's so good to see you again.
It's great to be here.
Okay, shall we get started?
Let's do it.
Okay, let's look at scenario number 1. Dear Faily.monster.net. I found a vulnerability at www.company.biz. Here are the steps to reproduce the problem, the references, and mitigations.
So, what's really good is there's a clear description of the issue, details to replicate it, and proposed mitigations. What's not so good, it's a mass scan of websites sent with a mail merge, and it discloses to the wrong team.
So our tip really is, please do not disclose other people's vulnerabilities. Number 2.
Dear Faily Monster, all your open source community town hall meeting minutes are publicly visible. These may contain sensitive information.
So in general, of course, that is really pretty good advice, because we do want to keep information private. However, unfortunately, in this case, the researcher failed to see that these were public meetings, and therefore minutes are publicly available, because that's part of the community service. So our tip, don't just rely on automated tools to find stuff, but kind of check the context there may be a very good explanation why an organization makes certain information public that is otherwise privileged. Dear Faily Monster, 2:30 a.m.
Hello, I found a vulnerability.
3:56 a.m.
Hi, can I please get a response?
6:19 a.m.
Hi, I haven't heard from you.
8:27 a.m.
Can I please have a reply?
So in this case, the researcher really did find a vulnerability, which was good, and they did disclose it privately, but they were a bit too impatient and sending numerous emails within a short period of time on the same day. So our tip here, give the team some time to respond, because they might actually be asleep while you're working. And they might also have some response timeframes published.
They might also be at a hacker conference.
Oh, really? Yeah. Or a hacker conference. All right. Dear Faily Monster, I ran an automated penetration test suite on demo.faily.monster and found number 1, 2, 3, all the way down to 20. Please fix and design CVEs.
So the good bit about this is they reported the problems privately. The not so good is they used infrastructure they weren't supposed to test on, and no proof of concept. 95% of the results are false positives.
So, kind of probably pretty obvious, our tip here, review the security and responsible disclosure policy and any associated information. You might also find a list of certain previously reported issues that aren't actually problems, and therefore you can kind of cut down on those false positives. Dear Faily Monster, this is an email not sent by the security researcher.
I stumbled upon repository.git and was wondering if you knew about the issue. It has a CVE number assigned.
So again, in this case, the researcher did find a legitimate issue, and again, they reported it privately. The researcher found the legitimate issue, but it was not disclosed by them. So they did not communicate with the team and therefore didn't do a responsible disclosure. Instead, they immediately published the problem, therefore putting a lot of organizations around the world at risk. So our tip, get in touch with the team privately to do a responsible disclosure. And also the issue that you may have seen might actually have wider implication than you can see at first. Therefore, kind of giving the team a little bit of time to figure out what is actually going on. So to summarize, we'd like to offer those 5 tips for you as Faily's tips for security researchers.
Number 1, don't rely solely on automated tools. Check the context. Number 2, don't disclose others' vulnerabilities. Number 3, read published security information. Number 4, get in touch privately. I'm out of fingers. Number 5, give the team time to respond.
But of course, since information security researchers are not the only party in a vulnerability disclosure conversation, we'd also like to offer some advice to organizations. Here are Faily's tips.
Number 1, don't panic when you are contacted. Number 2, read resources and guidelines.
Yeah, so here in Aotearoa, for example, you can find information about responsible disclosures and much more on the websites from CertInset and the Privacy Commission.
Number 3, have a responsible disclosure policy and a contact. Number 4, consider outsourcing the handling of disclosures.
And so, for example, you can use services such as Bugcrowd and HackerOne.
Number 5, respond in a timely fashion and engage with the researcher.
So these are our 5 tips for information security researchers and organizations alike when communicating about security vulnerabilities and how to work together to fix them. We'd like to invite all of you now to check your workflows and also policies to help you being taken more seriously by the other party. Kia ora.
Old mate Failure Monster back on the stage. Number 4th appearance at a Kawaiicon. Now, moving on quickly. This is probably not the first time we've had the Bureau on stage at Kawaiicon. I remember the first time was a little more contentious, and it's become less contentious over time. And I always used to think that the spooks had stolen my hobby and used it for geopolitics. But it actually turns out the spooks were doing this 25 years before I was born, and are actually pretty good at it. So that's been rather a hard pill to swallow, to be honest. They knew about meme corruption like 20 years before we did. It's very rude. Anyway, it's my great pleasure to welcome to the stage, from the government, here to help, as always, Yargs.
Tēnā koutou, tēnā koutou, tēnā koutou, tēnā koutou katoa, ko Kakipuka te maunga, ko Waipa te awa, ko Tainui te waka, ko Ngāti Maniapoto te iwi, ko Ngāti Uikaha te hapu, ko Toki Kapu te marae, ko Michael Yargish Tonga Wingua, or commonly known as Yargs, and I'm here representing the National Cybersecurity Centre. I started working for the NCSC in around 2016. I've been privileged to do a lot of cool stuff, but I never thought that I'd be up on stage at Kawaiicon after the Cookie Monster, so you never know what's going to happen. So the Kawaiicon organisers pride themselves on bringing together the entire InfoSec community at this event. Their website says here you'll see suits, spooks, hobbyists, researchers, consultants, engineers, analysts, testers, and management. So I'm very proud to be representing an entire part of that demographic. But I'm sure, actually, most of you wouldn't be surprised to know, I'm not actually the only spook here. Just as this is a really important event on the New Zealand InfoSec calendar, it's a really important event for us too. And there are a lot of my colleagues from the NCSC here scattered amongst you in the audience. It is good to see, though, they have all been diligently following security advice and been ignoring me for 2 days straight. This is a really important community for us to be a part of, not only to be here to listen or learn or be lucky enough to be here up on stage, but actually for us to find people that we need to work with, because we've realised that collaboration is the key to building a cyber-resilient New Zealand. And the development and delivery of our malware-free networks capability is a key example of that. So that's what I'll focus on for my talk. I think one of the challenges for us moving forward over the next couple of years is actually to be less spooky. So we're working on that, and my presentation here is part of that approach. So before I start, I do need to thank the Kawaiicon crew for having me here today. I'm actually moving house today, and so anyone who's moved house in Wellington knows that that means a lot of stairs and a lot of work. So there was quite a lot of negotiation with my wife, who is thankfully at home looking after my baby and doing the rest of the packing. So that's one of the really good benefits of working where I do. Whenever you want to get out of some chores, you just pull the, I'm sorry love, it's a matter of national security card, and then here I am today. So the National Cybersecurity Centre. So we focus on the cyber resilience of nationally significant organisations. These are organisations across the public and private sector of which New Zealand depends on for security or well-being. We're primarily focused on what we call national level harms, and these are particularly state-sponsored actors, but really any threat or vulnerability that has an impact to impact the economic or social well-being of New Zealand. We fulfil our responsibilities for a range of cybersecurity functions, ranging from protection of classified information, regulation over certain sectors, providing advice, threat detection, disruption, and when all else fails, incident response. And we do all of this by grouping all of our services under 4 key headings: advise, detect, deter, and disrupt. But these aren't mutually exclusive areas, and in fact, I prefer to think of them as a circle. So we detect indications of malicious activity, vulnerabilities, or weaknesses throughout New Zealand. We do that through both technical capabilities, but equally through extensive customer relationships. We then disrupt these threats from having a harm on our customer environments. This can range all the way from incident response, or releasing an advisory on our website or through our mailing list. We also have our active disruption capabilities, which I'll focus on more towards the end of the talk. Through all of this detection and disruption activities, we gain a really good understanding of the New Zealand landscape, and we use this to create advice, which helps our customers focus in their security efforts. What we learn from an incident or a threat in one place, we turn into advice to reduce the likelihood of that having an impact elsewhere. And we also maintain the Friendly Neighbourhood New Zealand Information Security Manual. As a result of all of our efforts, we uplift security throughout New Zealand, which in turn deters our adversary because we're raising the cost of targeting New Zealand. However, the cycle continues because as we raise security, our adversaries develop their own capabilities and use new techniques which we must then detect and disrupt, and so the cycle continues. So our service offering represents a multi-layered approach as required to combat cybersecurity, and we encourage all of our customers to think of cybersecurity in the same way. One of our roles is to provide intelligence or assessments for New Zealand government on the cyber threats. So before I talk about our efforts to stop threats, I really need to talk about some of our view of the cyber threatscape. So firstly, we're seeing actors evolve the way in which they conduct their malicious activity. Some of the key trends here are that we see an increase in the speed and scale of scanning and mass exploitation of recently disclosed vulnerabilities. Malicious actors quickly take advantage of this by targeting every device and organisation that could be vulnerable. They establish footholds in these networks, and then they selectively return to targets for further compromise. Actors are also becoming more savvy with their extortion techniques and the way in which they exert pressure on organisations. Techniques that make money survive and are amplified or copied by others. Actors are making more use of disposable infrastructure, and sophisticated actors are repeatedly compromising the same organisations and ignoring containment efforts, especially the sophisticated state actors. To make all of this more complex, we're also seeing the nature of the threat actor evolve, in particular the blurring of the lines between state and non-state actors. So financially motivated groups now have access to sophisticated tools and techniques that were once exclusively the control of the state. So the malware-free networks capability is a key way for us to combat this ever-changing threatscape. So before I talk more about malware-free networks, I first have to talk a little bit about the whakapapa of our cyber defense capabilities. So Project Cortex delivered a suite of cyber defense capabilities to private and public sector organizations where NCSC can make use of our unique insight and intelligence to detect advanced threats. Our goal here is to complement existing security services. We provide these organizations to consent. In fact, when I first joined the GCSB, my role was part of the Cortex rollout team, where me and my team, we went around the country talking to a lot of people, sort of along the lines of, hey, we're from the GCSB. You may have heard of us from fun times such as Kim.com or the Edward Snowden links. How do you feel about giving us some of your data? Very, very fun times. So our cyber defense capabilities allow the NCSC to find evidence of known malicious activity, and we leverage our unique position as an intelligence agency and our international partnerships to understand the TTPs of malicious actors and use this to focus our detection efforts. In a typical month, we detect around 15 to 20 incidents. Where malicious activity is identified, we produce an incident report for a customer or deploy our responders, depending on the severity. And where we see threats impacting multiple organizations, we'll produce more general advisories so that other organizations can protect themselves too. Crucially though, through these capabilities, we've developed a really good awareness of the types of threats New Zealand organizations are facing. Our suite of cyber defense capabilities though are quite technologically complex and require a lot of effort to maintain and even more effort to keep pace with changes in our customer IT environments. So from day one, we knew we needed to look at alternative mechanisms for scaling beyond our kind of one-to-one customer relationships. So in 2017, we worked with Vodafone and developed the initial malware-free networks pilot. This produced some really successful results in terms of us being able to disrupt high volumes of activity, but also getting some feedback about the uniqueness of our indicators that we were producing. It was really pleasing to make some of these breakthroughs, but it also helped us identify two key flaws. First flaw was that the original solution was built and operated by us, which effectively led to us operating as a managed service provider, which isn't necessarily our area of expertise. And secondly, we didn't receive any feedback on our service. It essentially left us blind. We were pumping our intelligence out into the world, but were unsighted as to the utility or value it was providing to our partners or customers. So all of that leads us to the malware-free networks of today. We realized that we needed to evolve beyond the development of secret capabilities within our secure facilities and work more collaboratively with partners. Luckily, the GCSB pride ourselves on our ability to listen, so we went and talked to experts throughout the country to identify the most effective way of providing threat protections at scale. And we recognized the key here was to partner with private sector and to develop a service that complemented what they were already doing. So instead of developing and deploying our own tech, we found a way to add our unique value to what was already out there. So Malware-Free Networks is a cyber threat disruption service, which we deliver in partnership with the private sector. We generate IOCs and disseminate this to our partners. Our partners span the New Zealand telecommunications, managed service provider, and cybersecurity markets. Our partners then use this threat intelligence to detect and disrupt cyber threats to their customers. Information regarding disruptions of these threats is sent back to NCSC as a telemetry feed. This enables us to continuously improve our intelligence, but it equally gives us that situational awareness about the threats facing Aotearoa. We provide our threat intelligence via industry standard protocols, and our partners make use of it to integrate it within the existing security services that they offer customers. So Malware-Free Networks requires no NCSC-owned or operated technology to be deployed into customer environments. Pretty simple, right? The key to our service is therefore our threat intelligence, which is made up of IOCs, which we receive from our international partnerships, but also, and predominantly, domestically sourced IOCs. These may be indicators that we become aware of through our incident response engagements, or they might be indicators generated through our other cyber defense capabilities. Importantly, for every indicator, we run a robust validation process to make sure that the indicators are of high quality and are not going to disrupt legitimate traffic. All IOCs are run through a list of safeguard checks and then through an impact assessment process where we use the visibility gained through our other capabilities to understand the likelihood of an IOC being a false positive. Another key part of this validation process is that telemetry that we receive back from our partners. For each disruption event generated by MFN, our analysts receive a telemetry receipt containing which IOC caused the disruption, the time and date, and the 5-tuple. And this means we get near real-time visibility of our effectiveness and can react quickly to any issues. So a lot of this happens automatically and 24/7. In fact, Malware-Free Networks is doing the mahi right now, even though I could neither confirm nor deny how many of my colleagues happen to be in the audience. We are very aware that our IOCs have a limited shelf life, and as such, throughout this project, we've had a real focus on the generation and dissemination processes. Our classified alerts and IOCs can now be moved out of our classified systems and shared to our partners within minutes. When we launched Malware-Free Networks in November last year, we knew this would be a real step change for New Zealand's cybersecurity posture, and particularly how we could have impact at scale. The most common type of activity that we are disrupting is remote scanning or exploitation, and this is really important because we know even the most sophisticated actors are looking to take advantage of known vulnerabilities. Through this work, we're taking away any easy wins from our adversaries. We monitor for threats and we keep our service up to date with the latest developments. For example, at work, we have a current heightened focus on the Russian invasion of Ukraine, and our MFN IOCs reflect that. We quickly push indicators to MFN when a major vulnerability is released. Top of mind are Log4j, Bazaar, IcedID, and Flubot. So if you are seeing a threat in the news or in the InfoSec community or Slack, then you can expect that those IOCs are included within Malware-Free Networks. One of our key findings so far is that geographic relevance really matters. The MFN IOCs are highly unique and relevant to the New Zealand context, in contrast to a lot of other threat feeds, which are often focused on the Northern Hemisphere. We receive feedback from our partners constantly who compare our intelligence to feeds they receive from others and find that our IOCs are largely unique. In fact, over 95% of the threats that are disrupted through Malware-Free Networks come from an indicator that we have generated at the NCSC. And this is because those indicators are specifically generated based on our visibility of threats in New Zealand. We have a huge amount of confidence in the IOCs we are producing. We aren't always able to share the context behind an indicator, but you can be assured that we're using the breadth of the NCSC capabilities, insights, and relationships to fuel this IOC production. Importantly, that is why Malware-Free Networks is a disruption service and not a hunting feed. We are definitely most effective when we can prevent harm before it happens. So Malware-Free Networks hasn't happened overnight, and our partnerships are key to getting us to where we are now. Our teams have worked hard to get systems integrated, and now we are working together to make sure that the insights we gain through MFN are usable from our partners and our customers to improve cybersecurity throughout the country. We're really proud to be part of this cybersecurity industry alongside our partners. So where to from here? So through Malware-Free Networks, we've learned a lot about how to achieve major impact for New Zealand. To build our cyber defense capabilities, we've established a good set of relationships across the country and proven that people are really keen to work with us to help protect New Zealand. We look forward to building off this model and applying the lessons to other parts of our work. As the heart of Aotearoa's cyber defense, we're a group of passionate people, and we're at the center of a lot of work and have a lot of experience and knowledge, but we can't do it all, and we recognize our work has the greatest impact when we combine with others. It's all of our responsibility as security professionals to be on the same page when we talk about why cybersecurity is important and what people should be focusing on. It's been an honor to represent the NCSC up here today as part of the Kawaiicon whānau. Maybe next year you'll see another spook up here too. He waka e ke noa, we are all in this together. Nō reira, e hoa mā, mi mutu a ke kaine, ka haere tonu te mahi.
Thanks very much. One of the downsides of a lightning talk is it's not really long enough to train like an audio deepfake engine so that we can like overdub him from offside of the stage, so that then his minder would have to run out and spear tackle him. But yeah, downside, didn't manage to do that in time. It is actually really great having the spooks here and amongst us. They have been amongst us all along, but at least now they're a little more open about it. But the importance of involving the hacker community, the research community, the commercial security, academics, and the spooks, we are all in this together, as the man says. So I remember when the first spooks started coming along to 2600 and ISIG meetings back in the old days when Paul McKittrick was really influential in the outreach from the spook world to us hackers. And we built relationships over the years, and those relationships, especially in a country this size, do get things done. So moving on, you're all good to go. Excellent. So my pleasure to introduce to you our next speaker, who once upon a time made like machine-learned videos of the day in the life of a bus, which is interesting stuff. It was interesting bus rides. Anyway, Mr. Douglas Bagnall.
Kia ora. This talk is going to be a little bit technical, but it won't be too long, so don't worry. I'm talking about fuzzing, especially with regard to open source software, which has got incredibly better in the last decade or so, or 2 decades maybe now. So fuzzing is testing software with random input. It's immensely more effective, as I just said, if you have the source code, because, well, you'll see. And it's supported by the industry for open source code. And when I say industry, I really mean Google, but I don't really want to say Google in case that offends Red Hat or somebody else who does a little bit. So the term and the concept comes from the late 80s, when in those days, to work remotely, you'd log into your VAX machine or something through a phone modem, and then the weather would put extra characters in the stream, and that would sometimes make things crash on the other end. And some people in Texas, they suddenly thought, maybe that shouldn't happen. Maybe unexpected input shouldn't make things crash. It could make them fail, but not crash. And then they started testing software with random input to see what crashed. And like about a third of the Unix utilities that they tried did, and they wrote papers. Over the years, they wrote a whole lot more. So the ways you can do it with the old ways of doing it is you can just pipe random noise into a program. Like with LS in this example, it won't actually do anything because ls doesn't listen on standard input, as far as I know. And you can pass the random noise as the main argument, except that will actually be fuzzing the kernel, not the ls program, because that path name is passed by the kernel, I think. You can make a whole lot of random options. In the GNU ls, there's about 40 options, and some of them take arguments, so that is a huge space to search. Or you can do things like set the environment variables that ls will then pass. And this is, for ls, that's probably the richest way to find bugs that I can imagine. But it's also not probably a good attack vector, setting environment variables. If you can do that, you can already do other things, I imagine. So the main thing that's made it better, apart from computers being 100,000 times faster, which does help, the main thing that's made it better is coverage-based fuzzing. And that is using an instrumented compiler, a special compiler that kind of, when it compiles, it doesn't just make it the fastest machine code it can, it keeps track of what it's doing, and it notices where you're going through the code, and then when the random string finds a new edge or new pathway through the code, just takes a different branch on one of the ifs or something, then it makes new inputs. It uses that as a parent to mutate to make new inputs. So it has the generations, has evolution. So it's still a random process, but it's an evolutionary random process rather than just making up noise. Now, I'm going to explain why this speeds things up, like by a number that you can't even give a name to. So here's a function that might crash. Now, it takes a string and a length, and it returns nothing. Now, if the length is not 5, it returns nothing. That's it. The function's over. Then it says if those 5 bytes that you do have, if they're not these, it is Samba. There's a project I work on, the old slides. If it's not that, it'll crash. Abort means crash. It's the way you can make yourself crash. So this function will crash if it gets to there. So if you're giving it random input, you've got 5 bytes is 40 bits. So that means you've got 1 chance in a trillion of picking the right numbers, but only if you pick a thing of length 5. And we don't know what the chance of picking length 5 is just by saying we're giving it random input. If it's a random size t, it could be, it's very low. If it's probably skewed towards small numbers, so maybe you've got a better chance. So we can say there's just a really low chance of this function crashing with general random noise. Now, with coverage-based fuzzing, the fuzzer, the framework that's doing this, it works out some pathways through the code, and it says, it goes for a little while, and it finds that when it chooses a 5, it opens up a new pathway, and so it starts concentrating more on that. But this isn't actually how it looks. This is how it really looks, because it knows that to compare a string 5 bytes in a row, it can compare them one at a time. So it can, if it's 5 letters, then it says, is it an S, is it an A, is it an B, M, is it whatever. It knows how to spell, I don't. And so rather than being 1 in a trillion, it's like 1 in 1280. And so it finds its way to the abort, just like that, whereas the other one, 40 bits is not good encryption, but you don't want to wait for it. And it's not trying to find the abort, it's just it's just colors in this diagram, colors in the edges red as it crosses them. So it's just trying to cover them all in. So coverage-based fuzzing has just made fuzzing immensely better. And this contrived example is contrived to make it look not as good as it really is, because in the real world it's even better than that. So it's like there's numbers that you can't even name, because, you know, who knows what's past quintillions. But then another thing, second thing that has made fuzzing much better is sanitizers. I'm talking mainly about the address sanitizer, because I don't have time to talk about other ones. So imagine you've got an array of 700 bytes, which is the size has been chosen to make it look like it visible on the 4K page, because memory is arranged in pages, usually the 4K. And now, access outside of your array, if you go a little bit out either end, it won't segfault, right? And if you go too far out, you'll land in some other memory, and you can change things there or read them or whatever, and no one will know until something tries to use it, or until you read the secret and you've got the password, whatever. And then there's other places where you will crash. So you can crash with it, you can segfault by doing out-of-bounds access, but you usually don't. But what a sanitizer does, the address sanitizer does, is it just says anything that is out of bounds will make that crash. And so it slows things down, but it actually makes things infinitely faster, because there are bugs. Like if you're reading one parser and something that isn't 8 bytes long, it's never going to actually go over the page boundary. Everything is aligned in a certain way that you just can't crash sometimes with the out-of-bounds read. Now, so before we were using, I was showing ls as an example. ls is a bad thing to try and fuzz, because it doesn't really take inputs in the ways that you want. But what you do is you write a fuzz target that wraps parts of your code and fuzzes like manageable chunks. You make little programs that use your program, and you can fuzz them, and you can find a good-sized part of your problem space and fuzz it. If you try and fuzz everything, like I work on Samba, it's a terrible project. It tries to be Windows. It talks Windows protocols, and so it looks like to the other computers like it's a Windows machine, but it's really the Linux machine pretending. And it's got so many holes that data comes in and out, and so many processes, and everything is so huge that I've been working on it for years and years. I've got no idea what all the things are, all the ways that data comes in and out, and all the configuration. There's like, I don't know, it's megabytes of documentation even, I think. It's easy if you've got an API that's writing a fuzz target. It's not very easy if you've got lots of global state. If you've got things like, if you put an exit all the way through the code, like a lot of programs do, if they just read some more standard in halfway through in the middle of some function. If everything's in one file, if you've got crazy event loops, databases would be down there at the bottom of that. So the way if you're starting a new open source project, or even a closed source project, you should be making a source directory, test directory, and also a fuzz directory that has fuzz targets, and start thinking about it from the beginning. Or you can just add one on later. So that's the third thing. It was writing fuzz targets has made fuzzing much more tractable than trying to fuzz the whole program, especially when the whole program is something like Samba that it forks 100 times before it does anything anyway. Persistent fuzzing is an extension of that. So your fuzz target, if it's got a special specially named function or special function, it loads it as a library rather than loading it as like running the whole thing, and then it just fuzzes that, runs that function over and over again. Or in Python, you can do it a different way. You know, there's all these decorators and stuff. There's actually different ways you do fuzzing in Python. There's more than one way to do it, of course, with Python. And so, like, this is nominating this function to be loaded in the library and fuzzed and fuzzed and fuzzed. Now, so in Python fuzzing, what you normally do is, and a lot of other languages, but Python is one example. Any uncaught exception is an error, and so you catch the exception that you want, that you expect. Like if you're doing, in this one, you're doing int, which you wouldn't normally be fuzzing, because as part of the Python itself, it's not your function. But if you were, you expect to get a value error if you give it something that doesn't make sense if you read it as an integer. But any other exception, there's something wrong with Python, right? And you can also do things like you can pull apart the data that you get in. Like this example is taking the first byte, if there is more than one byte, and using it as the base. So if you can say, does this pass as an int in base 32 or something? Okay, so now back to that earlier example where I was trying to match the string samba. For doing that in Python, and the data is compressed with zlib. Now, it will never get through this. It'll just be, you'll be fuzzing zlib, but you already trust zlib, because if you didn't trust zlib, nothing in the world would work for you. So you don't, and it'll never get past that. So, and if it does, it won't get past the next bit. So it's just trying to, randomly picking things in zlib. So what you do is you have your mutation function, you change it, so you have a custom mutation function that decompresses, then does the mutation that it would have done inside the compression, and then compresses it again. And that means you can transparently see through things like that. So there's that kind of thing you need to do. So, yeah. In summary, this is midpoint kind of thing, and it's quintillions, or an unnamed number times infinity times other smaller numbers, but millions, better than it used to be, right? If you've got the source code. OSS Fuzz, which is run by Google, if you write fuzzes for your open source project, they'll run them for you for free, forever, or until they lose interest. They're doing it in there. Your enemies are fuzzing your code if you're not, and they're finding the bugs. They're finding millions of crappy bugs that you don't care about, but some good ones. And you will find bugs. Now, I've got about a minute, so I'll go through how would you really fuzz LS. It's got all kinds of things like main, it calls exit, or it calls abort. So what you need to do is you have your fuzzing target, you include the LS source code, you redefine main to be not so main now, so that the main won't be called when you're doing it, it will jump to your function. Then you redefine exit to be a long jump, which is like an exception that you can do in C. And then you call the thing that you're trying to parse ls colors, or you do the main. You need to make up an argc and argv. And that's all. The truth is you'll find lots of crappy bugs, and there's 6 seconds until the sparkles.
Thanks very much. In the old days, computers were pretty simple, and if you wanted to think about the security of them, you can kind of reason about it in your head in a pretty straightforward way. And, if I'm on a Unix box and I think like, what do I want? I want root access. How many ways do I get there, right? I can go through a syscall, I can go through sudo, I can go through a service that's already running. Like, I can sit there and think, here are the number of privilege gates I can go through to go from low privilege to high privilege. Now we don't run Unix anymore. Now we run AWS. And I don't know how AWS works, and I can't reason about it. And that makes dealing with the complexity and understanding which bits you have to look at to understand where the controls are and what they actually do is very difficult. And the process by which we have to go through is called threat modeling. And I understand how to threat model a Unix box, but I don't understand how to threat model crazy cloud future madness, which is why we have Taryn.
Hi, everyone. Thanks for taking some time to listen to my talk. For those of you who are still there online watching this talk, I really appreciate it. I know this is day 2, probably coming towards the end of the conference, pretty close. So yeah, thanks for taking some time to listen to this. So my name's Tarun. I work in the security, risk, and compliance space. But don't worry, I'm going to talk to you about ISO requirements, not going to talk to you about SOC or NZISM or all those kind of things, because what I get to do is something really exciting. I think it's really exciting because I get to work in the risk and compliance space, but also get to do a lot of threat modeling and risk management. So I get to work with engineers, get to work with developers, and then see actually how does our organizational requirement fit into their day-to-day activity. So I've been to Kiwi/Kawaiicon a few times, but I've never given a talk, so I'm slightly nervous, so hope you're a bit more forgiving. But the topic that I thought might be really relevant for today is making threat modeling easy and scalable using the Stride framework. So what this talk is really about. So if you were expecting something like this, and I'd show you how to do that, I'm sorry to disappoint you, that's not what this talk is about. What this talk really is about, it's about my story. It's about what I've learned so far and what worked for me. I'm really hoping after my talk, you can take at least something away and use and make it a success story in your organization as well. So what is my story about? 2 years ago, I was given the task in a really big company that I need to implement a threat modeling process that is widely adopted, that is super easy to do. I thought that was easy, but it's not. So I work in a company which has got a global footprint. I think we've got about 4,500 staff across the world. More than half of them are developers and engineers. And I'm not even an engineer. I'm a risk guy, so I'm not that technical either. So it was 10 times harder. But I thought it's doable. I gave it a lot of tries. I failed sometimes. It worked out for me eventually. At least I hope it worked out. So in this talk, I'll be sharing that experience with you. I'll be talking about, at a very high level, what threat modeling is, what is the Stride word, actually. I won't go into too much detail about that, because there's lots of other talks, lots of other resources online that you can look up. So I'm not going to try to replicate that. And in my story, I'm going to tell you, why do people or companies find it hard sometimes? Why do they sometimes struggle? And then what is my way of making it easy and scalable? So like I said, this worked for me. Maybe it works for you. Maybe it doesn't. You might have to tweak a few things, and it might work for you. So moving on to the first part, what actually threat modeling is. I know a few speakers have already touched on that. But if you haven't heard about threat modeling before, there's a few dictionary definitions out there. In a nutshell, threat modeling is about looking at threats, thinking about your threat actors, so maybe people outside your company, maybe inside your company, your third-party supply chain, and all those kind of things. And then thinking about vulnerabilities that they could exploit. And then how are you going to stop them? What are the mitigations you're going to have? So basically, threat modeling is this exercise. And then what is Stride? So Stride is really a framework. There's lots of other frameworks. I'm not saying Stride is the best framework. What I'm saying is Stride worked in my scenario. There's maybe another framework that you can use, or you can use things like attack trees or just playing cards if that's what you fancy. But Stride worked for me. So if you haven't heard about Stride before, Stride is a framework which was, I think, developed in 1990s by a couple of people back in Microsoft. And essentially, what it really addresses is, it helps you answer the question, what can go wrong with the product or the feature that you're building? And that's it. It's really simple. It is an acronym, so it does have a sort of meaning to it. And like I said, I'm not going to go into too much detail about STRIDE, but I'll tell you what the acronym stands for. So it stands for spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privileges. Maybe that's too much to remember, maybe not, you're already familiar. Whatever the case is, that's okay. You don't have to remember the whole thing for this talk. But what I really want you to remember is spoofing, so basically pretending to be something or someone that you're not, and denial of service, which is taking actions to make something unavailable. And the reason I'm asking you to remember these two is because I'll be sharing an example about these two later down in my presentation. So, why is it actually hard? So, coming back to my story now. When I started my journey, I was someone like this in this photo where I had all my sticky notes ready in a workshop. I was standing next to a whiteboard with an engineering pod, a whole bunch of developers in there telling me about their product. And I said, cool. So what's the threat should we start with? I've got lots of sticky notes. So I'm hoping we come up with a lot of them. But we really struggled. And then that happened again. And it happened again and again. And I said, why is it actually so hard? I thought threat modeling is really easy. I mean, I think I figured out the STRIDE framework, so maybe it is easy. And there were a lot of things. So I thought there was maybe tools, like maybe I actually didn't have a good tool that could help me push out a really good diagram, tell me what my boundaries are, what I need to protect, what I really need to worry about as a threat for threat actors, and all those kind of things. So maybe tools. Maybe there's not enough training in my company. I know people have to complete modules when they join the company. There's annual refreshers. I've put out Confluence pages, and I think there's also like training videos. So is it actually training, or is it tools? Is it something else? Or is the process really actually complicated? I actually don't know where to start. Do I start looking at my UI, which is open to the public? Or do I start with my database layer? Do I start somewhere else? Which threat actor do I think about first? So it's really hard. When you actually sit down in a workshop and you think about what's the first threat I'm going to think about, and you can't just start with things like man in the middle, because where is that man in the middle? Is that man sitting in your office? Is that actually a person sitting on your cloud, in your browser, somewhere else? So it can get really complicated really easily as well. And then there's always this question, how long should I spend on it? How long should I book a workshop for? Half an hour? 1 hour? 2 hours? 4 hours? And that's really a good question, because a lot of the time people were asking me how much effort should I really spend on threat modeling. So to put that into perspective, imagine at the bottom of the scale we've got time. On the left we've got the value of the exercise of doing threat modeling. So the more amount of time you spend, you'll start coming up with threats. But there will be a time after a while you'd say, okay, I've spent a lot of time, but I've still only got 3 or 4 relevant threats. So maybe that's good enough. But that sweet spot, which is where you want to be, where does that actually sit? And the answer is, it depends. So something really simple where you've got a user interface, an API below it, or maybe a BFF, and that's a simple application, maybe half an hour, maybe 1 hour. But if you've got something really complicated, a really complex architecture, you've got multiple endpoints, multiple external integrations with a government agency, with a bank, with someone else, maybe 2 hours. So it depends on your architecture and how complicated your feature is. So then how do we actually make this really easy and scalable? Because there's a whole bunch of questions we went through. I haven't given you an answer yet. So I think maybe the best way to address the answer is to put it into 2 categories. One is have a really cool tool. And then second is have a really good culture, a really strong culture around it. And so I'm not going to ask you to go and spend some money and buy a really cool tool. I didn't do that. I couldn't afford that anyway. So what I'm going to talk you through is, in my story, how I worked through these 2 things. So I'm going to talk to you about how to build a tool. So you can go to the market, you can spend a lot of money, you can get something really flash that will spit out a lot of diagrams based on your infrastructure code, and they'll tell you what are your boundaries, be it AWS or Azure or GCP, and then it'll tell you these are the relevant threats you need to think about. That's cool. I didn't want to start there, so my tool is just a lightweight questionnaire. It's a bunch of questions. That's it. It's actually sitting on a document. That's probably it. That's my template. That's my tool. So when I talk about a tool, imagine a questionnaire. That's how I started. So how do you actually build one? And why do you need one? So there's different ways you can build one, and the first one I'd highly recommend is starting small. So my first attempt where I failed, I went in with a really complex questionnaire. I think had about 60 questions for an engineering team to answer, to say, hey, have you done this, have you done that? And at the end of the day, I sort of didn't get any value out of it. I know they didn't. So it was basically garbage in and garbage out. So what I really recommend is you start small. So when I started small, eventually, I said, I'm going to only ask you 5 questions, or maybe 6. And these are going to be basic questions. Tell me, how do you encrypt your data? Tell me, how does authentication work on a feature? What's the worst case scenario? And that's it. And I was really fascinated to see some of the answers, because it was an eye-opener about how engineers and developers really think about threats, and how does security think about threat? How does a risk person think about a threat? So it's quite interesting. So I'd recommend starting small and having practical expectations. So my expectation was not telling them this is a security requirement. My expectation was, I just want you to have a crack at this. If you can't come up with a single threat, that's good enough. But have a fair and honest crack at it, and see if you can come out at least with one threat. And then make it relevant. I started with questions on blogs and external resources, but I started making them more relevant. I said, hey, by the way, we use this build and deploy tool. I'm going to ask you a specific threat question related to this tool. What do you think now? So start making it more relevant. And most importantly, focus on consistency and speed. So use a framework that works for you, and to make it really consistent, but make sure you're still doing it really quickly. You're not asking for people to jump into 2 or 3 different workshops, and you're not getting in their way. And then, as you keep doing that, keep on providing more training, keep on taking more feedback, keep on sharpening your questions. I've had times where people have told me, this process is garbage, and your questions are wrong. And that's okay. So I've taken that on board, and I said, you tell me, what would you like to see? And they've spoken to me about really good sort of threats and relevant questions. So I keep on sharpening the questions. I keep on building that tool. I keep on expanding it, taking on questions, and adding more and more specific context. It does take time, but it really works. And so eventually what I'm saying is, through all these steps, keep on providing support, keep on talking to your team, see what really is working, but always make sure you're going lightweight. You're not going in with a bloated process, which is going to take too much time, too long, and you've spent a lot of time with minimal value. So make sure you always go lightweight. So when I talk about my tool, I'll take you to a quick example. So if you remember spoofing when I spoke about Stride early on, spoofing threat talks about basically authentication threats. So I ask questions like, how does authentication work on your feature? How does customer identity work? How do you use our own internal identity service? Can something go wrong there for your product? Are you using any hard-coded secrets or secrets which shouldn't be in the place where they're not meant to be? And by the way, when I'm asking all these questions, I'm saying, think about these tools. This is what we use in our company. Does this apply to you? Does this apply to your feature? So it could be things like Team City, or it could be our storage buckets, S3 buckets, or storage accounts on Azure, and all those kind of things. So the same applies for denial of service. When I'm talking about denial of service, I'm not just saying a distributed denial of service attack. I'm saying, have you done the bare minimum at least? Have you put your thing behind a web application firewall? But by the way, if you've done that, what about the other defense and depth mitigations? Can things go wrong there? Can an authenticated user still exploit the function of your feature? If you're sending out emails, text messages, or maybe just allowing people to upload CSVs, can someone exploit that? Can an logged-in user actually exploit your functionality to still cause some harm? So think about these things, and then think about things like ransomware scenarios. Can your feature easily be restored? Can you restore customer data if we get crypto-locked? And that really gets people thinking, because now you've given them a starting point. You've given them a set of questions to think about, so you've given them something to work with. So that was a quick sort of rundown on how I went and tried to make my tool, how I keep working on it. And the next thing I want to talk about culture. And so when I talk about culture, I'm talking about security culture. And this is something that is really close to my heart. And there's 3 key things I want to highlight here. The first thing I want to highlight is having realistic expectations. I don't know everything about security. I've never met someone who knows everything about security. And for me, security is really hard. But there are people who understand how a web application firewall works. There are people who understand how key management and encryption works. And that's okay. So you can't have the same expectation from your developers or your engineers in your company that they should know everything after doing a risk assessment or a threat modeling exercise. So have realistic expectations with people that are actually doing this exercise. The second thing is, don't get in the way. there's a Twitter account I follow, and they shared this text message online from one of the tech engineers in another company, and it was really fascinating. And this person was saying, basically, now there's 300 reviews, before I can have a product launch. Don't take this text message literally, because what they said was, hey, remember the time where you used to be, have an idea and then be able to ship it the same day? Maybe that's not good for your stability or security, but like that really spoke to me as well. And I thought, are we getting in the way? Like, one of the speakers mentioned shifting left, and I truly believe that. But then when you try to shift left, don't shift left along with your 20-step approval process, not with all your spreadsheets, not with your ticketing system. That's not shifting left. That's just moving the problem from one end to another. So make it really easy and stop getting in the way, remove the blockers, and any admin overhead. And last but not the least, don't be the bad guy. I work in risk and compliance, and it was an eye-opener when I remember in my first workshop, I said, hey, I'm a risk and compliance guy, and the response I got was, oh, here we go. This guy's going to start waving his compliance stick at me. And so if you get that sort of reaction, you probably need to work on that, because security is only as good as what's in your product. So when I saw this tweet, I said, that's really good, because difficult things, you can't just chuck them in a risk register and expect that, risk accepted and everything's good enough. So the reality is you have to work with people, you have to have difficult conversations, you have to take the feedback on board and really just help them. So in summary, make sure you've got a really good tool, start small, have realistic expectations, build a strong culture, and then that's how you can really make threat modeling easy and scalable. Last but not least, I just wanted to give a really good shout out to some of the people. If you know them, that's cool. They are still here, and they really helped me along in, this journey in the last 2 years. So if you see them, go and say hello. But yeah, that's my story. Hope you enjoyed it, and thanks very much for listening to me.
Awesome. Thank you, Tarun. Speaking of threats, what are the more common or scarier threats, especially for those of us who work in software development or application security, are supply chain or dependency vulnerabilities. So our next speaker is going to be talking about just that. So introducing our next speaker, NF.
Cool. All right. So this talk's basically about NuGet and dependency confusion within the NuGet environments. During it, I'm going to just do some quick demonstrations of what the exploit's like, and also talk about some bug bounty experiences I've had using this particular exploit. So my name is Matt Evans, or NF. I've been doing IT for about 20 years now, security probably for 6, and the more important thing is apparently I look like Beaker here. This is also how I'm feeling up here at the moment. So first talk. So the reason I decided to do this talk is in February 2001, I read this article from Alex Burson. And as I went through it, a lot of what he was talking about with the dependency confusion attack within NPM started to remind me of some work that I actually looked at a couple of years ago. So NuGet suffers from the same sorts of issues, but the difference is NuGet doesn't really get talked about. So I thought I'd actually go through, show what it's like, and yeah, pretty much bring it to the broader attention of people. So first, just quickly, what is NuGet? NuGet is essentially like NPM, NPM, but for the .NET environment. So it's a package system. It's used widely. PowerShell also uses it. So the packages themselves are just compressed files that contain things like your binaries, your static content, and in some cases they can contain additional build instructions for when you bring those packages in. So this is just what NuGet.org looks like. This is the largest package repository that's actually used. As you can see up there, Newtonsoft.json has got about 2 billion downloads, so that's quite a big deal. So what is dependency confusion? So the best way to think about it is if you have an application that's building and it's pulling in an external package, but it's got the option to pull in 2, it gets confused. So that's the simpler way of thinking it. Another way that I like to think of it is if I'm getting off the plane or going to the airport and I go to pick up my red bag, this is what I come across. Going to pick up the wrong one, probably get something that I don't need. So what's impacted by this vulnerability? So it's mostly build environments, but it's also developer like workstations in their environments. It's a bigger risk in your cloud, in the cloud, basically due to some stuff that I'm going to talk about briefly. So what are the steps, or what are the requirements for this vulnerability? So in NuGet, you've got these things called package feeds. So the first requirement is to be using more than one. So in this case, we've got NuGet, and then we've got a private feed here. The next one would be, within those feeds, a package that is used by the application that's being built is only in one of the feeds. So if you look at the bottom here, you can see Nest v7. So what I would do as an attacker is go and have a look to see if it's in both feeds, and for example, it's not sitting here in NuGet. So another requirement is you need to be able to upload to the feed that it doesn't exist in. NuGet.org is quite easily, the one that we're going to be going for. Anyone can just sign in, get an account, and actually upload a package that they want. There is one last condition. NuGet is really iffy in the way it works with packages. So when it's pulling down packages from multiple feeds, it's a race condition. The fastest package that's responding is the one that will get pulled down. So when you're working with cloud, you may have packages sitting somewhere in Azure, but generally NuGet.org is going to be faster because it's just built to be faster for the ecosystem. So I'm quickly going to go through and show what the demonstration of this particular vulnerability looks like. But beforehand, I'm just going to talk about the actual payload that I use. So this is a .NET.target file. This is a file that allows you to add additional build instructions. This particular file's got some embedded code, and all that code is doing is making a DNS call to a server that I set up. So during the demo that I'm going to play, you'll see just some DNS requests proving that this is actually executed. The other thing is with these target files, you can set up when they execute. So this is not executing when the package is installed, but on the pre-build event of the application being built itself. So the way that this has been set up is to do the live demonstration, I'd actually have to push a NuGet package up, but NuGet actually has like a 10 to 30 minute time before a package becomes available in a feed. So I preloaded the package, and in this demonstration, I've also got my secondary feed, which is showing here, just my get, and this is the happy package. This is the one that we want to run. So that's the bad package sitting on NuGet. That's not what we're going to get initially. What this has right here, this is the feeds that we're actually going to use, and this is just a basic application that is pulling in that Xamarin Loves Kawaiicon package that I set up previously. So all we're going to do here is run the happy path. This is a good package. And you can see it's pulling down from NuGet. Now, the important thing to note, it's pulling down from myget. The important thing to note is the actual timings here. So to pull down the actual package, it's taken 300 milliseconds essentially. Now we do the build. Now, this piece here is just the endpoint that is monitoring for any DNS calls. And so I've checked no DNS calls. That was the happy path. So next we're going to use the malicious package. So we add the feed that's had the package preloaded up. We clear the NuGet cache. We do a restore. And you can see that's already pulling in a whole lot of different packages compared to the myget one. So it's because it's going off to NuGet. The next thing to note is at the bottom, it's actually taken 10 milliseconds compared to the 300, so that's why the race condition's there. Generally, NuGet's always going to be faster unless your build server's right next to your repository. So that's the package being restored, but we haven't done the build yet. That's just the target file that was used, same DNS entries. And now we build the solution. So now that's built, that malicious code should have executed. We go back to, well, we will go back to that DNS server. And we check for any entries, and we can see that the request has been made. Oh, and I've lost my place. Oh, there we go. Cool. So using that vulnerability, I've actually done a couple of bug bounties just during COVID. So I'm just going to talk about what they were and the particular use cases that they were. So the first one was JetBrains. What we're looking at here is it's got 3 feeds, and we can see the ones that are highlighted as this Unity test libs. So the piece of code at the bottom is the package that they're using, but the interesting case here is they were actually dynamically building their application and code as part of the test for this ReSharper Unity extension. So when that was executing, it wasn't in a normal build environment, but because they're still using the same mechanisms such as the feeds and the NuGet restore on this code that they're building here, I was able to get code execution. Then there was Octopus deploy. So this was a different use case. So there's a concept on NuGet.org as prefixes. So for example, if you register a prefix, no one else can actually upload a package with that prefix. The best example would be like Microsoft. No one can upload packages with Microsoft dot whatever because that prefix is owned by Microsoft. So in the case of Octopus deploy, their prefix is Octopus. You can see that it's registered. I went through some of their source code on GitHub, had a look at a couple of these packages, and just ran a script just to check if they were registered. And apparently they weren't. So with that information, I was able to go and register 7 packages belonging to Octopus and just drop in some payloads just to do some DNS calls and provide information back to them to show that you can actually do that. So that was, for whatever reason, their prefix in NuGet.org was not registered correctly. So Elastic, they had a mitigation in place already, but we're going to see that the mitigation had to deal with the people element. So what you can do is, with your packages, you can use something called a packages.lock file. And what that does is it takes a hash of the packages that you're going to be using, or you've already pre-built, so that when you try and rebuild again, if any of those hashes changed or have changed, the build will actually break. So if you've been a developer and the build breaks and you're trying to get work through, one of the first things you do is you check to see if you can just get it working again. In this case, they regenerated the package lock file. So because this is now working with my malicious package, I was able to get code execution again within their build environment. The last smaller examples are just some stuff from Microsoft. So the first one is the extremely popular Power BI PowerShell application. So this is interesting because while they were using NuGet, they were also using PowerShell.gallery as one of the feeds. PowerShell.gallery is normally, PowerShell.gallery is used to host PowerShell scripts and store modules, and not normally the same sort of packages as you would expect as NuGet. However, PowerShell Gallery is built on top of the NuGet technology, which means if you've got a feed like this, you're actually introducing dependency confusion. So in this case, that bottom package, Platy PS, is just a PowerShell package. So while it was registered on PowerShell Gallery, it wasn't registered on NuGet.org. So again, it's a case of just changing, uploading a package, and because NuGet is faster than PowerShell Gallery, that race condition gets you code execution. So for this, Microsoft gave me nada. Nothing, it's not worth it apparently. The next one, slightly more interesting. So the PowerShell source code. So again, they're using PowerShell.gallery, but they've got a private feed for additional packages. What's more interesting is this PS desired state configuration is quite an important package, and it had not been registered on PS Gallery. This is used for DCS stuff. If you've done DevOps, you've probably used this in PowerShell in the last 5 years. Because that wasn't registered, I was able to upload to this, and this time it was on PowerShell.gallery. After this bug bounty, you can see at the bottom, that is roughly when they took over the gallery from me. So for this one, I got a sticker. That's much better than money. And the last one, probably not as interesting, Azure. So I managed to get code execution on the Azure function host, which apparently is what all the Azure functions sit on. So if we look at their NuGet feed, you can see, again, lots of internal ones, but at the very top, NuGet.org. So while most of their packages looked fine, there was this one that was just an outlier, this appinsights.testlogger. This shouldn't have been in there at all. So this is a package that all it was doing was when they were running their build, it would just give an update on how long it took to AppVeyor, even though they weren't using AppVeyor at the time. So this thing had been sitting around in my GitHub for 5 years. No one had touched it. Yeah. So managed to actually upload that, get some code execution in Azure. In the Azure build for this function host. For this one, I got a pair of socks. Actually, this was within scope, so this was a big payout. So yeah, but I think the upwards of the Azure bounties at the time was roughly about 40 grand. So I got somewhere close to that, but not quite. So there are mitigations for this. There's lots of them. I would say the best one, if you can do it, is the bottom one. Just use a single NuGet feed, just eliminates the issues. The problem is you have got operational overhead because you need someone to go in and curate that and make sure that the packages being pulled aren't malicious themselves. There is another, register the packages on NuGet, the prefix if you're going to use them. So if you're building internal packages, you can register the prefix without uploading your packages. It's just another way to protect yourself. I would avoid the package.lock JSON file. It just seems brittle. It causes a lot of overhead. And the NuGet's actually introduced something specifically for dependency confusion, and that's source pinning. So with source pinning, all you do is you get your feeds, so you can see those top two ones, and you can actually specify which feed to pull the packages from. So, yeah. Cool. That's all. Hope you enjoy it.
Thanks very much. Right, it's afternoon break time. We're running a little bit behind schedule, so we'll push the break out to, I don't know, maybe 4:20. So we'll see you back then. We are going to need you to clear the auditorium just because we have a little bit of setup to do for the next, last 3 set of talks. So go forth, fresh air, and see you back here at 4:20. All right, good afternoon, welcome back. Final segment of Kawaiicon 2. Now, our next speaker is actually one of my colleagues at CyberCX, and he runs our hardware hacking team. We're increasingly doing work where, with Internet of Things devices and embedded systems and SCADA and control systems, where the integration and the intersection between hardware, embedded operating system applications running on embedded systems is super important. And being able to explore and use those in a blended manner is increasingly important. So Ben's really, really passionate about this subject and really wants to help you all get into hacking hardware. So I hope you enjoy his talk. Please welcome Mr. Ben Knight.
Share middle. Hi, everyone. So as Middle said, I'm Ben, working at CyberCX. First of all, thanks for sticking around. I appreciate, it's day 2, it's the afternoon. By the way, did anyone notice the crazy, weird flashing light? Maybe there's something there, something to keep an eye on. Something to think about. So a lot of you may recognize it from the internet, from the IT crowd. So if there's anyone in the audience that doesn't recognize this, here's some context for you. So now I've got the internet, and as Metal said, I'm a hardware hacker, so what could go wrong? So Kiwicon 3 was the first security conference that I attended. It was also the same Kiwicon when this infamous poster came out. This poster is probably in a bunch of your offices, printed out somewhere. So I just want to say, I feel very privileged to get to speak to you all today. So I sat sort of security adjacent for a number of years in forensics roles, and I started working at Insomnia just over 5 years ago, now CyberCX. And also, as Metal introduced, I'm now kind of leading the hardware, IoT, embedded system side of our pen testing service. So I wanted to make just a small change to this infamous poster that's relevant to us here, talking about hardware. So, hackers going to hack, they're going to hack your hardware. So, why does hardware hacking matter? Well, hardware is your attack surface. Your hacker might be interested in extracting sensitive information off your device, or maybe they want to sort of leverage it to gain access to something that the device can do. But ultimately, hardware hacking is a means to opening up the black box, to understand how something works. To sort of, as a parallel example, like a web application, right? What is the attack surface of a web application? Well, it's the application. You talk to it on a network socket. You use some tools like Burp Suite or even your browser to find vulnerabilities in the application. But when it comes to hacking a device, that black box, the hardware is the thing that you're going to leverage to find some sweet vulnerabilities. So to paraphrase Joe Fitzpatrick, who for those in the audience that don't know, is a sort of well-known, well-respected hardware hacker. He says something along the lines of, today's hardware exploited issues are tomorrow's remote software vulnerabilities. It's that first step to really understand how something works and define those vulnerabilities. But as we've also seen, hardware attacks can be automated with jigs specific to a thing, or in the game industry we see a lot of mod chips that are able to replicate pretty advanced attacks. So things like the Nintendo Switch and the Xbox 360 both had sort of CPU glitch style attacks, and it's just a matter of soldering up some bits to the right board and off you go. So you might get lucky. Maybe you get a firmware update image you downloaded from the internet for the device you're looking at. But more often than not, it's encrypted, or even more often than not, they just don't provide that. So, you need to open up the device to get that visibility. So when you think of hardware hacking, you might think of something like this. So this is actually a photo I took just a few days ago of me trying to dump this Flash EEPROM from 1999. So I didn't have a socket that the chip would sit into, so I was kind of left to solder a bunch of magnet wire to all the pins, break it out to a breadboard, connect it to an Arduino. So, sometimes hardware hacking looks like this. It looks complicated. It's probably akin to, say, in Hollywood movies where they got the scrolling text, some program codes. It looks scary, it looks confusing, it looks intimidating. But what I want to show you here today is hardware hacking doesn't need to be scary and intimidating. It doesn't need to be full of wires. With the right tools, you can actually achieve quite a bit. And just understanding the different interfaces that you are potentially going to sort of find as you open something up. Also, you don't need to be an expert in electronics to do hardware hacking. I certainly am not. I just enjoy opening things and understanding how they work. So some of the tools that I'm going to use here today, and I am tempting the demo gods, so please send me your good vibes. So I'm going to use the TieGuard. Again, this was a device made by Joe Fitzpatrick, who I mentioned earlier. I call this a bit of a Swiss Army knife style device. So it has an FTDI chip in the heart of it. So it will connect to things like JTAG interfaces. JTAG is a sort of test and verify protocol for talking to components on your PCB. It can be used for like single-step CPU debugging. You could use it to dump memory. You could use it to dump flash chips. So the JTAG can be an avenue for you to get firmware off a device. Also, the TieGuard will talk to serial wire debug interfaces, which is essentially just a 2-pin version of JTAG. Well, it's JTAG on top, but it's the number of required pins has been shrunk down, and it's an ARM standard, so it's just a bidirectional I/O pin and a clock pin. So it's a little bit easier to discover if things aren't labeled, for example. And the last interface that we're going to look at is the UART serial, which it's typically designed for device to PC sort of serial communication. So if you're going to find things like debug messages or maybe shell access, if the embedded system you're looking at has command line access, you might find that through a UART interface, and that's just 2 pins, a transmit and a reset pin. So what devices may be alternatives to the TieGuard? So a lot of you probably recognize the Bus Pirate. It's very popular. In my opinion, it's just a little bit clunky to use. I feel like the TieGuard is a better hardware tool, and the JTagulator also a good tool in its own right. However, it is quite expensive. So I definitely recommend the TieGuard as a good sort of overall tool. So also, I highly, highly recommend, if you're going to be doing hardware hacking, is to save yourself a lot of pain. So jump on AliExpress and look for, say, like the TL866 or the ProMan Flash Reader Writer Programmer. These have extensive lists of chips that they support. And so, doing it manually, you pull the thing off, you figure out how the chip works, you read the data sheet, can be painstaking. And what you could often find is you plug it into one of these readers and it just works. So I highly recommend looking at some of these programmers. The other tool I'm going to show you today is probably my favorite hardware hacking tool, and it's actually a very simple idea. It's just a pogo pin on the end of a arm. So the arm is quite heavy. It sort of uses its weight to hold the pogo pin down on something you're trying to connect to. And then you can connect your wires up to your tool, like your TieGuard or whatever you're using. So this is a PCB byte that we're going to use. So this is where I'm tempting the demo gods a little bit, because as you can see in that picture, it's a pretty tight space. and you're all watching me, so it's potentially a bit unnerving. So we'll give it a go and see how we get on. So I'm going to use the PCB byte to talk to a couple of the serial pins on a microcontroller. I'm going to use the tie guard to do that. All right, so what I'm going to do now, if we can flick to just the camera, is I'm going to open up the internet and see what's inside. By the way, did anyone notice the flashing button? All right. It's very light, surprisingly, for the entire internet. All right, just 2 screws, just to make it a little bit easier. I wonder what's in the internet. Okay. We have a battery. Surprised the internet can run on such a small battery. We've got a battery, and we have this board. Also interesting. I'm not sure how easy it is to see on the video feed, but there's a strange number written here. But okay, so let's talk about this board. So often when you pull something apart, your first thought's going to be, well, what components do I have? How are they connected? Are there test pads that are broken out from? It could be useful. Are there ports that you connect cables into? So let's have a look at this board. So we've got a USB port. That's kind of interesting. We've got a microcontroller. It's, the guts of it. That's where the CPU is. We've got a flash EEPROM over here, and some, battery terminal, the LED. We've also got some, you can see the traces running from the microcontroller down to these pads here. So just in the interest of time and demoing for you all, I can tell you that these are breakouts for JTAG. So you could use the PCB byte to connect to the JTAG. Also on the back side, we've got, it's pretty simple, but a few more breakouts from the microcontroller. This is the serial Y debug. So we're not going to connect to either of those today, but we are going to connect to a non-broken out thing on the microcontroller, which is the UART serial. And then we've got the flash EEPROM here. So we're going to use the tie guard to dump the contents of the flash. One thing I want to point out to you, again, it might be a little bit hard to see on the video, but there's actually this USB connector's got 4 pins. You can actually see the 2 running along the bottom of the 2 data pins. They're actually missing resistors here. This is not an uncommon thing for vendors to do, to essentially disable interfaces. So rather than actually disable it or actually change, they just remove simple components from their production runs of boards. So that's something to keep an eye on. Just look at the traces, see how everything's connected, kind of piece it together in your head. So just head back over to here. You pull up the slides again, thank you. So probably one of the most important components we found when we opened it up was the microcontroller. So how do you identify what component you're looking at? Well, often you'll use something like a microscope or just zoom in on your phone and take a photo of the markings on the top. So we can see that this is a NXP LPC. If we Google for the data sheet, we can see it's the ARM Cortex M0, so pretty low power, low speed ARM processor. It's a 64 pins along the outside style footprint. It has outputs for JTAG, serial wire, UART. So when you're looking at UART serial, a recommendation I have for you is just be mindful that you're more likely to see messages through that interface at boot time. So if you're probing around a bunch of pins and trying to connect a serial adapter, and I just recommend just each time you go to somewhere else, go back, reboot the device, because you don't want to accidentally connect to the right pin and not see anything because it finished its boot process. So we've pulled up the data sheet for this microcontroller, and I've just highlighted the pins that are actually interesting to us as the hacker. You know, we want to look for JTAG, serial wire, etc. So yeah, we're going to look at these two blue ones, and yeah, just emphasizing that these are very small, and the PCB byte is a fantastic job at getting into these small spaces. The other component that is really interesting to us as a hacker is the flash EEPROM. So again, we took a photo of the top, we looked at the markings, and we can see that it's a microchip. So it's a flash EEPROM, it's I2C serial EEPROM. So I2C is a kind of serial communication bus. So it's used for intra-board moving of data, so components to components serial communication. So you can have a number of devices sharing the same bus, like maybe the microcontroller needs some data from a flash, or maybe there's a sensor or some other component. Another serial intra-board style protocol you might see when hardware hacking is SPI. Same deal again. So we are going to use the TieGuard to dump this. So just to sort of sum up what we found when we opened up the internet, there's the microcontroller sitting there in the middle. There's a couple inputs to the battery LED, not particularly interesting. We found that there was a breakout for JTAG and serial Y debug. We noticed there's a USB port that's got some components missing. Again, in the interest of time, I'm not going to look at the USB, but just so you're aware that that's something that does happen, removing components. Down the bottom there is the kind of battery management chip for because you can charge the battery through the USB. So as a hacker, we don't really care about that. That's just power stuff. We want to look for data. So yeah, we're going to look at the microcontroller and look at the flash. Cool. So if we go back to the camera, I'll just bring up my terminal. So the first thing I'm going to do is dump the flash. So now it's time to say a prayer to the demo gods, I guess. So what I'm going to use is I'm going to use this test clip. So essentially it clips on top of the flash chip, but it can be a little bit tricky to get on. So looking at the TieGuard, just a bit of a trick. So I'm going to power the chip in circuit, meaning I'm going to power it normally like it is now, and I'm going to set the TieGuard to just voltage target mode, which means don't provide any power on the VCC line. And a reason why that can be quite handy is because the LED pops up showing, yep, there's voltage on that line when it's successfully connected, because, like I said, it can be a little bit tricky. So what I'm going to do is I'm going to turn off the internet. Sorry if your phone loses connection. I'm going to, actually before I do that, so the PCB byte comes with these really nice kind of leg holder devices. So I'm just going to set it up just so there's a bit less likelihood that if I do something a little bit, loses connection or whatever. So get that in place. All right, can you see that okay? Cool, that looks good. So I'm going to try and get this clip in place. Just move these screws out of the way. So pin 1 is indicated as the highlighted pin here, and I'm going to connect it to pin 1 on the chip, and then we'll see if it connects. This is probably a good time to play cricket.wav as I try and get this on. Okay. The LED didn't pop up. It's on, but the LED didn't pop up, so that's why I feel like that's quite a good trick. Aha, the LED popped up that time. Fingers crossed, everyone. All right, so first we are going to scan the serial bus to see if it can find the I2C device, which it didn't. So we'll have to do it again. All right, let's try again. Okay, doesn't want to work. So what I'll do is I'll just show you the video of it working. So there's nothing else. How hard can it be? All right. So we scan the I2C serial bus, and magically it works when you play the video. And so we can see it's detected the device at address 55. So, oh, there we go, it popped off. So, so I'm going to use the PyFTDI library, which allows you to talk I2C with an FTDI chip, which is the one on the TieGuard. Going to tell it we're using the TieGuard, what the address of our I2C device is. A little bit details about our device, the Indianness of the bytes, also the length of our address. And we can see that it has pulled off 10 bytes from the start of the chip, and looks like there's some data there, so it's a good sign. So just going to write it to a file and see what the file might be. So, oh, it's a compressed bzip2 compressed file, so just unpack that. All right, there must have been some zeros at the end of the file, which is why it said something about garbage and EOF ignored. Let's have a look at what's output. Okay, it's an HTML file. Let's blindly open that in a browser without seeing what's inside, right? All right. Oop. Oh, of course. I would expect nothing less than from the elders of the internet to rickroll us. All right. So the other demo I want to show you is the PCB byte. So let's see if we have a little bit more luck with that one. So this is a little bit simpler, but also requires a bit of trickiness. So I'm going to make a few changes to the TieGuard. So I'm going to remove the clip. That didn't work. And I'm going to, so where before we had the TieGuard set up to not provide any voltage over VCC, I'm now going to set it to 3.3 volts. And I'm going to attach the wiring harness for the JTAG interface. So we'll just connect that up here. Make sure it's the right way around. Shifts that way. All right, so I'm only going to connect 2 pins here. We need to ground the TieGuard with our board. So we're going to connect to ground point. So looking at the breakouts here from the microcontroller, we know that this pad here is a ground point. So I'm just going to use that because it's quite easy to connect to with the PCB byte, can just sit on top. The second connection is a little bit harder because it's the one on the side of the microcontroller, and that's the TX, so the transmit pin for the serial from the microcontroller, is going to go into the receive pin on our TieGuard. So I'll just connect that up now. So first we've got our ground. So these PCB byte arms here just sort of clip in like that. And then it's magnetic and it just clips on there. So this one can just happily sit on top there. So just while I'm doing this, I'm going to kill its power. So then we're going to connect our receive line to this one. All right. And much like the test clip, this is requires small, and you'd probably do it under a microscope and not with, house lights blinding you, but let's give it a crack. All right, move my hand out slowly. So what I'll do is I'll just get I'm just going to use Picocom to talk serial at this end. I already know the baud rate, so let's get that on and let's see if I got it in the right place. Oh, it's an ARPANET terminal, very old. Oh, anyone recognize that early malware? Oh, of course. Again, they've rickrolled us. I'm starting to think that the elders of the internet might be mega trolls. So, to wrap up, hardware is a fantastic attack surface. It allows you to open up the black box, understand it, get the firmware out, which then ultimately allows you to find those sweet software level vulnerabilities. Hardware hacking doesn't need to be intimidating. I've been able to connect these things, well, one of them, in the time I was talking to you here. It's probably one of the worst environments to try and do hardware hacking. The PCB byte, as long as it sits in the right place, it just works. It allows you to iterate fast. You're looking around the board, you think, oh, there's a bunch of pins here, maybe this is this, maybe this is that. You connect up the PCB byte or a test clip or something. You use something versatile like a tie guard, and that means, if it didn't go right, that's fine, just move on to something else. The alternative, what would have been the alternative? It would have been maybe solder some magnet wire onto the chip. By doing that, maybe you create a short somewhere, maybe a pin comes off, maybe it gets a bit too hot or whatever, and that iteration's much harder because, you've spent all that time and effort, you've got it working, oh no, it wasn't the right pin, I didn't understand I didn't have the data sheet, so I'm sort of guessing as to what pins I think are what. And just when it comes to hardware hacking, understand the interfaces, like JTAG, serial wire, UART, understand the protocols, like the serial protocols that are used on the board for the chips to talk to each other. Consider using a logic analyzer or an oscilloscope to try and troubleshoot. What am I looking at? Understand that kind of stuff. So, if you're interested in hardware hacking, but maybe you haven't taken the plunge of actually pulling something apart, I recommend look inside your cupboard. I'm sure you have a box of old cables and tech stuff. Find your old router, open it up, get a serial connector. Just start looking around. Also, did anyone figure out the flashing pattern on the front? Please, maybe send me a message on Twitter. My handle's there if you figured out what it is. Also, if you are interested in hardware hacking, interested in electronics, maybe you're doing an electrical engineering degree, or just interested in hardware in general, maybe you don't have to have hacking experience, please come and talk to me about working. CyberCX is hiring. And I want to continue to grow this service, bigger and better at pen testing hardware. And that's me. Thank you very much.
Thanks very much, Ben. You're a brave man, doing the tiny, tiny things live on stage.
Turn it off.
Yeah, turn off the internet. That's an excellent choice. Excellent choice. And thank you, Ben, also for activating the brand, so I didn't have to. That's good work. Right, let's move on to our next speaker. This is his first Kawaiicon, first KiwiCon, first Kawaiicon, fresh into the country. So we're going to have to show him how we do it around here. So we have a big welcome to Mr. Steve Esler.
Kia ora. Hi, I'm Steve. A little bit about myself, because I don't like to talk too much about myself, but I'm from the UK. I am 10 years a developer. In the last 5 years, I've swapped over to doing application security, and I like it. So I'm here today to talk to you about application security and cheese. So first off, a quick apology. There was meant to be some cheese boards going around the auditorium, but I spent all my money, or all the marketing budget, on fancy graphics, as you'll see. Oh, this is just gonna play ball. There we go. So yeah, you're probably wondering what application security has to do with cheese. Take meltdown. That's not. So we had a brief mention of Swiss cheese model from Peter Gutman first thing this morning. So I'm going to delve a little bit deeper into what it is and how we can apply it to application security. So just a quick brief of what I'm going to talk about. So I'm going to talk about what the Swiss cheese model is. I'm going to cover some examples of where it's been applied, how we can relate it to application security, what good looks like in terms of our cheese board for application security, and how things can still go wrong and what can be done to prevent them. So first off, I'm going to explain a little bit about high level of the model and what it's been used for. So in 1990, Professor James Reason came up with this Swiss cheese model of accident causation to explain how accidents can occur in complex systems, such as those he first studied in healthcare environments. As with many complex systems, medical systems require some human input, and along with that human input comes inevitable human errors as well. So Reason saw that errors should be seen as a failure of the system rather than the result of one human's actions in the system. So these system errors can be prevented, as you'll see on the screen there, by a series of defenses, barriers, and safeguards. These are the slices of cheese. Defenses are based on the assumption that we cannot change the human condition, but we can change the conditions in which humans work under. In an ideal world, each one of these defensive layers would be impenetrable, but in the real world, they aren't. So Reason likened each one of those to a slice of Swiss cheese. It has holes in it. If an error occurs and gets through one hole in the slice of cheese, then it won't be a big problem, as the next slice will catch it. However, sometimes the holes can align and cause losses in the system, or in the case of a healthcare system, harm to the patient. So as well as being used in medicine, it's been used to explain and investigate aviation accidents, such as the Challenger space shuttle disaster, and industrial accidents such as the Bhopal chemical disaster in India and the Chernobyl nuclear disaster. The post-analysis of these virtually always reveals that the root cause was a failure of multiple layers in the systems of defenses. So what can cause the holes in the cheese? What can cause those to widen, to move around? So there's two things, active failures and latent conditions. So active failures are unsafe acts committed by people who are in direct contact with the system. Slips, so these are broken down into these four different parts. So slips, this is where the correct plan is made, but is incorrectly executed. So this is perhaps where you meant to drop the kids off at school, but went to autopilot and took the route to work instead. Lapses, where you forget to do a step of the plan. So your home insurance perhaps becomes inactive because you failed to pay the bill. Mistakes, so these are misinterpretations of relevant rules. So you interpreted your flight check-in time as 9 a.m., but arrived late. Could be violations, and this is where a person knows the rules, but doesn't follow them. Not intentionally to cause harm, but perhaps to save time or complete a priority task. So an example of this is at Chernobyl, the operators wrongly violated plant procedures and switched off successive safety systems, causing the initial trigger for the accident. So the other part of it is latent conditions. So these latent conditions arise from decisions made by designers, builders, procedure writers, and top-level management. They have two adverse effects. That is, they can create error conditions in the local workplace. So this could be from things like time pressures, so perhaps wanting to complete features and not fix vulnerabilities, understaffing, poor supervision, or poor communications. On the other side, there's creating the latent conditions can create long-standing holes in the system. So this could be deficiencies in the design or construction, ineffective equipment, unworkable procedures, and untrustworthy alarms and indicators. That last one reminds me of the first trial flying lesson that I took. And as we're sat on the runway and the pilot's taking off, we just start to take off, and this alarm starts going. And I look puzzled at the pilot, thinking, "Oh, what's going on here? Is that normal?" And they say to me, "Don't worry, that's our stall warning indicator. And a stall is where you don't have enough speed, enough lift to keep going up. You'll start going down." She says, "That's perfectly normal on this type of aircraft. We just ignore that alarm." That filled me full of a lot of confidence. The latent conditions, as perhaps the name suggests, these lie dormant in the system until they combine with one of those active failures to create an opportunity for an error to occur. So unlike active failures, which can be hard to foresee, this dormancy allows us an opportunity to spot them and try and remove them. So back to COVID, that's been mentioned a few times today. It's a good example, and this is one place where the Swiss cheese models have been applied to. So as we all love and know and love, we've got these multiple layers built into the defenses against COVID. So things like mask wearing, hand washing, testing, and vaccines. So what sort of things could cause potential active failures? People forget their masks, perhaps leaving them at home. Like that would be an example of a lapse that makes that part of the defense ineffective. But then we've got other layers in the defense that'll help us with that. Some possible examples of latent conditions in here that could affect the defenses. So people not knowing to wash their hands effectively. So perhaps inadequate guidance around that. I know in the UK, they got you to sing happy birthday whilst you were washing your hands, so you did it for at least 30 seconds. Or perhaps it could be poor communications around the different COVID level rules. And obviously that's something that here in New Zealand, we got really right, which is great. That's just one example of how the Swiss cheese model's been used recently. So next I'm going to start to apply the Swiss cheese model to AppSec. So my first question when I was looking for a topic to talk about was, could we apply the Swiss cheese model to AppSec? Well, it's been applied in other areas of cybersecurity, so I thought it probably could, and I hope so, otherwise this would be a really short presentation. With the Swiss cheese model, Reason was trying to move people's thinking from treating mistakes as individual errors by bad people to a systems approach that accepts humans are fallible and mistakes are to be expected. Well, in application development, it's a human designing the application, it's a developer coding it, it's someone configuring the infrastructure for the application to run on, and each one of those things are prone to a person making mistakes. And in cybersecurity, you also have the long-standing concept of defense in depth, which the Swiss cheese model talks to. So how can we apply the Swiss cheese model to AppSec, and what would we be looking to achieve with our cheese slices? So for me, as you can see from the diagram, it's around reducing the risk of vulnerabilities or security flaws being introduced into that application or system under development. Why do we want to remove those risks? Well, reducing those risks reduces the chance of those vulnerabilities being present in the production application for an attacker to then actively exploit, leading to a security incident that compromises your assets and causes losses. So what are those risks in an application security context that we're looking to reduce, and what human factors play a part in them? So there's a risk that someone creates a security flaw in the design or architecture in the system. So this would be considered a latent condition, a flaw in the design, opening up a hole in that slice of cheese. Another risk is that we accidentally introduce a security issue or vulnerability into the code that we write. So this could be down to an active failure, perhaps a lapse by a developer forgetting to use an input sanitization function, or forgetting to remove a hard-coded API key. Or it could be a violation. A developer knew he needed to introduce a bit more, they needed to introduce a bit more code into the function to secure it, but they were under time pressure, so they didn't, which perhaps also talks to some of the latent conditions around those time pressures. Another risk is that we bring in a supply chain-based vulnerability. We've talked about a few of those things in the presentations today and yesterday. This could be a slip by a developer forgetting to upgrade to the latest version of a dependency, leading to an older version being used which perhaps has vulnerabilities in it. It could be that you've selected an open source project that does what it needs you to do, needs the system to do from a functionality point of view, but isn't that well maintained and doesn't get security fixes in a timely manner. For me, that's probably like a latent condition, the equivalent of choosing poor equipment in the system. There's a risk that you inadvertently put a security issue or vulnerability into infrastructure setup and configuration. So that could be applied to traditional like on-prem infrastructure or infrastructure as code. So in the infrastructure as code world, perhaps the configurers lapsed and accidentally set up an S3 bucket as public when you meant to set it to private. Or perhaps a violation, so not following the correct procedure and removing unused ports or services before the application goes to production, and that leads to one being left open, which is vulnerable. And then finally, we've got a risk of somebody maliciously introducing a security issue. So this could be, your malicious insider. It could also potentially be an attacker that's already got inside your network. For me, this probably fits into a violation under sort of the model, but with an intent to cause harm. And that talks to, as well, I think, the latent conditions around what led to that person wanting to maliciously introduce a security issue. So what does the landscape look like in applications and systems development? So in the top in orange there, we've got the typical waterfall, kind of longer kind of development process, longer iterations with the different phases. And then in the blue there, we've got the more modern kind of CI/CD world, where the goal is to release features to the customer faster and more frequently in smaller iterations than waterfall. So we've got that continuous integration loop where we've got coding, building, testing. If the test finds functional issues, then you code again, you build again, you test it again. And then once you're ready to go to release, once your builds succeed, then you go towards releasing, deploying that, and then once it's released, operating and monitoring that. And each one of those stages gives us opportunities to introduce defenses, those slices of cheese to try and mitigate or reduce these risks. This is the first really expensive graphic that cost us a lot to make. So I would say, though, it's still cheaper than buying a block of actual cheese in New Zealand. So this is quite a busy slide. So I'm going to talk you through a couple of scenarios for this one. So I'm going to use the laser as well. There you go, look at that. So we've got two arrows here. We've got the top arrow and the bottom arrow. So those are two scenarios that I'm going to walk you through. So the top arrow is where a developer has used a JavaScript eval function, which is the root of a lot of evil in JavaScript. It's a horrible thing. You shouldn't be using it. Perhaps they lapsed and they forgot to read your coding standards guide, where on page 70 out of 100, it told you you're really not meant to use that particular function. So we've got two layers of cheese there that could help prevent that sort of vulnerability. The first two, though, they're more aimed at preventing design flaws creeping into the system. So threat modeling, we saw a really good presentation earlier that discussed what threat modeling is. I'm a really big advocate of it. I think it's really effective in working with the team, helping train the team up as well, and finding the possible threats to that system while it's still under design. But in this case, yeah, it's not meant to prevent sort of those coding errors. So it goes through that slice of cheese. The next one we've got there is design reviews. So this is where a security expert typically, takes a step back and a look at the design of the system and looks at any potential for design flaws in that. So again, it's not the right tool for the job in this case. But the first thing that will help us in this situation is our SAST. And so that's static application security testing. So that's white box with access to the source code. You've got a scanner that's going through your code and checking for these sorts of vulnerabilities. It's done, this is the kind of the earliest point to do it, which is still when you're writing code before you've committed that code. So this is where it's done in your integrated development environment. So doing it early, so that whole shift left mentality, the earlier we do it, then the more effect we get out of it and the cheaper it is to fix and spot those flaws. So in this case, we ran that tool, it found that JavaScript eval function, it flagged it up to the developer, and then the developer, before he's committed the code, can go and fix that. So that's a win, that's great. This second one is, going to use a little bit of an edge case here, because I totally agree with what Tim said yesterday, which is a lot of modern frameworks help prevent this sort of thing, which is that the developer has been tasked to write a piece of functionality to enable rich text areas in the system. So this is where they're going to be looking to have like tags in your text areas on the page, so like a text editor. And in order to do that, they need to change the rule set that would ordinarily prevent those kind of potential sort of script injection points for things like injecting malicious SQL or XSS data. And in this case, they need to kind of loosen they need to create an allow list rather to allow certain of these tags through. So again, like before, threat modeling and design reviews, as this is a risk that we're introducing a vulnerability into the code, don't really help us here. But the first thing that it will hit is, again, that static application security testing. Well, in this case, typically these tools don't look that deep into the config of how you've configured that sort of validation, that input validation. They just really check they're there. So in this case, it's not been that effective. The next slice of cheese we've got is secret scanning. And so secret scanning, perhaps using a tool like TruffleHog that Dylan spoke about yesterday. Great tool for checking for secrets. So things like hard-coded API keys, SSH keys, that sort of thing. But again, it's not the right tool for the job to spot this error, this vulnerability that's been put accidentally into the code. We've got code reviews next. So this is where you've got eyes on other colleagues of yours, doing a peer review of your code. And yeah, another great opportunity to spot this sort of vulnerability. But it takes a lot of training. It's quite a specialist sort of subject to find, these sort of code flaws. And so perhaps in this case, that team didn't have that sort of training. They were just looking more for those functional errors rather than security errors. So it goes through that slice of cheese. Now we've got the SAS tool running again, but we know that wasn't effective in the first place. So this is where it's running in a build pipeline. So it's running automated, and then it's returning you a result, just like with features, where you get errors with features. It'll stop your pipeline and cause you to down tools, fix that, and away we go. But in this case, it doesn't work. The other thing that we can do at this point, again, run it as an automated tool, is that software composition analysis. So this is really good for catching those dependencies that have pre-existing vulnerabilities, and again, breaking your build so that you can fix those, perhaps update them. Container and image scanning, again, not quite the right tool for the job. So this is really good at spotting those infrastructure misconfigurations in your infrastructure as code. This is really good at spotting where your containers have been misconfigured and allowing you, again, to change that configuration. And then you've got policy as code. So policy as code is really good at spotting those misconfigurations in your infrastructure as code. And yeah, again, getting the team to fix them. So what does catch this particular vulnerability is your DAST, which is your dynamic application security testing. So this is where you've got a tool, perhaps like the OWASP app, that's working like a hacker would, so attacking the application like a hacker would, where it's running, and one of the things it does is it fuzzes the inputs. We had to talk about fuzzing earlier, so it fuzzes the inputs. And this sort of thing would find that sort of vulnerability. So this is going to perhaps spot where that allow list for the tags for this rich text area was just a little bit too wide, too permissive, and it stops it. So it's gone through quite a few layers of cheese. Ideally, we want to catch that earlier, but we have eventually caught it, which is great. I'm going to just briefly talk about some of the other parts in there. So we've got signing, which is where you're assigning the container image or your exe of your application. And this is quite good at spotting where potentially like an attacker or a malicious insider has swapped out your container or your exe for one that has malicious software in it, malicious code in it rather. We've got the network and container scan, so we can run container scanning again just before we release and deploy that. It's cheap, relatively cheap to run, so it's a good point to run it. We've also got the network scanning there, so this is using a tool perhaps like Nessus to check the infrastructure setup, again as an attacker would. Black box this time, and finding those flaws perhaps in the infrastructure setup. The next one along is pen testing, and this would have been a backstop if that DAST hadn't caught that issue in the code. This is another point where we've got those multiple layers of cheese. This one would have caught that. So that's where you've got skilled security professionals attacking the application again as an attacker would and finding these sorts of flaws. Next one along is you've got vulnerability management. So this again is around your software composition analysis, but this is more looking at your operating system, making sure that's being patched and kept up to date, and perhaps some of the components that make up that operating system as well. And then last but not least, we've got compliance checks. So this is something like the AWS ECR, for instance, running on a continual basis, as with the vulnerability management before, and checking to ensure that your infrastructure setup meets best security practices. And so one of the things that this could be used for as a model is for blameless postmortems. So again, the focus here, when you look at perhaps an incident like that bottom arrow is why didn't our defenses catch those vulnerabilities rather than, why did that developer put that, use that particular dangerous function in the first place, or why did they, allow too permissive allow list? So that's probably a really good use for this sort of model. So we've done all that. We've got all those slices of cheese in place. What can still go wrong and how can we prevent that? So one of the things is not considering security early or on changes in the design. So this is perhaps not threat modeling early or conducting system design, security design reviews early, meaning that one of those security deficiencies creeps in early in the design phase. And it's, as I mentioned before, it's also there where you get really most benefit from shifting left, so you're not ending up having to redesign a system because you found that security flaw too late. And then the next one is not considering security on changes, perhaps in your stories. And one of the things I've seen here work quite well is security guardrails, which is where you have a set of questions the team can ask themselves when they're refining those stories. So it could be things like, does this change affect effective access permissions? Or is it likely to change the threat model? Or does it introduce another attack surface? And so if so, consult with a security specialist. The other thing that I've seen in practice is setting the thresholds for the scanning tools too high. So this is where perhaps the focus has been on just criticals and highs and you're not looking at the mediums. And as we know, quite often those mediums can be chained together and be the equivalent of a more serious vulnerability. So make sure you're setting those thresholds. Similarly, keep the policies for that, the policy as code checks and the compliance checks up to date. And also here, there's that need, as with any security tooling, the SAS tools, the DAST tools, the SCA, they will find false positives. So they do need some investment in terms of tuning those scanning tools to remove those false positives. Lack of supervision and guidance for the practice-based activities. So some of the activities like threat modeling, they do require quite a bit of training in those procedures like STRIDE. And it's also something that's a practice rather than a tool, so you can't really automate it. And so it's easy to forget to do. So perhaps having that as one of the must-haves that you need to do before you're allowed to input code into production will help try and prevent that. Because if the team knows it's a precondition for going live, then it'll benefit the team to get it done early to prevent delays in going live. Training there, also plays a big part in getting the most out of those security code reviews that I mentioned. Next up, we've got a reliance on humans to fix the vulnerabilities. So those humans are going to be subject to those time pressures to deliver functionality. And that might mean that those security fixes get rushed or completely missed, which we've all seen in practice, no doubt. So my suggestion here is tracking the work for those fixes, just as you would, a piece of functionality or a fix to a piece of functionality that was broken, and give it that visibility. Flag those stories as security specific or having an impact on security, so the trends in time to close them can be spotted. And tooling can help out here often. Some of the scanning tools, provide those sorts of metrics as well. And the point here is that if you spot those trends, don't punish those teams. They're probably the ones that need some help. Maybe they're struggling on the best way to fix those vulnerabilities. So get a security specialist in and help them fix those. So the lack of skilled security specialists. This is one of those latent conditions, not having adequate staffing. Here's somewhere where security champions programs can really help here. So this is getting volunteers from within the organization, from different roles, to be trained up in security and to be the local focus for security, and someone who's got enough knowledge, to help hopefully on the spot, but if not, engage with the security specialists, security engineers, InfoSec consultants, and where needed. So we're kind of making the best use of their time as well. And the last one here is not doing software composition analysis as part of ongoing vulnerability monitoring and management. So some projects might still have quite long-winded development phases and not have regular releases. But as with patching the operating system, we need to monitor that the dependencies used in our applications, over time, they would have had vulnerabilities found in them, so we need to keep them up to date and perhaps re-release the application to include those security fixes. A few ways around that, you might want to just continually run the pipeline, anyway, even if you're not deploying to live, so you catch those you can run those automated tools on a regular basis. So in summary, we looked at the Swiss cheese model. We related it to application security, looking at the active failures and some of the latent conditions that might cause the holes in the cheese. So the takeaway really here is that you can't change the human condition, but you can change the conditions that humans work under. So have those scanning tools to support the humans and spotting those potential vulnerabilities and allowing the team to fix them. Take the time to set those tools up and tune them so that they're effective. And then with the latent conditions, those design flaws, support the developers with training and guidance to close up those holes, give them that guidance and training to be able to do threat modeling well, and spot those design flaws early. So a couple of thank yous. Thank you for Kawaiicon for allowing me to talk at this conference. Thank you to Teo for giving me the original inspiration for this talk. And thank you to Jeremy Stott for being my rubber ducky on this one. So thanks a lot. That's me.
Oops, crickets.wav time again, running late. Thank you very much. All right, we're going to head onwards to the final talk of the day. And some of you may have been admiring the fine piece of machinery on the stage. How many of you have been eyeing that up? A few? Yeah. Do you want to hear it? Yeah, that's what I thought, right? So, it's my great pleasure to introduce probably the best-dressed hacker. He's certainly been consistently voted best-dressed hacker at previous KiwiCons, and we'll leave it to you to judge, but hailing from Pulse Security, Mr. DOI.
Thank you, Neil. Okay, we should hopefully have... yeah, okay, awesome, it works. Right, Prezo time. Okay, I'm going to be talking to you about reverse engineering this Ducati. For those of you that don't know who I am, my name is Dennis, and I'm a security consultant with Pulse Security. We do things like pen testing and attacker emulation, security research, forensic analysis, that kind of stuff. And I'm kind of like a offensive security jack of all trades, really. You might remember me from previous Kawaiicon and KiwiCon talks. This was KiwiCon 7, I think, 2013. And we were talking about enterprise software security vulnerabilities. This talk is not about enterprise software. This talk is about automotive junk. And specifically, what I want to do with this automotive junk is I want to be able to go and tune the engine so I can go and change some of the parameters of how the bike runs. And on most modern vehicles, that means dealing with electronic fuel injection. Now, electronic fuel injection is basically a tiny computer that goes and figures out how long to hold fuel injectors on for and when to fire the spark plugs. This is like the basic building blocks of what you need to make an engine go. But it is a tiny computer, so all the standard tiny computer shit still applies. And there's a bunch of other tiny computers on this motorcycle, and if you just go and swap out the factory ECU, which you can see on the left there, with an aftermarket unit like the Max ECU Street that is on the right, everything else stops working. And now, I didn't want to go and replace the dashboard and the ABS module and all that kind of stuff to make it work. I wanted the factory systems to be able to work with my new aftermarket ECU, but to do that, I had to figure out how to control them. And that's really what this talk is about, I think. This talk is about control. And look, we're going to be talking about embedded firmware reverse engineering, and we're going to be talking about CAN bus protocol reverse engineering. And we're doing so under the guise of tuning internal combustion stuff, but this isn't limited to only internal combustion stuff. Anything that implements these protocols, the same techniques that we're about to cover are going to apply. So this means EVs, industrial control, whatever. Quick disclaimer before we get started though, working on vehicles can be dangerous. You can be a danger to yourself and others. So if you don't know what you're doing and you can't go and play with this stuff safely, then please do go and upskill yourself so you don't die, basically. So here's the plan for the talk, right? First, we're going to look at the wiring diagram, and this is going to give us some key input about some other stuff later on. We're then going to reverse the factory CAN bus protocol that runs the dashboard. After that, we'll do some reverse engineering of the stock ECU firmware to find some fuel maps and some ignition maps to give us a head start, and we will wrap this all up with a bonus round if there is time. So I appreciate that this is the last talk of the day at the end of a hacker conference, and you're all probably lightly toasted from information overload right now. So I'm going to be glossing over a lot of stuff. Now, if you find yourself wanting to get really stuck into the nitty-gritty and have all the specific technical details and all that kind of stuff, then I've written up both the CAN bus reverse engineering and the firmware reverse engineering up on the Pulse Security website. There, they go into depth. If you want like nitty-gritty information overload, have at it. So wiring diagram, it looks like this. Fun fact, it's wrong. But it's not, it's not entirely wrong. The wiring diagram is something that Ducati at least are still providing through their owner's manual. So this isn't like a privileged piece of information or part of the workshop manual or anything like that. This is just what you get in the owner's handbook. And the plan here is to go and figure out where each sensor and each switch goes to. So there are 3 microcontrollers on this bike. There's the dashboard on the left-hand side there. There is the ECU, which is that bottom row of pins, and then there is the ABS module. So we want to figure out where each sensor and each switch goes. It ends up looking like this after you go and figure everything out, and eventually you get a list. And this is a list of what handles what sensor and what switch. And now this is important because it gives us an idea of what we should be looking for on the CAN bus before we ever put any tools on the motorcycle, or even purchase the motorcycle, for example, right? So here's a practical example of that, right? The neutral light is on the dashboard, but the neutral switch is handled by the ECU. So the ECU needs to have some way of reading that switch and then going and communicating the information to the dashboard about whether or not the bike is currently in neutral. And it works the same the other way, right? The immobilizer antenna goes to the dashboard, but the starter relay and the starter button go to the ECU. So the dash needs to have some way of handling the immobilizer logic and then going and communicating that state back to the ECU. So no tools have been involved yet, and we kind of already have an idea of the sort of information that we're going to be looking for on the CAN bus. So CAN bus 101, we could talk about bit timings and how this worked. It doesn't matter. It doesn't really matter for what we're doing here. What you need to know about the CAN bus is that it is a bus, so everything that is wired into the same physical 2 wires will be able to see every message that is transmitted on the bus. And it generally consists of a message identifier, in this case 100, and then a bunch of data bytes. So these data bytes are what we need to figure out because they contain the information that will drive the dashboard or the ECU or whatever. We need to reverse engineer that so we can re-implement it in the new shiny. So let's just do that. I want to show you how to do that. Provided I can remember how to drive Linux, maybe. Mirror. Okay, hopefully you can all see that. These extend and mirror scripts, by the way, I did not come up with that. That is 100% Michael Fincham. Correct response, yes. Actually got AV on Linux working. Anyway, looking at the wiring diagram, we understand that the dashboard and the CAN bus and the ECU live on the CAN bus, and the diagnostic connector underneath the seat also lives on the CAN bus. So I'm going to plug something into that that'll let me talk to it via my laptop, right? And what I've got here is a 8 devices USB to CAN interface, which goes to ODB2, which goes to an adapter, which goes to the Ducati diagnostic connector. So we're going to plug that in and have a little bit of a play. Okay. So I will remove the seat, if I can remember how to. There we go. And I will not scratch my sweet paintwork. Careful, careful. Okay. I'm going to pop off the clip that I'm going to put in my back pocket and remember that I put it there. And then we will plug in our CAN bus interface. Thusly, okay, we now have access to the CAN bus, maybe. So the cool thing about socket CAN and modern CAN bus interfaces is they turn up as an interface in Linux. So we have this CAN 0 interface here, which means that all the standard Linux kernel networking junk is what we can use to go and inspect the CAN bus and figure out what's going on. So that means Wireshark, TCP dump, all that sort of stuff works with CAN bus. You need to enable it first, which is this command. Okay. It's up. There should be a blinky light somewhere, probably. All right, and now what we're going to do is we're going to use the CAN sniffer command. And this is part of the socket CAN utils package. Again, this is super easy. It's in the Debian package repositories. It's in the Ubuntu package repositories. You don't need to compile anything. Just apt-get, install it, and it works. So we go CAN sniffer, and we pass our CAN bus interface. And this is what we get. Now, I am going to take my key. I'm going to plug this in. I'm going to have a look. We get some stuff, right? So now we have these message identifiers and these data bytes. And the cool thing about CAN sniffer is it shows you stuff that changes, right? So if I roll the throttle back and forth, thusly, right, you can see that we have a throttle position. If I grab the front brakes, nothing really happens. If I grab the clutch, right, we see some bits changing, right? If we pull the pass light, we have a small pulse that comes through, which is fantastic. We can use that for a nitrous solenoid if we need to. And that's basically the process. You just go have a play and figure out what works. We can start the bike. And now what we're looking for is RPM. And that's a message 100. Like, do you see it? Do you see it there? Right? So we want to use the bike in these different conditions and get a packet log. I'm doing this with CAN sniffer now because it's easy. But if you run CAN log or TCP dump, you can actually log all these packets, do that while you're actually going and using the bike, and you can get a packet capture that you can use standard PCAP analysis tools and start reverse engineering and figure out what's going on. Now, our mission here is to figure out what data frames the ECU is sending, so we can go and replicate those in the new ECU. And the best way to figure that out is through the process of elimination. So what I'm going to do is I'm going to yank out the ECU fuse, which is this bottom one here. I'm going to put that in my back pocket too and not forget that it's there. Okay. And now we can run the same thing, CAN sniffer. In reality, you'd be using CAN log, but same but different. Right? I don't hear the fuel pump prime, which is good. That means the ECU is off. And now we have these message identifiers. And that's really handy, right? Because now we can go and diff our previous PCAP, and we know what messages are being sent by the ECU, and we know what messages they're responsible for, and these are the ones that we really need to understand. Now, there's a few other tricks that you can use. If I go back to my demo cheat sheet here, right? So you can use CANgen to actually transmit data on the CAN bus. So here, I am going and sending ID 100 with this set of data bytes. And what I'm doing is I'm looking at the dashboard while I'm doing that. Right now it has a check engine light on and it's throwing a CAN bus error. If I run this command, check engine light goes off and something happens. The neutral light has come on. I am registering some kind of RPM, and I am seeing 0 kilometers an hour. So we pick some of these data bytes, like 04 DC, which from the CAN sniffer we suspect is the RPM, and we change that to like 09 DC and take a look. More RPM. Great. Zero FDC, yeah, even more RPM, perfect. So the other thing that you can do here is like we have a really incomplete run file and we don't know all the things that this message ID is responsible for. So if we go and remove the data bytes, like so, it'll just send random data. It'll just send random frames. So the trick here is to set this up and pay attention to what starts going bananas. So we run it. And now we can see, so the dashboard has gone into all dashes, which is like, it means it's going faster than 290 kilometers an hour. We control RPM. We control the shift light in different states. We control the ABS light. Headlight flickering, okay? We have a headlight kill there. Fantastic. So just by being a nuisance, you can go and start to figure out what these messages really do. And if you don't have complete packet captures, that's a really, really handy tool to have in the toolkit. So we'll extend this back out. I will go turn this guy off. Okay. Whoop. Let me find the slide. All right, so if you do all this stuff, you end up with an inventory that looks like this. Like, I'm kind of being flippant about all of it, but really you should go through this methodically for every single message with a log file, and then you figure that out. And if you're worried that the CAN bus message might trigger something that you don't want to happen, then you don't fuzz it, so on and so forth, right? After you go through that methodical process that I'm just going to like hand wave away, you end up with a spec that looks something like this. So message ID 100 is responsible for the gear and the vehicle speed, RPM, and then a bunch of bit flags for the various things that we saw happening on the motorcycle. 211 is auxiliary data that we want to go and display back to the rider via the dashboard. And then we have these guys, which are awesome. So that's the start message. And 201 is interesting. So message ID 201 is how the ECU goes and communicates error states to the dashboard. So if you set one of these bytes or bits, what will happen is the check engine light will come on, and it will complain at you with whatever error code is there for that message. Now, the other cool thing about this is if you set this to all Fs, the check engine light comes on, it rolls through every single error code, and it also unsets the service light, which is handy. So now we no longer need the Ducati factory diagnostic equipment because we have a CAN bus fuzzer. So did it work? Did all of this work? Yeah, it worked awesome. This whole thing was a little bit misleading. The factory ECU hasn't been in this bike for a long time. I've put about like 3,000 or 4,000 kilometers on this setup since, and yeah, it works great as far as reverse engineering the factory protocols and making something new go and communicate with the black box via CAN bus. Totally viable. So with that, we can move on to factory ECU reversing. Now, what I want to do with this is I want to go and pull out the fuel map and the ignition table. Now, the reason I want to do that is these two bits of data are what the ECU uses to determine your fuel load and to determine how much ignition advance to put into your engine. These two things are like the fundamental building blocks of your tune. If you want to go and change your engine behavior, these are the things that you're going to be changing. So Ben did a great job of explaining all the hardware hacking stuff, so I'm not going to. Basically, you open up the ECU, you figure out the chip, it's an S12X chip, you spend $16 on AliExpress for an S12X BDM debug interface, you probe it with PC byte probes, and then you go and load it up in USBDM and dump the firmware. That's it, easy. So now we have another problem. Now we have 256K of ECU firmware, and we need to go and decode this binary information into something that's actually usable for us. The correct way to do this would be to go and load up the firmware in Ghidra or IDA or your reverse engineering suite of choice and read the disassembly, figure out how everything works and like the logic behind the ECU and really get an understanding for it. But I just want a fuel and ignition table. I don't really want to do all of that. So I'm going to go and share a trick with you, which is using GNU plot for firmware reverse engineering. So what you do is you take that 256K and you put it in a 3D map, and it looks like that. The theory behind this trick is that code segments within the firmware are going to have high entropy, meaning that they're going to have a wider array of bytes between 0, 0, and FF, and they're not going to follow any kind of mathematically predefined structure, right? But fuel maps and ignition tables and structured data are going to follow some kind of a pattern. And if you look at this whole 256K of the Flash firmware, you can see those two valleys. Those are two sets of fuel maps. Now, the other thing you can do is go and set the Y range to limit your view, and then use the scroll wheel to kind of go back and forth. So we got program code, program code, program code, more program code, even more program code. Now it's starting to look interesting, okay? And here we go. Now we have some really structured data. So this is our fuel map, but it doesn't look like a fuel map. And the reason it doesn't look like a fuel map yet is because we don't know the dimensions of that array. We know it's structured data, but we don't know what kind of structure it is. And this is where the next GNU plot trick comes in. What we want to do is we want to note that offset and then open it in 2D view and have a look. So if you see this line, what we have is we have a set of values that's generally increasing before it resets, and then it starts generally increasing again, and then it resets. And this is a really good thing to see because it follows the general pattern that we'd expect for both a fuel table and an ignition table. As engine RPM increases, we generally need more fuel and generally need more spark advance. Now, to determine one of the dimensions of that array, we can just do it right here. We just count the peaks. And in this case, we have 30 peaks, so we know that that array is 30 by something. Next, we can open this up in a hex editor, and it looks like this. These are 16-bit unsigned integers, and we want to look at that pattern and see when it resets. So how many integers do we have before it goes from a high value to a low value? And in this case, we have 20, right? You can see here it goes from 4EB3 to 1B33. That's our reset point. Our map dimensions are 20 by 30. Plug that back into GNU plot. We have our fuel map. We have our ignition table. We're not done yet. There's not enough information in this to load it into an ECU. So what we need is we need to figure out what the X and Y breakpoints are. So right now it's labeled 0 to 30 and 0 to 20, which doesn't help us because those aren't RPM values and those are not throttle position values. We need to figure out what those breakpoints are. Now we know that it's going to be 30 RPM values, and we know there's going to be 20 throttle position values, and that helps us. So we jump back into 2D view, and we find these two bits of data that follow the general structure that we would be expecting. So for RPM, we have 30 integers that are generally increasing linearly, and for throttle position, we have a logarithmic scale there. The throttle position is logarithmic just because of some of the physics of how individual throttle bodies work. If you used a linear scale for an engine that's running ITBs, then part throttle cruise is just a mess. So you need more tuning granularity down low. Now we have enough information to punch this all back into the max ECU, and I really like this view because they adjust the scale depending on where you set your axis breakpoints. And we can start the bike with this, right? What I really like about this, though, is you can see where the factory tuners wanted more granularity, like they wanted more control from that 3,500 to 5,000 RPM range, whereas higher up and at high throttle openings especially, they didn't need as much tuning granularity to go and make the engine function correctly. And that's just interesting insight into how factory tuning works for me. So did it work? Sort of. I mean, it kind of worked. To be fair, the ignition table trick worked awesome. That was like spot on straight out of the gate. The only changes that I made to the ignition table are because I wanted the ignition behavior to be different in some way. The fuel map was within 5 to 10% of where it needed to be across most of the map, which is okay. I mean, not great, but it's pretty good. There's no free lunches in motorsports, right? So what I did here is I went and gave up time hardware hacking and pulling out things from firmware files and so on and so forth, so I didn't have to go and spend that time building base maps out from scratch. Professional tuners have been building base maps from scratch forever, since EFI was first invented. So you don't really need to do any of this. But for me, at least, without direct access to a dyno, it was a useful trick to get this up and running and on the road faster. So we have a bunch of time left, which is nice. So we've got some bonus rounds. Let's talk about computer hacking. Okay, so I've included this because I know that if I didn't put something like this in here, some like gatekeeping InfoSec chud was going to come up to me after this and be like, that talk wasn't even about real hacking. So let's talk about some software vulnerabilities, I guess. And I want to talk about some software vulnerabilities in the Max ECU, or at least some bugs in the Max ECU itself. Now, the Max ECU implements this feature called an ECU lock. And what it lets you do is it lets you set a password on your ECU, and then you can protect various tables so that you can't go and get them back out without entering this code. Now, the pretense for this is that if you have a commodity engine or something that's tuned often, like say like a Honda K series or a 2JZ or an LS, something along those lines, and you take your car or bike or whatever to the tuner, they don't want you sharing their sweet LS2 with the truck cam ignition map with other people, so they'll go and lock down your ECU. And now if you want to go and modify that further, you have to call your tuner and beg them for a password and so on and so forth. Like, the whole pretense of this talk was about control, and having somebody go and arbitrarily take that away is not cool with me, so we need to find a way around this. Luckily, I can think of 5 ways to get around this. But we don't have time to talk about 5 ways to get around this. We have time to talk about 1. So we're going to talk about a known plain text attack. And the way that we're going to go and execute that is when you hit that little save icon, if your ECU is password protected, it gets saved as this Max ECU encrypted save file. So let's take a bit of a closer look at that and try and figure out how that actually works. Okay, it works. All right, so here's what I've got. I've got the encrypted Max ECU save, and I've got the plain text Max ECU save here. So let's take a look at the plain text. This is XML data, right? Which is, for a known plain text attack, that's pretty good, because we know that at least this part of the file is always going to remain relatively static, right? So let's do the same thing with the encrypted save, and we have base64 encoded data. So maybe this is just base64 encoded, and we can all go home. Whoops. Nope, it is binary. So that's a problem. So let's move this off to ciphertext.bin. So this ciphertext is now what we're trying to decrypt. So we'll take a look at that in XXD again. And just kind of scroll through it, get some vibes. Going and staring at screens of ciphertext shouldn't give you anything, but sometimes it do. So what I'm looking for here is like repeating patterns of some kind, or just anything. Like see, at Y, HMV, TXAD. Okay, here we go. This is weird. OXQE, OXQE, that repeats. So let's grep that up. So XXD ciphertext, grep this guy. All right, it's repeating. That shouldn't really happen. That shouldn't happen in a ciphertext. So what I suspect is that they're using XOR. Now, so the thing with XOR is if you go and XOR the plain text with the ciphertext, you get the key. So that's what we're going to try, and we're going to see if that works. So so I have this XOR function in bash, so we're going to source this, and then I'm going to read the plain text first. I'm going to read 32 bytes of the plain text, and I'm going to spit that out hex encoded. That's what we're doing here, okay? And then I'm going to do the same thing for the ciphertext. Right? 32 bytes, 32 bytes. And now I can use my XOR function to XOR these two, and we will decode it back from hex. And that's interesting. We have a repeating pattern, right? We have 5VUE EXQY, 5VUE EXQY. So what we've got here is a 16-byte rolling XOR. And we want to go and confirm that. So echo -n, into a key file. We can then get the hex value for that. And now to confirm that our assumptions here are accurate, what I want to do is I want to read another 16 bytes of the ciphertext, but I want to do so on some other 16-byte boundary, so any number that's divisible cleanly by 16, right? So let's skip 128. Right? Whoops. There we go. So we want to XOR our key with our arbitrary 16-byte chunk. Pull this out, decode it back from hex, and yeah, this is plain text. Okay? So what we have is a 16-byte rolling XOR. Now, I'm going to automate this. I've written this decrypt.c function file, right? And all we've got is a while loop that reads from standard in, and it goes and XORs each byte with the key, just rolls over. So we'll run that, decryptor, pass it the key, and we push in the ciphertext thusly. There we go. There's our plain text tune file. Now, we don't really want to be messing with file formats and putting things into and out of MaxECU and all that sort of stuff, so instead, we can just script for the password, and in this case, it is set to Patricia. So we can now get our totally sweet LS2 with a truck cam ignition table out and share it with all our sweet LS2 with a truck cam buddies. Okay. All right. Okay, so basically, XOR with short keys is bad, and you shouldn't use it. But what was the point of all of this? And I don't even know anymore. I think all I really wanted to get out of this talk was to hopefully inspire maybe like just a few of you to go and start looking at your vehicles a little bit closer. You know, like start having a bit of a play. All this tooling, cheap. Everything is in Linux kernel and socket can utils and stuff like that. So start having a little bit of a play, start seeing what you can find, and you know, maybe you can figure out your own stuff. And you don't need to worry too much about not being very good at it, because like being bad at something is sort of the first step to being kind of okay at it, and that's totally fine. This learning curve is steep, and it's especially steep depending on your background. Like if you're coming at this from the perspective of screwdrivers and hammers and carburetors and points, then this stuff is complicated as fuck. But if you're coming at it from the perspective of all the other shit that we have to deal with in IT and the levels of complexity, it's reasonably straightforward. So it depends on your mindset and how you want to apply that. Now, I didn't do this alone. I had a lot of help, and people were very nice to me about it, and that was awesome. I went and picked up that ECU from Jeff at NZ Wiring, and Jeff is amazing. I sent him like screens of emails with questions that no one would reasonably expect Jeff to answer, and he did an outstanding job. And like we even managed, like I got in touch with the MaxECU developers, and they rule. So what I figured out was that because this is an uneven fire engine, right? You don't need a camshaft sensor to do fully sequential ignition and fueling anymore, because the crankshaft kinematics are uneven. If you do real-time crank analysis, you don't need a cam sensor anymore. So I wrote all of this up with a bunch of graphs, and I sent it off to Anders, I think, at MaxECU, and he went and he handed over like a new firmware the next week that had this prototype function enabled, and it works. If you want to go and not use a sync sensor on anything that's odd fire or V-twin or single cylinder now, like we did that, and I'm just some guy in New Zealand. That's amazing. Like, so yeah, I mean, like, Jeff rules, the MaxECU devs rule, like, all of this was great, and I was like really blown away by how forthcoming people were with information and wanting to actually go and get stuff done, right? And I think if you get involved with this sort of stuff, you'll be really surprised at how nice and approachable all these people are. And that's the great thing, because there are questions. There are important questions, right? Like, how much power can you really pull out of a Nissan Leaf engine? And you might be the right person to answer those questions. Thank you.
always rely on Dennis to close us out with a fantastic presentation. So thank you. That's it for the con. We want to go through and do a few thank yous before we release you all into the wild. So if you bear with us for just a bit. I'm actually not sure if, yeah, there we go. So we're just going to go through a bit of a technical crew debriefing, say some thank yous, give some shout outs to our sponsors. We've got some prizes as well. So we'll go ahead and get started. Where's Bogan? Somewhere around here. Come on, yeah, he's coming up stage. First we want to say thank you to the people who helped design the theme of the conference. So a special shout out to Pepper Raccoon, who might be somewhere out there. And also, right here, front row. So Pepper was very patient, very, very patient with us as we worked 2 years on the art and design for this conference, and also juggled a whole bunch of stuff while also running her own art show. So we appreciate her very, very much. And also a special thank you to Rack Attack, who helped us pull together the website. So a special shout out and thank you to Rack Attack. Another special thank you out to D-Rock and Alzi. A lot of the, some of the tweets that we've put out, to the QAing of the sticker to make sure that I didn't muck something up, they all helped tremendously. So a special shout out to them for all of their infinite knowledge around space in general. So yeah, round of applause for them.
Thank you to the Good Eggs. So we had a bunch of people email in and just want to donate tickets to students and unwaged people. So thanks to the Good Eggs.
Yeah. I think especially, like, we had someone donate enough money to send about 30 students from Unitech from around the country, and as well as a bunch of people who perhaps had to pull out last minute and donated their tickets to some students or unwaged. So really, really awesome.
Thanks to the speakers who submitted their talks. We accepted them, reviewed them all, and then they had to wait a year to give the talk. So.
Yeah. So thank you very much.
And thanks to all of you for patiently waiting 2 years for this con to happen. Right, sponsors. So we have weird furry animals in the sponsor categories, and it's unclear who gave the most money, but it is an order of who gave the most money. So the Emperor Tamarins are the richest. Aura Information Security, CyberCX, Spark, and Google. Thank you heaps. The Norwegian Forest Cats.
I think that's my favorite sponsorship tier, but
Yeah.
it's also just super adorable.
Very floofy. Exenic, InfoSec, Pulse Security, the Instillery, and Cyber Research. Thank you. The Mary River Turtle sponsors. Canva, Elastic.co, Redshield, Blacklock, Galar Cyber. Did I pronounce it right? Yep.
Yes.
Thank you.
All
Yeah.
right. Sorry.
Sorry.
Sorry. Yeah. And PrivSec. Thank you. And the very cute pygmy raccoon, Mindshift, Trenchant, and Arachne Digital.
So last year, when obviously pandemic things were going on, we decided, we spent actually, our crew chat turned into really just a sharing of food photos chat. I think it's called actually Loud Chat, share your food pics. Perhaps something a little bit more vulgar than that. But we decided, why not pull together a community cookbook? Why not? That sounds like a great idea. So we did, and we want to say a special thanks to Internet and Zed, who helped sponsor it and also subsidize, I think, a good chunk of the cookbook, actually.
Yeah, it's not cheap to make your own book. That turns out the cost per book was around $110 to produce, and so Internet made it affordable for it, because I didn't think anyone want to pay $120 for a photo of Metal Storm face stuck on top of Julia Child. But yeah.
So cheers.
It's the quality of your Photoshop that's poor.
Prizes. Offensive Security gave us a bunch of prizes for the Hack and Learn, which we'll talk about shortly. And the lovely people from SiteHost look after all our hosting requirements for free.
So Hal, do you want to come up on stage and talk us through what happened? Who participated in Hal? Show of cheers, loud noises.
Yeah.
Here we go.
Awesome, thank you. First of all, I'm going to apologize about the voice. Most people get up here and talk for 1 hour. We've been talking for 2 days. So yeah, croaky voice. Second of all, I'm going to keep this real quick because I know you're all hungry. Where's the button? Cool. Yeah, sweet. All right, let's go. All right, quickly about us. Next time, I swear I'm going to get the fonts right. So I'm Dylan, or also known as Narcosia. I build stuff. This is Shofi. Also, he is insane. He breaks stuff. And we have GIF or GIF, depending on which side of the argument you're on there. And big shout out to him because he helped us out in the last couple of weeks just to set up a couple of extra VMs. Really quickly about us, we started Hack and Learn in 2018, basically trying to give back to the community and educate the next generation of InfoSec professionals and uplift your current capabilities and encourage enthusiasts to actually enter the field. We've built a practical environment, so people come in, bring their laptops and connect into our infrastructure. And then, we do attack and defense scenarios in a CTF-like environment. Pre-COVID, we were running these once a month up in Auckland and expanding it out to Wellington and Christchurch. COVID kind of put everything on the back burner, like it did for everyone. But yeah, we do have 420 members on Meetup and a Slack channel, so if you do want to get involved, hit us up. And we do run the occasional ad hoc CTF for businesses, unis, and of course Kawaiicon. They're awesome. Very quickly, this is us doing what we do before COVID. And just quickly, we have had a pretty epic road trip down here. So this is us getting ready. This is all of our gear in the back of a trailer. I just spent a couple of days at my mum's house to look after the dogs on a farm. And so that is the servers in the back of the car, hooked up on the cigarette lighter with an Ethernet cable out, and it's on rural internet, which I think is slightly faster than Sydney internet. And that's so Shofi can actually connect in. And lastly, down the bottom is me outside at 6 o'clock on Thursday night, trying to set up the thing because everything broke. But yeah, we got it working again, so that's awesome. Very quickly, many late nights, big road trip. We run clustered KVM on Ubuntu with a bunch of janky bash scripts. This time we had multiple network zones, Active Directory environment that Shofi has been so awesome to set up. Some objective-based missions, so we're trying to unleash the hacktivists and get the best defacement. Some enterprise access stuff, exfiltrate the data. We had a total of 58 flags, 1,450 points, and 45 participants. I'm going to quickly hand over to Shofi, who's going to talk about the network.
Kia ora, everyone. This is Shofi. So just a super quick rundown on how things went. This is just a rough graph. We are pretty bad at doing Photoshops and designing. You have to do with, make do with this. Segregated networks, we have multiple zones. People have done pretty well. They broke into pretty much the second network in the first day. And then second day is pretty much domain admin midday. Can you go to the next slide? This is just a rough overview of the type of attacks that they could run. And we tried to make it interconnected so that you could go in one box, hop in, hop out, get information, and come back to get domain admin. That's pretty much how the environment was set up. I'll quickly move it back, hand it over to Dylan for
Yeah, sure.
some
So
pricing.
let's go and announce the winners. So the first one that we have, who is our best hacking learner, who actually went through and actually, is new to hacking and kind of got the spirit of hack and learn. So I want to invite Stella up to stage. So fantastic work. If you're here. There we go, cool. So in the spirit of hack and learn, and thank you to Kawaiicon and Offensive Security, we are going to give the top prize to Stella because we really want to kickstart your career in penetration testing. So go forth, keep hacking and learning. So yeah, congratulations, Stella, for doing so well over the CTF. So that's awesome, thank you. Cool.
One of the objectives was to deface a website and put your picture up, whatever you want to do. So I would like to thank Best Hacktivist, which is Team Google. Round of claps for Team Google.
Okay, so the first team who got full domain admin and installed the skeleton key were Joker, and they're from Spark. So congratulations, Joker. I think we have another offensive security prize for you, wherever you are. Jokers, I think you're down there. Give us a wave. Awesome.
We'd also like to encourage or appreciate the second place winner for the CTF, which is Team Google again. The folks over there, I believe, raise your hand. Get a clap.
So Team Google, we know you've got all the certs and everything, so you really don't need any more certs. So we are giving you the one thing you don't have, and that is the Kawaiicon cookbook. So yeah, awesome, congratulations. Okay, and finally, the people who picked up the most votes in the AE35 unit were the Farming Simulator Next Gen. So congratulations to Gordo and Chat. They have done a fantastic job and they won the CTF overall, so put your hands up, wave. The other thing that Gordo and Chat want to do is to donate their prize to the next Hack and Learner. So if you've got, if you're a learner and you're going to get value out of learning pen testing, come talk to us afterwards. Because thank you very much to Gordo from Cybermarket and Chat from IG for actually donating this. That's awesome, keeping the spirit of hack and learn. So I love it. Yeah, come talk to me afterwards. Okay, last but not least, here's a quick snap of the scores. So yeah, we had a possible of 1,450 points, and we got 785 for Farming Sim. So awesome work, and Google close behind. Lastly, we have put a substantial amount of time and effort into setting up our infrastructure. We've relied on lots of donations of unwanted electronics, and we've made a whole bunch of Franken servers. And we do it to give back to the community, and we want to grow. So we are actively looking for sponsors to help us out because we want to take this to universities and high schools and actually get this around the country. So if you do want to help us out, please get in contact with us, and let's take Hack and Learn to the next level. And last but not least, thank you to Shofi and thank you to the whole Kawaiicon crew for having us. It's been awesome.
Thanks a lot.
Thank you.
That was great.
Awesome. Locksport, where are you? Somewhere. Logan, Sam. Are we presenting for you? Cool. Someone else want to hold this? Well, cool. So, Locksport, round of applause or cheers for those of you who actually played around with something on the Locksport table. Yeah. Cool. So, so this year they were running a competition, and they had a total of 23 competitors, a total of 103 competitive opens, and a total of 3 people stuck in handcuffs who have hopefully been saved and aren't still handcuffed to something. And a special thank you out to Sam. I think, no, is Sam up there? Where's Sam? Sam's gone. Well, thank you to Sam Shoot for all of the donation of a lot of the kit and stuff that you all used on the table. So we'll go through the prizes.
Lowell Sport third place is Darren B with 8 opens.
You want to come on up? Do we have prizes?
No.
Oh, wait, no, we don't have prizes. Round of applause, sorry, for Darren. And I think second place ended up being a bit of a tiebreaker. So congratulations to Artemis, who got 10 opens.
And Mike in first place with 12 opens.
So cheers over to Logan and Sam, who ran the Luxport table for us this year. Who one of them is up there, so clap for that guy. Next up, we got some prizes. So one of the original prizes, how did the original book of... Yeah, so one of the original prizes that kind of circulates around to the best speaker is one that we won't open, but it's the Book of Skin Diseases. Yeah, look at that fleshy cover. Fantastic. And we've grown up a lot, so instead of opening the book, we'll just, this is the evidence of what is inside. Atlas of the commoner skin diseases. That prize, actually, goes to Izzy, right? Yeah, come on up, Izzy, for best talk.
So Shero has also made some, Grace, has made some beautiful crafts. I wouldn't call them horrible. We've got it written down as horrible craft on our sheet here, but it's actually wonderful. If you can hold that up to the camera, Shero.
Beautiful.
A hashtag.
Like move it around a little bit, sparkles, it's glittered. Yeah, beautiful. So congratulations, Izzy. Yeah, and Izzy has a 2-year-old, so maybe we'll keep that book on a high shelf so she doesn't open it accidentally. Sorry, some of these are out of order. Next prize that we wanted to give out is to the first person to let us know that they decoded the sticker. So Andrew Chen, come on up.
So Andrew gets a copy of the cookbook and a minor horrible craft.
Minor. And also, so the sticker, for those of you who went through and decoded it, is based off of the Perseverance rover parachute. So our sticker spells out "Dare Cute Things." But Andrew also pointed out that I made a typo on stickers that I printed out 2,000 times. So the coordinates aren't exactly right, but it's close enough. So congratulations, Andrew. Next, we have the speaker who is most deserving of a holiday. So, Patrick, come on up.
So Patrick gets a cookbook, a Lego kakapo, which is very cool.
So you can enjoy your unemployment by building Lego.
And a minor horrible craft, so he can go to the moon.
Beautiful. Oh, congrats, Patrick. Next, we have a Craft Crimes prize for the person who does craft crimes, which is Alex. And the prize for this is the craft crime that he himself made and brought upon this universe. And here is some photo evidence of this craft crime being committed. So congratulations to Alex. And then the last prize, right? The last one to give out is our best news speaker.
Oh no, we gave her.
No, I know, it's going to be the next one. Best new speaker, Ron. Are you still here? Come on up. So when I was listening to Ron's talk, I was actually quite surprised afterwards that someone actually pointed out that this was his first talk. So congratulations. Cool. And then we're just going to go through some stats. So this is the first time we live streamed the con. And I think in total we got yesterday at least up to 3,440 views, but about 330 concurrent views at one time. And a special shout out to MJ and the rest of the AV crew for pulling that all together. So thanks heaps to them. Next we have, 7 new crew. So I don't know, shadow crew, step forward and take maybe we'll get some sparkle action. But the con really came together by, 7 people kind of stepping up and helping the rest of our crew. So special shout out to the shadow crew. Yeah. We have 1 junior crew member who is hopefully sleeping at the moment. But, and first baby on stage. So, yeah, I had a baby while organizing this conference, which is not something I would really recommend. So, yeah, first time for everything. First time speakers this year. So in addition to Ron, we also had Kento and Matt as well. So congratulations to them for their very first conference talk. And our first 4-legged speaker. When we had our AV call, I don't think the AV team had dealt with dog wrangling before. So that was a new thing to add to our health and safety risk register. Yeah, first dog. So thanks to Peter, Wickett, and Jed for that fun health and safety experience. To actually make this con happen, we had to reschedule the venue twice, which, yeah, fisticuffs were had. It took us quite a while, and this is why we have the con smack bang in the start of, or in the middle of the year and at the start of winter, but we had to end up rescheduling twice, which is also not fun. We also had masks, but we didn't give out too many, so please do take one when you leave the venue. Otherwise, yeah, 10, maybe one for everyone on your team. And we also gave out quite a few rat tests, but we also have plenty of those, so please do take them. But a special thanks to Ministry of Health, who just kind of gave us those rat tests to give out to people so that people can take them if they need them. So special thank you to MOH. And especially with, the COVID plan that we had in place, maybe a PG way to refer to some of the emails that we got are sasshole emails.
Can I speak to the manager emails?
Yeah, seriously. Which were quite hilarious, and thank you to Vex for actually stepping in as our manager when those came through. But we only had about 14. So 14 out of, 1,700 tickets that were sold actually isn't that bad. So thank you for not sending, mean emails. So, yay. And lastly, volunteers who are going to come on stage now. There's heaps. It's like a train of volunteers. But our conference can't run without volunteers, especially this year. I'm sure it wasn't, it's probably a bit of a nerve-wracking job working the door and handing out and checking vaccine passports and handing out wristbands. And the whole con was just really different this year. So we needed all of the help that we could get. And it's thanks to all of the volunteers that really kind of made this con happen and made it successful. So scoot on in, come on. Fantastic. So I'm going to step aside, but volunteers, take a bow, get some sparkles. And if you see a volunteer later and you want to give them a special thank you, buy them a beer, buy them a soda, and thank them for all of the stuff that they put up with for the past 2 days. And that's it. That's Kawaiicon 2. So, yeah. Oh, AV crew. Yeah, thank you to AV crew. Are we able to get some? No? Come on out. Yeah. And also a special shout out to Madman there in the back as well. That's Kawaiicon. Cool. Yeah. We'll see you later.
Hey, I'd like to do one last shout out. So we had COVID this year. We had a whole bunch of COVID processes. We had a whole lot of checking as you came in the door. You guys have all been awesome. I know this whole thing has been, it's difficult. We've had so few problems. It's been amazing. You guys rock. We've got the best hackers in the world, man.
So yeah, go out there and have fun. See y'all later. Oh wait, sorry. Stop.
We'll do a karakiri as well, thank you.
Oh, cheers.
It's the same as yesterday, if you remember it. I didn't, clearly. Kawha kai rei te tapu, kia watia atiara, kia tuniki whakataha e, kia tuniki whakataha e, huye, tai iki e. Thanks.